Hello, my name is Zandile and welcome to Mastering Function. So what we're going to do is I'm going to tell you how this video is going to be broken down so that you can understand how to do everything, right? So this video is going to be broken down into being 4 subtopics, right? So it's going to be linear function, it's going to be the quadratic function, also known as the parabola. Then it's going to be the hyperbola function. Then it's going to be the exponential function. And after breaking down into that 4 section, each subtopic, which is the linear, the quadratic, and the hyperbola and the exponential, is going to be broken down into being 2 parts, right? So how I'm going to break it down is that, for example, for the linear one, we're going to start with the nodes first, where I explain everything that's important, breaking it down from the basics, meaning from grade 10 till grade 12, things that you need to do. Then after doing the notes, then we're going to move to what? We're going to move to the questions. Where the questions that I use, I'm going to use questions from past papers. So I'm going to do that for all the remaining, 3 subtopics, which is quadratic, hyperbola, and exponential graph. Then another thing that I wanted to say is that this video is long. And since it's long, I'm going to break down into being chapters. So at the bottom, there's going to be chapters so that if you want to just focus on quadratic, you can just click on the chapter and go straight to quadratic. Or if you just want to do the questions for the topic, you can just go straight to that topic, right? So this is what I wanted to say. So now let's start with linear. So now we're doing linear functions, right? And we're going to start with the nodes. So how I'm going to do this video when it comes to function is that I'm going to switch from the nodes to the graphing calculator. I might leave a link so that you can play with it. Actually, I'm going to leave a link so that you can play with it. The reason why is that with functions, I feel like it's more easier when you see it visually on how certain things affect certain components in the function, right? So the first thing that we're going to do is we're going to go straight to the nodes. Then if I move from side to side, is that because I want to explain a certain concept, right? So the first thing that you need to understand is that we need to know what's a mother graph. So the mother graph is this one. So the first point is the mother graph. And this is how the mother graph is going to be. Y is equals to X. The reason why I call it a mother graph is that everything happens comparison to this, right? Then now we're going to move to what? The general form of the function. So this is the general form, this is where you test it half of the time. So the general form is going to be, it's written in 2 ways, right? It's this one, which is Y is equals to mx plus c, right? Or it's going to be written as y is equals to ax plus q. The m and a is the same thing, how it affects the graph, and the c and the q is the same thing on how it affects the graph, right? So now let's move up so we can start with the effect of a and ac and aq. MC and aq, that's what I want to say. So what I'm going to do is I'm just going to write it in a pink color, just the function, right? So y is equals to mx plus c slash y is equals to ax plus q, right? Then I'm just going to put it here. Then we're going to be talking about the effect of each, right? So the first one is going to be what? It's going to be the effect of m or slash the effect of a. So before I write the notes on what it does, let's go to the graphing calculator so that you can see how a affects the graph, right? So let's go here. We're going to first have the mother graph, which is y is equals to x. That's the mother graph. So it's the one in white, it's the one in green. Not normally, A affects first the slope, this is not what I want to show you guys, but it affects the slope on how steep or how shallow the slope is going to be, right? But here, what's very important that you need to understand is that how the graph behaves when A is positive and when A is what is negative. So in our mother graph, right, so that you guys can see it, I'm going to make our A a -2. Let's start with the -2. So if I say y is equals to -2x, where -2 is our A or our M, do you see what happens? Is the graph changes from being what? From going from the first and the third quadrant, but it goes from the what? From the second and the fourth quadrant, right? But when we say y is equals to what? +2, right? Do you see where it does? It goes from the what? From the first and third quadrant. So when it's positive, we say the fact that the graph is increasing. Remember that? And increasing means the fact that it's from the first and the third quadrant. When it's negative, the graph is what is decreasing, right? Meaning it's from the what? The third and fourth quadrant. I hope I made sense. So now, right, let's go to the notes and fill in what is the effect of A, right? So A, first you need to understand the fact that, let me just write a point here. A, you need to understand the fact that A, M, or A is the gradient, right, of the graph, Remember that. A or M is the gradient of the graph, right? And another way besides this on how to calculate A is that M, right, is equals to, the gradient is the change of y divided the change of x, meaning it's the same as what? As y2 minus y1 divided by x2 minus x1. Meaning if you have 2 points, you can find the gradient by using this formula. Okay, that's okay. Now let's talk about when A is positive, right? So when M, right, I'm just going to say M. You know the fact that M and A is the same thing, right? When M is positive, which is greater than 0, this greater than 0 means the fact that M is positive, right? The graph is going to be what? The graph is going to be increasing. And this is how the shape, I said the fact that it goes from the first and third quadrant. See? Just like that. Then when M, right, is less than 0, meaning M is negative. The graph is what is decreasing. Meaning it goes from what? The shape goes from the second and fourth quadrant. Remember again that M or A gives us the shape. So in bracket, it gives us the shape. So this is what it determines. This is what A does. It determines us the shape, and we know whether the graph is increasing or decreasing. I hope that made sense. Then there's a situation, right, when M is equals to 0. When M is equals to 0, meaning our function now, right, what's going to happen is that since y is equals to mx plus c, is that here at mx, there's not going to be, we don't have a gradient. Therefore, our function is going to be y is equals to what? It's going to be equals to c. Right? So if y is equals to c, this is how the sketch is going to be. It's going to be, this is going to be our c. Let me just do it in another color. This point here is going to be, that's going to be your point C. So that's how the graph is. I hope I didn't confuse everyone and everyone is on the same page. So this is the effect of what? This is the effect of M/A. So now let's move to the effect of C and Q. As you know, we need to go to the graphing calculator, right? So Q, I'm just gonna erase this 2, because that's what we're gonna need to show our mother graph. So we see the fact that our mother graph is still the red one, right? So what I'm gonna do is same thing, is that we're gonna see when Q is positive what happens, and when Q is negative happens. The value that I put really doesn't matter. Just look at what happens to the red graph, right? So let's say the fact that I pick Q as being -2. Or let me start with positive. I pick Q to be positive Q. So if I say Y is equals to, remember the fact that there isn't any, A is going to be 1. So we're going to take A from our mother graph, which is +1. If I say X, then Q is the one that you add after, right? And I say +2. Do you see what happened? Is that the graph from here, I'm just going to show it from here, right? From the point 0, 0, it moved 2 units up. Do you see? Then it basically moves up. Do you see that? And you're going to see that. See, from here, it moved to this point. Do you see that? So meaning when Q is positive, it moves up 2 units up, whatever the Q value is, right? Then now, if I make my Q negative, if I say Y is equals to X, right, minus 2. Do you see what happens? From here, 0, it's going to move 2 units down, which is the green one, right? So what do we know? We know that Q, right, moves the graph up and down. So that's what we know. So we know the fact that Q, right, shifts the graph up and down. Up and down, up in Q. Up and down, right? So, and another thing is, if we go back to the graphing calculator, what do we see? We also see, which is I'm going to talk more about it, we see the fact that after moving it up and down, this point that it moves up, right, is going to be what? This Q is always going to be our y-intercept. See? Our Q or C is going to be always our y-intercept. So also, our Q, C/Q is the y-intercept. Right? Another thing that I want to talk about is that the shifting of up and down of Q is the same throughout everything that we're going to do. Meaning, even in quadratic, Q behaves the same way, right? It moves the graph up and down. In hyperbola, Q behaves the same way. It moves the graph up and down, meaning there's some little things that are going to be tweaked, but like how the behavior is the same throughout each graph, right? Then C is also the y-intercept, right? So remember the fact that C or Q is also the y-intercept, right? So now another thing that we need to write down is that when C, right, or Q is greater than 0, meaning it's positive, what happens? The graph, remember positive meaning it moves up, the graph moves Q or C or Q units up, right? Meaning the fact that if C or Q is 3, it's going to move 3 units up. That's why I'm saying C or Q units up. Whatever that number Q is, it's going to move up. Then when C/Q is what? Is less than 0, meaning it's negative, right? The graph moves. The graph moves C or Q units down, right? That's what you need to know. And again, since it's the y-intercept, right? The y-intercept, to write the coordinate, I'm just going to write it here. It's going to be 0, then the C coordinate or Q coordinate, which is the same. C or Q is the same thing. So this is how you would write the coordinate. Then another thing is that when we have C being equals to what? Equals to 0, right? So when C is equals to 0, meaning this equation does not have this 2. It's just going to be y is equals to mx plus mx, or it's going to be y is equals to what? To ax, right? So that's what it is. So I hope I didn't confuse you with C or Q again, and I hope everything makes sense so far. So now let's move to the topic of domain and range, right? So we're going to talk about domain and range of a linear function. So the first thing that you need to understand is you need to understand what is a domain and what is a range. So let's start with domain. So domain, right? It's what? It's all x values in the function, right? Then range is all y values in the function. All right, so that's domain and that's range. So when we're dealing with linear, we have how many cases? We're going to have 2 cases on how to write the domain and range. The first case is when you have a restriction, and the other case is when you don't have a restriction. So I want to show you both cases so when you get to the test, you know on how to answer such questions, right? So now let's move to case 1. And this is when we don't, this is without, right? Without restriction. So let's say, for example, they give you this function. They say f of x, right, is equals to x. And they say find domain and range, right? So how you gonna write, and this is the case always, guys, can I stress this? Always. Whether they give you a function that's fancy, like they can even give you a function like they say g of x, let me just write it in pink, g of x. If they say g of x is equals to, maybe, let me write the one that has a and thingy, negative 2x plus 6. Even if they give you something like this, right, and they didn't give you any restriction or condition on the side, this is the case of always in both situations, how you would write your domain. So your domain here, I'm going to write the one in pink. Your domain here, you're going to say domain, right? Then you're going to say x is an element of real numbers. Always, if you are not given a restriction, then your range is going to be what? It's going to be y is an element of real numbers. Case of always. Even if they give you like this, without a restriction, your domain, right, is going to be x is an element of real numbers. Then here your range is going to be the same thing. It's going to be y is an element of real numbers. If they didn't give you a restriction, which is I'm going to show you what's a restriction on the next case, this is how you write your domain and range. I hope I'm making sense, right? So this is case 1. So now let's move to case 2. And this one is with restriction, right? So this one in bracket is with restriction. So case 2 is with restriction. So I'm going to do what I did on top. I'm going to give you two situations, the black one and the pink one, right? So let's say they're giving you a function and is f of x, right, is equals to what? To x. And they give you a restriction on the side. They say x is an element of an element, right, between what? Between -1 and +1, right? Or they can write the restriction as like being this and this one, the top one and the one that I'm writing on the bottom is exactly the same thing, right? So they write it like this. So this and this is exactly the same thing. If they give you a restriction, let me put O, right? And they give you a restriction written either like this or like this, because both of them is the same thing, right? And here they give you g of x, right, which is equals to -2x plus 6, right? And they give you a restriction again of what? Of x is an element of between -1 and 1. Or they written it like this, which is -1 is greater than and equals to 1. So if it's given like this, do you see here on the side, they gave you restriction. This is what I call restrictions. This one's I call restriction. And they ask you to find the domain and range, right? So domain, right? Since they gave you your restriction in terms of x, your domain is exactly what they gave you. So your domain is going to be what? Exactly what they gave you. So it's going to be x is an element between -1 and 1, or you can write the one that's underneath if they give you the one that's underneath, right? That's your domain. Then now you need to find your range. So now to find your range, you need to solve for your range. They already gave you what? Your x. You need to take the x and substitute it to the function to get your what? Your range, right? To get your y, because of range is y's, right? So we're going to substitute for f. The first one is f -1, right? So here you're going to substitute -1, which is going to be -1, which is going to give you -1, right? Then f of what? F of 1 substituted, it's going to be what? It's going to be 1. Therefore, it's going to be 1. So here, right, our what? Our range is going to be y element between what? -1, because we solved it here, and 1, right? In this case, our range and domain are the same. So now let's move to this one, the pink one, right? So our domain, as I said, is exactly what we given. So it's going to be x is an element between what? -1 and 1, right? Then range, remember the fact that we need to what? We need to solve for the y. So we are given what? -1 and 1. So you're going to find g of 1, right? Of -1, right? Because we start there. So g of -1 is going to be equals to -2, open bracket, -1 plus 6, right? So punch that into the calculator, right? And you're gonna get g of -1 is equals to what? To 8, right? Then we need to find g of 1, right? So we need to find g of 1. So it's going to be -2, 1 plus 6, which is going to give me 4. So it's going to be what? It's going to be 4. So now we know the fact that g of -1 is 8, then g of 1 is 4. Then we're going to write and say that y is an element. Always start with the smallest number, which is in our case is 4. Then square bracket is going to be 4 in 8. Then that's how you would find your what? Your range. I hope that made sense. So remember the fact that in linear, right, to trick you is that they might put a restriction and they might say find your domain and range. And remember when they put a restriction that you need to actually solve for your range and your domain is always given. So that's that with domain and range. So now let's move to the next topic or the next section here, which is intercepts. So we have in total 2 intercepts. We have x intercepts, and we find that by letting y equals to 0, right? Then we solve for x. Then we have what we called y intercepts, and we find that by letting x equals to 0, then we solve for y. So now let me give you an example and we can solve the x and y intercept. So for example, if I'm given a function which is going to be y is equals to 2x plus 3, right? And I need to find both intercepts. Or they say find intercepts. Right? So for my y, for my x-intercept, let's start with my x-intercept. I know the fact that I need to let what? I need to let y equals to 0, right? So wherever I see y, I'm going to substitute by 0. So it's going to be 0 is equals to what? To 2x plus 3. Then I need to solve for x. So I'm going to take the 3 to the other side. So it's going to be negative 3 is equals to 2x. Divide both sides by 2. So it's going to be negative 3 divided by 2 is equals to x. So therefore, my x is equals to negative 3 over 2. Then I'm going to write it in coordinate form. So it's going to be what? Since I'm done solving, my x is going to be negative 3 divided by 2. Then remember the fact that I let my y to be 0. So here it's going to be 0. So this is the coordinate. It's going to be negative 3 divided by 2 is 0. So now solving my y-intercept. I'm going to let my x equals to 0, right? So wherever here in the function, wherever I see x, I'm going to substitute by 0. So it's going to be y is equals to what? To 2, open bracket 0, plus 3. Therefore, making my y equals to what? Equals to 3, right? Then write it in coordinate form. It's going to be what? Remember, we let x equals to 0. So it's going to be 0 and what? And 3, right? And this is what? This is your y-intercept. So that's how you solve your x and y-intercept. So now moving to sketching linear function, there is 3 parts that you need to understand or you need to have in order to sketch, right? So the first one is the sign of M or A. So the sign of M or slash A, this gives us the shape, right? Then we have number 2, which is what? Which is the intercepts. Meaning both x and y intercept, right? Intercept meaning x and y intercept, right? So that's what you need to sketch. So now for sketching, let's do an example. So let's say, for example, we have exactly what we did before finding the intercept. We have y is equals to, e.g., we have y is equals to 2x plus 3, right? So now remember the fact that we need what? We need the we need the sign because of it's going to give us the shape. So for the first one, the sign of A or M is what? So A is equals to what? Is this one is equals to 2. 2 is what? Is greater than 0, meaning it's positive, meaning the shape is going to be what? From the first and the third quadrant. So this is the shape of the function, right? Then 2, we calculated the intercepts. Remember, our intercept, we had 2 of them. We had them as being what? As being negative 3 over 2, right? It's negative 3 over 2 and 0. This was our x-intercept, right? and our y-intercept was what? Was 0 and 3, right? So this is our y-intercepts, right? So now moving up, or let me just put it on the side because we have the information. Let's sketch the graph, right? So we know the fact that we're gonna just have a Cartesian plane like this. Obviously you would use a ruler, right? So let's put the point. Let's first put the what? Our x and y intercept. So negative 3 over 2 is what? Is the same as 1,5. So this coordinate is the same as negative 1,5 is to 0, right? So we need negative 1,5. So we know this is going to be negative 1 and this is going to be negative 2, meaning negative 1,5 is this one. I'm just going to put the dot in pink, right? Then positive 3 is going to be what? It's going to be, this is going to be 1, this is going to be 2, and this is going to be 3, meaning it's going to be, no, it's going to be, this is for the x-intercept, which is correct. So for the y-intercept is on the y-axis. Remember the fact that this is what? This is the x-axis and this is the y-axis, right? So for the y-intercept, we need to do it on the y-axis, right? So it's going to be 1, positive, remember, 2, and 3. So this is the point here, right? Then connect the 2 points together. Connect it like this. And this is going to give you what? Your sketched. Do you see the fact that this and this, the shape is the same? So you are done sketching what you call this, a linear function. And this is the steps you will take to sketch it. So now what we're going to do is we're going to move to what is an inverse function, right? Whatever that I'm going to say now applies in all the functions that we're going to do in this section or in this topic. So remember, whatever I'm going to say this, or every time when we talk about inverse, I think I'm going to make it into a chapter so that you can, like, if you forgot something, you can easily go back. But obviously in each function, there's going to be different things, right, that differs from one function to another. What you call this, involving inverse, but in general the concept is the same throughout each function. So the first thing that we need to understand is that what is an inverse function? What is an inverse function, right? Which is represented by this. So this is the representation of an inverse function, right? Is what is the intersection, is the interchange, not intersection, is the interchanging of x and y. Right? So we're interchanging x and y. That is how an inverse function is. Then the next point is that how to determine an inverse function. So now how to determine an inverse function of a linear, which is we're going to use this, y is equals to mx plus c, right? So the first thing that you're going to do is what? You're going to interchange. You're going to interchange x and y. So we know the fact that we could have this. So if we say we're going to interchange x and y, so I'm going to do that part. So we know the fact that we have y is equals to mx plus c. So wherever there is y, we're going to put x, and wherever there is x, we're going to put y. So we're going to do this. It's going to be x now is equals to what? Is equals to my plus c. See, we interchange the x and y looking from this one. Do you see? Wherever there was x, I put y, and wherever there was y, I put x. So I did that part. Then the second part, it says to make y the subject of the equation. So taking the one that we did from the first one, we're going to make what? We're going to make y subject to the formula. So we know the fact that we have x, right, is equals to my plus c. So we want to make y the subject, so we're going to take the c to the other side. So it's going to be x minus c is equals to my. Divide both sides by m, so it's going to be x minus c divided by m is equals to y. So therefore, our equation here, our inverse is going to be y is equals to x minus c divided by y, which is the same as what? As saying f to the power negative 1, which represents the what? The inverse. This represents the inverse, is equals to what? To x minus c divided by, this is m, sorry, divided by m. And this is how you would find what? The inverse function of a what? Of a linear. So now let's look at the domain and range and the intercept of what? Of an inverse. So I did a column where you have the original function, which is f of x, and what? And its inverse function, right? So what happens is that you see the fact that at the top we said what's an inverse is interchanging your x and y. So what's going to happen if this sides we have a domain, right? The domain of f of x is going to be the range of what? The range of f inverse, right? Then the range of f of x is going to be the domain, right, of f inverse, right? Then the x-intercept of f of x, right, intercept is going to be what? The y-intercept. The y-intercept of what? Of f inverse. Then the y-intercept of f of x is going to be what? The x-intercept of f inverse. To make this simple, what I'm going to do is I'm going to do an example, but for domain and range, so that you can see the fact that they actually intersect, like they actually interchanging, is that I'm going to use where we have a restriction, right? So now this is an example. It says given f of x is equals to 2x plus 3, then they give us a restriction. They say find the domain and range for f of x and f inverse. Then the second question says find the x and y intercept for f of x and f inverse. So solution, which is I'm going to do it in pink. We're going to start with the first one, right? So we're going to first start with the f of x, then we're going to move to the f inverse, right? So the domain, right? So for the first one, so this is for f of x, right? So the domain for f of x, right, is what? It's exactly what we given, the restriction. So it's going to be x is an element between -1 and 1. Then the range, remember with range, what do we need to do? We need to solve for the y, right? Because they gave us a restriction. So let's do that. We know the fact that we need to find f of -1, which is equals to it's equals to +2, -1 plus 3. Then when you punch that into the calculator, you're gonna get 1, right? Then we need to find +1 is equals to 2, open bracket 1, plus 3, which is going to give us 5. Right? It's going to give us 5. So what do we know? We know the fact that our range is going to be y, and our y is going to be between what? It's going to be between 1. Remember, here comes the smallest number, then the one that follows, which is 5. So this is our domain and range for f of x. So now let's find our domains and range for our f inverse. Let's go up to the notes. I said the fact that if we have f of x, the domain, and we want f inverse, the domain of f of x is going to become what? The range of what? Of f inverse, right? So now our domain here, right? Since we have domain here, meaning our range is going to be what? It's going to be exactly like what? Exactly like our domain of f of x, right? But the only thing that changes is the y, because of range represents y. So you're gonna say y is an element, then it's gonna be between what? It's gonna be between -1 and 1. I hope I made sense. They swap, right? Then our range becomes our domain for our f inverse. So this is gonna be domain, and it's gonna be what? Since domain is x, so you're gonna say x is an element between what? Between 1 and 5. So that's how you find the domain and range of what? Of f of x and f inverse. So now let's move on to the x and y intercept. So number 2. So for f of x, right, I've already calculated it in the previous questions, right? Is that we know the fact that our x intercept for f of x, right, x-intercept for f of x was what? Was -3/2 is to 0. Then our y-intercept, when we calculated it, was what? Was 0 and 3, right? So that's our x and y intercept. Then for f inverse, remember, our x-intercept becomes our y-intercept, meaning also the coordinate are going to change the position, right? So here, our what? Our y-intercept, remember, becomes our x-intercept. So here, our y-intercept is going to be exactly this, but they're going to swap position. They're going to swap positions, right? So it's going to be y-intercept. Then it's going to be what? It's going to be 0. So it's going to be 0. Then it's going to be -3/2. Then our x-intercept is going to be this one, remember. Right? Then they're going to swap position, so it's going to be 3 and 0. So that's how you would find your x and y intercept for f of x and f inverse. I hope you guys understand, and this topic you understand on how inverse functions operate, right? And this is like the end of the notes. So now what we're going to do is we're going to do a question from past paper. So now moving to the question, which is only one question. It says, given h of x is equals to 2x minus 3, 4, then they give you a restriction, the fact that the graph is between -2 and 4. Then they say the fact that q, which is here, I'm just going to mark it here, right? Q, the x-intercept at the graph h is q. So we know the fact that q, which is this one in pink, is what? Is the x-intercept, right? So the first question, they say determine the coordinate of q. So let's do that. We know the fact that 5.1, we know the fact that q is what? Q is the x-intercept. So we're looking for the x-intercept, right? Then we're going to say let y equals to 0. So wherever I'm going to see y or h of x, in this case, h of x equals to 0, right? So if I'm going to see h of x, I'm going to substitute by 0. So I'm going to say 0 is equals to, I'm taking it from here, right? This one is going to be h of x, which is going to be 0. H of x is 0, right? So it's going to be 0 is equals to 2x, right? Minus 3. Take the 3 to the other side. You're going to have 3 is equals to 2x. Divide both sides by 2. So it's going to be 3/2, right? is equals to x. Write that in coordinate form. It's going to be what? It's going to be 3 over 2, right? Then since we let h of x or 0 or y equals to 0, this one is going to be 0. So your coordinate is 3 over 2 is to 0, and that's your coordinate q. I hope that made sense, right? Then the second question says, write down the domain of H inverse. Remember the fact that the domain of H inverse is what? Is the range of h of x. So we first need to find the range of h of x, then we can find the domain of f of H inverse. So now we're looking for the range of h of x, right? So we're looking for the range, right? So we need to find the range. So remember the fact that we're given what? We're given a restriction of what? Of from -2, right? From -2. Imagine I'm putting a semicolon. It's between -2. It's greater than or equals to x. And greater than or equals to 4, right? So we need to find what? The range. So meaning we need to find f of -2. And we need to find h of, not f of, h of 4, right? So that when we equals that, it's going to be 2 open bracket using this equation. Where we see x, we're going to substitute by -2. So it's going to be -2 minus 3, which is we're going to get as being -7. So here, wherever we see x, right, we're going to substitute by 4. So it's going to be 2. Then it's going to be 4 minus 3 is going to be equals to what? To 5. Therefore, making our range being what? Being y is between what? Y is an element between the smallest number, which is -7, till what? Till 5. So this is our what? This is our range. But remember the fact that range is the domain for the inverse. So we answer in this question. Therefore, H inverse, right? The domain is going to be equals to what? It's going to be, we're going to just change the y into being an x. So it's going to be x is an element, then it's going to be between what? -7 and 5, right? Square bracket. You could have also written this like this. You could have also written it like this, meaning y then is between 5 and -7. And also this one, you could write it like this, being x is between 5 and -7. This one and this one is exactly the same thing. It's just that it's written in different ways. So that's how you find your domain of an inverse H. Then now it says sketch 5.3. It says sketch F inverse in your answer book. Clearly indicate the y and let's say clearly indicate the y-intercept and the endpoint. So the nice thing here is that we already have the x and y intercepts, right? Our x-intercept is what? Is this Q, the one in pink, right? And let me just change this color so that you guys can see it. And the y-intercept is this -3. Remember for H inverse, right? What do we need to do? Is that your x-intercept for f of or h of x in our case is going to become the y-intercept, right? And the y-intercept for our h of x is going to be the x-intercept. So we know what? We know the fact that the intercept, so 5.3, before we sketch, we know the fact that h of x, x-intercept, right? This is for h of x. So x-intercept, right? We have already calculated it as being Q, which was what? Which was 3 over 2 is 20, right? Then the y-intercept, it didn't tell us the coordinate, it's just a point. We know the fact that it's what? It's 0 and -3, right? So now to sketch the graph, and again, let's deal with the endpoints, right? Remember when we were finding the range, we calculated the y coordinate. So we know the fact that it's 2. So the coordinate there, when we substituted what? When we substituted -2 here, we got -7, right? So the coordinate here, by way I'm going to highlight here, right? It's going to be what? It's going to be -2 and -7, right? And the coordinate here, where I'm just going to highlight again, is going to be what? Is going to be 4, right? And 5. So again, is that we know the fact that the endpoint for h of x, right? I haven't moved to f, what you call this, h inverse, right? So we know that the endpoint is what? Is -2 and 7, -7, right? And the other one is what? Is 4 and 5, right? So now, remember the fact that h inverse is the interchanging of what? Of everything. So we know the fact that h inverse, this one is going to become my y-intercept. So the x-intercept is going to become my y-intercept. So the y-intercept here is going to be what? It's going to be, since it's 3/2 to 0, it's going to be 0 is to what? Is to 3/2, right? Then our x-intercept is going to become my y-intercept, but interchanging them. So it's going to be what? It's going to be -3, right? And 0. Then my endpoints are going to switch positions. So my two endpoints here is going to be what? It's going to be -7 and 2. And the other one is going to be what? It's going to be 5 and 4, right? So we have all the coordinates that we need to sketch the h inverse. So now let's sketch it. So now let's sketch it, right? So I'm just going to draw a Cartesian plane like this. Then I'm going to start with my x and y intercept. The first one is 3/2, right? 3/2, which is 1,5. So it's 1,5 and 0 and 1,5, which is the y-intercept. Because so we're going to go, this is y and this is x, right? So the y-intercept, I need 0 and 1,2. So I know the fact that this is going to be what? This is going to be, let me start, this is 0, so this is going to be 1, this is 1, and this is 2. So 0,5, I'm going to do it in this color, is going to be 1,5 is going to be between 1 and 2. So that's going to be what? That's going to be my y-intercept. Then my x-intercept is here on the negative x-axis. So I know the fact that this is going to be -1, right? And this is going to be -2, and this is going to be -3. So it's going to be just here, right? Then I need to plot the endpoints, right? So to plot the endpoint, it's going to be what? It's going to be -7 and it's going to be -7 and -2. Yes, let me just check. I think at yes, it's -2. It's -7 and -2 here, right? Because I just swapped the position. So I'm looking for -7 and -2. So we're going to start at -7. So it's going to be -1, -2, -3. This is -4, -5, -6, and this here is -7. So my point is -7 till what? -2. So it's going to be 1 and -2 here. It's -1 and -2. So it's going to be just right here. So I'm going to make it in yellow. That's my endpoint, right? So this is this one. Then we're going to look for 5 and 4. So we're going to go this side. The ending point is going to be, this is 1, this is 2, 3, 4, then 5, right? Then we need 4. So it's 1, 2, 3, and this is 4. So it's here, just here. So this is going to be what? My ending point. Connect the dots together. Obviously, you're going to use a ruler when you do this. Then just indicate in dotted line that this is the ending point. way I'm doing it. So this is how you would sketch. This is H inverse. So this is how you would sketch it. So now moving to 5.4, it says for which values of x will h of x be equals to H inverse. So they want us to equate h of x to H inverse, right? And calculate the x coordinate or the x value, right? So to do that, we need to first find what? H inverse, because we already given what? H of x. So we need to find H inverse. That's what we need to do, right? So to do that, we need to take H of x. Where's H of x? We need to take H of x. We know the fact that, let me just write it here in pink. H of x is equals to what? 2x minus 3, right? So that's what we know. So what I'm going to do is I'm going to write this in terms of y. So I'm going to say y, right, is equals to 2x minus 3. Then I'm going to interchange x and y. So here I'm going to say x is equals to 2y minus 3. Then I'm going to make y the subject of the formula. So it's going to be what? It's going to be x plus 3 is equals to 2y. Divide both sides by what? Divide both sides by 2. So you're going to have x plus 3, right? Divided by 2 is equals to y. Making my, then this is going to be what? This is going to be the same as saying the fact that H inverse, because of everything is in terms of what? It's in terms of, no, because of y is the subject. So it's going to be H inverse, right, is equals to x plus 3 divided by 2. So now we're done solving for what? For H inverse. So now we have H of x and H inverse. So now I can solve this. So I can say H of x is equals to what? To H inverse, right? What do we have? I know that H of x is equals to what? Is equals to 2x, right? Minus 3. Then I know H inverse is equals to x plus 3 divided by 2. Then since this side is divided, I'm going to multiply it by this side by 2. So it's going to be 2. It's going to be 2x minus 3 is equals to x plus 3. Distribute the 2. So you're going to have 4x minus 6 is equals to x plus 3, right? Then I'm going to take what? I'm going to take the x this side. I'm going to take the 6 this side. So you're going to have 4x, right? Minus 1 is equal minus x. That's what I mean. It's equals to 3 plus 6, right? This side is going to give me 3x, right? Is equals to what? Is equals to 9. Divide both sides by 3. You're going to have x is equals to 3. And that is the x value where h of x and H inverse are equals to each other. So now moving to 5.5, it says P, X, and Y is a point on the graph of H that is closest to the origin. Calculate the distance of OP, right? So I'm gonna zoom in the diagram because I want to show you on how to solve it properly. So now I have zoomed in, right? They want the length of what? They want this length that I'm going to highlight. They want this length, right? OP. That's the length that they want. What are we given as coordinate? We given Q, and also we given O, which is the origin. So the coordinate here is going to be 0, 0, right? So again, since it comes from the origin coming here, it's going to create what? A right angle triangle. So again, so we know the fact that if it's creating a right angle triangle, we can take the properties of a right angle triangle to actually calculate the length of OP, right? So let me just highlight this right angle triangle. So we know the fact that the one that I'm going to highlight in yellow, is going to be what? The right angle triangle, right? So what do we know? We know the fact that using the theorem of Pythagoras, I can find what? The length of OP. And what's another thing is that here, right, this is the x coordinate, and here the y coordinate by what? By P can be written as being what? We know the fact that we already given the function where it cuts it hits here, right, by the line, right? So the line here is what? We know the fact that the line is h of x, right, is equals to what? To 2x minus 3, which is the same as y is equals to 2x minus 3. So this y can be substituted by 2x minus 3 so that everything can be in terms of what? It can be in terms of x. So let's rewrite this p. So p here is going to be x. Then the y is going to be substituted by this, which is going to be 2x minus 3. I hope I haven't confused anyone so far, right? So knowing that, we know that using theorem of Pythagoras that this is what? This is the hypotenuse, this one. This one is the hypotenuse, right? So we know the fact that OQ squared, right? OQ squared is equals to what? Is equals to OP squared plus PQ squared. And this is what? This is theorem of Pythagoras. So knowing that, what can I do is I can just go down, find, before substituting, find individual, what you call this, OQ squared, OP squared, and PQ squared. So let's do that, right? So let's start with OQ squared, right? It's going to be equals to what? It's going to be the equals to, it's the same as doing the distance formula, but without the square root. So it's the same as saying XO, right, minus XQ all squared plus what? Plus YO, right, minus YQ squared, right? Substitute your XO and QO and your YO and YQ. So let's substitute. We know here we're gonna have what? We're gonna have XO is 0 minus XQ is 3/2, which is 1,5, right? All squared plus, this is gonna be 0 minus 0 squared. So punch this into the calculator. You're gonna get your answers being 9/4. So we know the fact that OQ is equals to 9/4, right? So now let's find OP squared, right? It's the same as what? It's the same as XO minus XP all squared plus YO minus YP squared, right? So let's substitute. So we know the fact that XO is going to be 0 minus what? XP is going to be X, right? All squared plus XO is going to be what? It's going to be 0, right? YO is going to be 0 minus XP is going to be what? Minus, let me put this into a square bracket because this negative is going to affect. So it's going to be 2x minus 3 square bracket close all squared. Simplify it. So it's going to be here, this one is going to be x squared, right? Then here we're going to be left with what? It's going to be plus what? It's going to be plus 2x, right, minus 3 all squared. Then I'm going to expand this, right? So when you expand that, you're going to have x squared. So it's going to be x squared, then it's going to be plus, when you expand this, it's going to be 4x squared, right? Then it's going to be minus 12x. Then it's going to be plus 9, right? So that's when you're done expanding. And therefore, you're going to have what? You're going to have group like terms together. So when you group like terms together, you're going to have 5x squared, right, minus 12x plus 9. So that's what you're going to have for OP, right? So now what we left to solve what? We left to solve PQ. So let's do PQ. So PQ squared, right, it's going to be equals to what? To XP minus what? Minus XQ all squared plus is going to be what? yp minus yq all squared, right? So let's substitute. xp is going to be x, and q is going to be minus by what? xq is going to be 3 over 2. So it's going to be 3 over 2 all squared, right? Then this is going to be plus yp is going to be what? It's going to be 2x. Remember, it's going to be this one. It's going to be 2x minus 3. So it's going to be 2x minus 3, right? Then minus open bracket, open a square bracket. Then yq is going to be what? It's going to be 0. So it's going to be just 0. There's no need for a square bracket. So it's going to be minus 0. Then it's going to be all squared, right? Then what you're going to do is here, you're going to, you're going to expand it, right? So when you expand this one, you're going to get x squared minus 3x, right? Then plus 2,25, right? That's what you're going to get when you expand this. Plus this one, when you expand it, when you simplify it, you're going to get 2x minus 3 all squared, right? So what we're going to do is now we're going to expand this one. So you're going to rewrite this one exactly. So you're going to say x squared minus 3x plus 2,25, right? Then plus, let's expand this. You're going to get what? You're going to get 4x squared, right? Minus 12x, then plus 9. Group like terms. When you group like terms, you're going to end up with what? With 5. So you're going to be left with 5x squared, right? Minus 15x plus 11,25 plus 11,25. So now we're going to take this and substitute every components that we just solved. So that to confuse them, we do it in pink. So we know the fact that we have OQ squared, right, is equals to OP squared, right, plus PQ squared, right? So let's substitute every component. So the first one is 9 over 4, right, is equals to OP is this one, which is going to be what? 5x squared, right, minus 12x plus 9. Then PQ squared is going to be this one, which is 5x squared, right, minus 15x plus 11,25, right? Then take the 9 over 4 to the other side. So we're going to have 0 is equals to 5x squared minus 12x plus 9 plus 5x squared minus 15x plus 11,25 minus what? Minus 9 over 4. Group like terms. So you're going to have 0 is equals to 10x squared, right? Then minus 27x plus 18. Then I'm going to use the quadratic formula. So to use quadratic, I need to find a, b, and c. So I know that a is going to be equals to 10. Then my b is going to be equals to negative 27. Then my c is going to be equals to 18, right? To the formula is going to be x is equals to negative b plus or minus square root of b squared, right, minus 4ac divided by what? Divided by 2a, right? Let's go up. So now Now after doing that, let's substitute a, b, and c. So x is going to be equals to, my b is what? Is negative 27, right? Plus or minus, then it's going to be negative 27 all squared minus 4, 10, and 18 divided by what? Divided by 2, 10, right? Then when you punch here, when you put just the negative and not the plus, you're going to get your x as being equals to what? As being equals to 6 divided by 5, which is the same as what? Is the same as 1,2. Or when you substitute here, it's a positive instead of a negative, you're going to get your x as being equals to what? As being equals to 3 divided by 2, right? Which is the same as what? Which is the same as 1,5. Then let's go back to the graph, right? To see something. We have 1,2 and 1,5. You see here from the graph, I cannot use 1,2 because of this q, right? Is because of this q, the x coordinate is 1,5. So the answer for this one, the x coordinate for this one is what? Is 1,2 because of already q has 1,5. So the answer there, so therefore the answer here, the x coordinate for p, right? So xp is actually equals to what? To 1,2. But remember that in the question, they asked us what? They asked for the length of OP, right? And remember the fact that we wrote OP in terms of x. Let me just go here so that you can see it. OP in terms of x, we had it as this one. I'm going to take this final one, right? We wrote it in terms of p, so we're going to substitute that. So we know the fact that OP squared, right, was equals to what? So OP squared is equals to what? Is equals to 5x squared, right, minus 12x plus 9, right? Sorry that I wrote this like that. So now we're going to substitute xp. So we're going to say OP, right, is equals to 5, open bracket, is going to be 1,2 all squared minus 12, then 1,2, then plus 9. This is OP squared, right? Then OP squared, when you punch that into the calculator, you're gonna get it as being what? 1,8, right? Then square root both sides, therefore OP is gonna be equals to what? To 1,34. Remember that the length is always positive. That's why we just picked the positive one as being 1,34. And that would be your final answer. So now moving to quadratic function. As you know the fact that we're gonna state the mother graph with the general form and how each component on the general form affects the graph. So the first thing that you need to know is what? Is the mother graph, right? So the mother graph. So this is the mother graph, which is y is equals to x squared, right? Then you need to know the general form. Which state what? Which state is y is equals to a, open bracket, x minus x plus p to p squared, then plus q, right? So what we're going to do is we're going to talk about the effect of a, p, and q. So to do that, we're going to go to what? We're going to go to the graphing calculator. So now we're going to start with the effect of a. So we're going to go straight to the graphing calculator to show you how a affects the graph or how a makes the graph behave. So the first thing that we need to do is sketch the mother graph. So I'm going to just put in the mother graph, which is y is equals to x to the power to the power 2, right? So this is how the mother graph looks, where the turning point is 0, 0, which is here. This is going to be the turning point, and it's going to be 0, 0, right? So what I'm going to do is, the second one, I'm going to just make a positive 2, just so that you guys can see it, right? So I'm going to say y is equals to 2x squared, right? 2 to the power, 2. Do you see it? It's still, the origin is the fact that the graph is still here, right? So don't look at the red one, but look at the blue one. Is that you see the fact that the graph, when a is positive, the numerical value of a really doesn't matter, is how it affects the graph, right? Is that when a is positive, it's going to create like a smiley face, right? Then let's make it when a is negative. So you're going to say y is equals to negative 2x to the power 2. Do you see what's going to happen? Is that the green graph is that when a is positive, the graph is going to be a smiley face, and when a is negative, it's going to be a sad face. So now let's go to the notes. It's that the effect of a, right? So we know the fact that a gives us what? Gives us the shape. So a is going to give, it gives us the shapes. It gives the shape, right? Sorry. So that's what we know. It gives the shape. As you notice, the fact that even in linear, a did give us the shape, right? So now let's discuss when a is positive and when a is negative. So we know the fact that when a is greater than 0, meaning greater than 0, that a is positive, right? What's going to happen? The shape is going to be like this. It's going to be a what? It's going to be a smiley face. So when you dealing with this, just remember the fact that positive makes you happy and negative makes you sad, so that you can remember which shape it is, right? And when a is less than 0, meaning a is negative, right? Then it's going to give you what? A sad face. So the graph is going to look like this. So remember, positive makes you happy and negative makes you sad when it comes to A. So now let's move on to what? Let's move on to the effect of P. So the effect of P So now we're going to discuss the effect of P, which, let's go down so that you can see it. The P is the one that's inside the bracket, right? So now let's go into the graphing calculator so we can see the effects of P. So now, taking the mother graph, which is the red one, what we're going to do is we're going to just strictly see when P is negative, what's going to happen, and when P is negative, what's going to happen. Then when we move to the notes, there's something that I need to show you on how to find out which one to use, because of here you're going to see something different. But let me get into it, right? So we're going to leave the way the mother graph is, meaning we're going to take the mother graph and only add a positive P and a negative P, right? So let's say now we take P as being a positive what? A positive 2. So we're going to say y is equals to, then open your bracket, is going to be x minus 2, right? Let me start with the negative. Close bracket to the power 2. So remember, first, before I talk about the graphs and what it does, remember the fact that when we're talking about P is always the one that's inside the X, inside the bracket, right? When something inside the bracket, that is your P. The number after X inside a bracket is your P, right? So what do we see? We see the fact that when P is negative 2, your graph is going to move with, it's going to move 2 units to the right, right? So it's going to move 2 units to the right. And the reason for that, let me go to the other side. The reason why it moves to the right and doesn't move to the left because of its negative is because of this happens. Let me just write it here. When you have a function which is y is equals to then open bracket x minus 2 all squared, right? To find your p, what you need to do is you need to take this thing inside the bracket and equate it to 0 so that you can solve your p. So when we do that, it's going to be x minus 2 is equals to 0, right? Then solve for p, which is technically solving for x here. So you're going to take your 2 to the other side, so it's going to be x is equals to what? It's going to be equals to positive 2. Therefore, how you would know something is going to move to the left or to the right is that since this x value, right? Since this x value, the one that I'm highlighting, is positive 2 after solving, right? That means your graph is going to move to the right. I hope I'm making sense. So that's how you would know the fact that something moves to the left, it moves to the right. You need to solve for that p, which is that p is x is equals to that number. So it's going to move 2 units to the right because of its positive after taking it outside the bracket. I hope I'm making sense. So with that said, now let's see when we have our p being positive. So we're going to say y is equals to, same thing, but we're just going to change the p. It's going to be x, right, plus 2 close bracket to the power 2. Do you see what happens is that our graph moves 2 units to the left. And the reason why, even if here it's positive, right, in the equation is positive, it moves to the left, is because of we solve it, right? So even if we do the same thing, we say y, right, is equals to, you can't see this color, wow. But even if we take, let me do it in pink, and we say y is equals to x plus 2 all squared, right? We're solving for p, meaning we need to take this out to know which side it's going, whether left or right. So we're going to say, we take this, that I put a curly bracket underneath it, and we're going to equate it to 0. So we're going to say x plus 2, right, is equals to 0. Then when we solve for x, it's going to be what? It's going to be x is equals to negative 2. So that is why it's going to move how many units? 2 units to the left. So just remember that about your p is that the one that's in the question, right? The one that's in the question, like the sign that's in front of the equation, doesn't determine whether it moves to the positive side, but it moves the opposite of the side. That's why with this one, with the purple one, inside the bracket, right, it's negative 2, but it actually moves to the right. And with the black one, it's positive 2 inside the bracket, but it moves to the left. I hope you guys understand how P works, right? And on how to solve it using this method to know whether it moves to the left or it moves to the right. So with that said, now let's write the notes for P. So let me just erase this so I can have space. So what does P do, right? First, we need to know that it moves the graph left or right, which is also known as being the vertical shift. So that's what P does, right? Then, as I said, the fact that to solve for P, taking into account, let me just write it in pink, if you're given y is equals to a, I'm just doing it in alphabet, then it's going to be x plus p, right, all squared. To solve for p, you need to actually equate this to zeros to know whether, like, when p is positive, what happens, and when p is negative, what happens. So what I'm going to do is I'm going to write the notes using the p that's inside the bracket, right? So to make it easier so that you guys don't be confused, I'm going to use it doing this. So let's say you have y, like let's say for when p, right, is greater than 0, meaning p is what? P is positive, right? Positive. Then I'm just going to put a semicolon. I mean the fact that the equation looks like this, so that everything, you guys don't get confused. A open bracket x plus p all squared. When it looks like this, when p is positive from the bracket, what I mean, right? So put in bracket. That means the fact that the graph is going to move what? It's going to move the opposite side. It's going to move to the left. So it's going to move to the left, right? Remember, that's what happened here in the graph. When it was positive, right, it moved to the left. Then now when P, right, is less than 0, meaning is negative. And I don't mean after solving P, but P from the equation. When it's negative, so y is equals to a, open bracket, x minus p. That's what I mean, right? Then the graph moves to the right. As you have seen in the graph, moves to the right. Right? So that is the effect of P. And remember that when we talk about P, the side that it moves to is opposite to your sign that's inside here, right? Just remember the fact that the reason why I put this too is that you guys can see what I mean when it's negative P, not after solving for X, but when it's still inside the bracket, how it affects the graph. I hope I didn't confuse anyone and everyone is fine with how P affects the graph. So now let's move to the effect of Q. So back to the graphing calculator. I'm just going to erase this so that you can see how Q affects the graph. So let's start with when Q is positive 2. So I'm going to say Y is equals to X squared, taking the mother graph exactly, but just adding Q. So you're going to say plus 2, right? So remember, Q is something that's not inside the bracket. So what I'm trying to say is that with P, to see the fact that something is actually P, is that it needs to be inside the bracket, right? Then that's P. When it's outside the bracket, it's just next to X squared, then that value is Q, right? And it seems like this one is red. Let me just change it so that the color, I don't want it to be the same color. So Y is equals to X. Yeah, X squared, right? Plus 2. Do you see that what happens when Q is positive? The graph is going to go up by Q units, meaning 2 units up in this case. And now when Q is negative, so it's going to be Y is equals to X squared, right? Then minus 2. Then the graph is going to go 2 units down. So what do we see? We see the fact that Q moves the graph up and down. So when Q is positive, it moves 2 units up. And when it's negative, it moves 2 units down, right? So let's write down the effects of Q, right? So it's going to be moves. We know the fact that it moves. It moves the graph moves the graph up and up, not up and down, up or down, up or down, right? And here, just to clarify something, because I feel it might be a little bit confusing, even if it's not, let me just clarify it, is that in P, remember the fact that the sign of P, how it moves, it's opposite to its sign, right? With Q, its sign, if Q is positive, then it's going to move to the what? It's going to move up. And if P is negative, it's going to move down. So it doesn't operate like P, where P just takes the opposite of what the sign is, right? Just wanted to clarify that. So we know the fact that when Q, right, is positive, which is greater than 0, meaning that it's positive, what happens? The graph moves up. Moves up, right? Then when Q is negative, which is less than 0, the graph moves down. Then one extra remark or note, let me put a star here, is that P and Q gives us the turning point. This P and Q, right? And this P is after solving it the way I showed you. This P after solving, meaning what I mean is this. You know the fact that you need to take x minus whatever value, x minus P is equals to 0. Therefore, x is equals to P. The P that I'm talking about is after solving that you put here. As the P after solving. Then the PQ is going to give us what? That is your turning point. I hope everyone is okay. And we are done with the effects of A, P, and Q. So now let's move to domain and range of a quadratic function, right? So this is the case of always, if they ask you for domain, you need to write this, whatever I'm going to write. And if they want the range, you need to solve it the way I'm about to do it, right? So with domain, right, it's going to be always that x is an element of real numbers. Then your range is the one that basically needs components. So with your range, you need your A, right, and you need your Q. Okay? So with range, there's two conditions. Is that when A is what? Is greater than 0. It's greater than 0, meaning you know the fact that A is positive. Then this is how you would write your range. You're going to say Y is greater than 0, meaning it's positive. It's going to be greater than and equals to. Don't forget to write the equals to. Always is greater than and equals to. If you miss this equals to, then you don't get your mark, right? So it's going to be Y is greater than and equals to Q. So that's why I'm saying you need your A or you need your Q. You need your A and Q, not O. You need your A and Q. Then we have a case. So this is case number 1. Then you have case number 2, where A is less than 0, meaning it's negative. Right? And also you need your Q. So if it's negative, let me just put a line here. You're going to say Y is what? Y is less than and equals to Q. So always remember that greater than and equals to and the less than and equals to 2. Then this is how you write your range and domain. So let's do an example so that you can see it like visually doing it. So example. They say find the domain and range, then of for those two questions. So it's the first one is going to be Y is equals to x squared, right, plus 3, and the other one is going to be Y is equals to negative 2, open bracket, x plus 1, then minus 4. So we need to find the range and domain for those two. So the first one, so solution. So for the first one is that, so for I, the domain, right, for the first one, domain is going to be what? X is an element of real numbers, right? Then the range, remember I said with range you need two things. You need your A. So here our A is equals to what? Is equals to 1, right? Because it's x squared. So A is going to be equals to 1. And 1 is what? Is positive, so it's greater than 0, right? Then our Q is what here? Is 3. So our Q is 3, so Q is equals to 3. So now our range is going to be Y is what? Is greater than and equals to 3. Just like that. Then the second one, right? Our domain, still the same thing, is going to be X is an element of real numbers, right? Then our range is going to be what? It's going to be what? We need A and we need q. So a is equals to what? A is equals to -2. -2 is what? Is less than 0. Therefore, our q is equals to what? AQ is equals to -4. Therefore, our range is going to be y is less than and equals to -4. So this is how you would find your domain and range. Then now we're talking about intercept. You know the fact that we have two of them. We have x-intercept, which is the same in linear. We have x-intercept, right? Which is we're going to let y is equals to 0, right? And here in quadratic, you're going to get what? You're going to get 2x-intercept unless that that x-intercepts, you're going to get either 2x-intercepts, right? That's case 1. Then the second case is that sometimes the x-intercepts does not exist, right? Or the third one is that there's going to be only one x-intercept, meaning the fact that that one x-intercept is also the turning point. So let me just write it down. You're going to get 2 x-intercepts, right? Or you're going to get no x-intercepts. So when solving and you're getting no x-intercepts, don't feel alarmed. No x-intercepts at all, meaning the graph does not cut the x-axis, right? It only cuts the y. Or you're going to get one x-intercept. And if you get one x-intercept, that means the fact that that point is the turning point too. If you get one, right? Turning point. Yes, that's what I wanted to say. Then you have y-intercepts. Y-intercepts. So you know the fact that, and there's only one y-intercept. So y-intercept, not intercept. And when you find y-intercept, you're going to say let x equals to 0. So that's both your x and y-intercept. You know how to solve it. You use the same method that we used when doing linear. You substitute for x-intercept, you substitute your y being 0, then you solve for x. Then for your y-intercept, you substitute 0, your x as being 0, then you solve for your y. Then that's how you find it, right? So now let's move to turning point. So we have two cases, right? So if we have case 1, case 1 is when you're given a function like this, y is equals to a, right? Then it's going to be x plus p all squared, right? Plus q. Then they say find the turning point. If you have something like this, your turning point is your p and your q values. So first, the turning point, you need to solve for your p. So you're going to say you're going to take this part. So it's going to be x plus p is equals to 0. Solve for it, therefore x is going to be equals to negative p, right? Then your q value is just going to be your positive q, so it's going to be just q. Then your turning point, which is I'm going to say TP, is going to be equals to what? Negative p is to q. And that's how you find your turning point when you're given this equation. So this is going to be what? This is case 1, right? Then we have what? Case 2. So case 2, right? It's when your f of x, right, or your y is given in this form, which is ax squared plus bx plus c, right? So when your quadratic is given in this form, what you're going to do is to find your turning point, you're going to use this formula to find your xp. So your xtp, meaning your x coordinate from your turning point. So I'm just going to call it xtp, right? Meaning it's your x coordinate from the turning point. You're going to find it by saying what? Negative b divided by 2a, where your a comes from this This is A, this is B, and this is C. So whatever coefficient of A squared, of X squared, and B, and C, that's what you're going to use to find that. Then after solving your, what you call this, your X coordinate of your turning point, you're going to substitute that coordinate, your X, TP, right, into the function. Then whatever you get, that's going to give you your Y, TP. Therefore, making your turning point being equals to what? To X, TP, and Y, TP. So that it makes sense, let me do an example. So now example, it says find the turning point of the first one, which is the one with the general form where you're finding your P and Q, and the other one is when we use the other method of having the X minus B divided by 2A. So let's start. So with the first one, right, because of it's in this form, we need to solve for P and Q. So now let's solve for P, which is P is going to give us our X coordinate of the turning point. So we're going to take this in the curly bracket and equate it to 0. So you're going to say X, right, minus 3 is equals to 0. Therefore, X, take the 3 to the other side, is going to be equals to 3. So that's our X coordinate. Then our Y coordinate is what? Our Q is equals to 4, which is our Y coordinate. So the turning point, right, I'm just going to say TP is equals to positive 3 and positive 4. So this is how you find your what? Your turning point if you are given in this form, right? So now let me just move it here. For the second one, we need to find the turning point. So if you are given in this form, in the quadratic form, right, what you need to do is that you need to use this equation of X to find your turning point. So you're going to say X is equals to what? Is equals to negative B divided by 2A. So here, what's our A? Our A is equals to 2. Our B is equals to 4, and our C is equals to 6, right? So substitute B and A. So you're going to say X is equals to what? To negative 4 divided by 2, multiplied by 2, which is going to give you your A as being what? Our X is going to be equals to negative 1. Right? Then we're going to take this negative 1 and substitute it back in the formula to find our Y. So you're going to say Y is equals to what? Y is equals to 2, open bracket, negative 1, all squared, plus what? Plus 4, negative 1, plus 6, and that you're going to get 4. So here our turning point is going to be what? Our turning point is going to be what? It's going to be negative 1 and 4. And fun fact, after finding your turning point here, right, you can actually rewrite this in a form of turning point. So let me just show you that. So I can rewrite the second equation in terms of turning point like this one. This one is in terms of turning point. So you can say, we already know our A is 2. So you're going to say Y is equals to 2, open bracket. Remember that our turning point is what? Is our P is negative 1, but we need to go back and solve it again. So to solve it so they can come here in the bracket, is basically saying what? It's going to be X, right, is equals to negative 1. Take the 1 to the other side, it's going to be X plus 1 is equals to 0. So here it's going to be X plus 1, right? Right? Because you're doing the reverse of this one. Then all squared, then our Q is 4, so it's going to be plus 4. So do you see the fact that after finding your turning point, this represents our P and this represents our Q. So that's how you would find your turning point. So now let's move to axis of symmetry, right? So if you get into a question or you are given a question, then they say, what is the axis of symmetry of the equation? What you need to do is, taken from this, you need to solve for P. So you're just going to take this and equate it to 0. So you're going to say X plus P, right, is equals to 0. Then you're just going to solve for X. So it's going to be X is equals to negative P. So this is going to be your what? Your axis of symmetry. If it's not given in this form, it's given in this form, meaning Y is equals to AX squared, right, plus BX, right, plus c, and they want the axis of symmetry, then you need to solve for the x coordinate of the what of the turning point. So it's going to be x is equals to negative b divided by 2a. Then that you're going to say x, whatever that number that you're going to get, that's going to be your what? Your axis of symmetry. So that's how you find your what? Your axis of symmetry in a quadratic function. So now moving to sketching a quadratic function. So you need three things. You need the first thing, right? You need the sine. You need the sine of a. So you need the sine of a, right? And the sine of a determines what? Determines the shape of the graph, right? Then you need the what? The turning point. And the last thing that you need the what? The intercepts, both x and y. You need the intercepts, right? X and y. So this is what you need. So now let's go to a section where it's finding the equation of a parabola from a graph. So let's say they gave you like an actual sketch, then they want you to find the equation of the graph, right? So what you're going to do is, the first case, we're going to deal with three cases. So this is the first case when you're actually given the intercept, both the x-intercept and both the y-intercept. How you will approach this question and how you would solve for the equation. So the first thing is that we're going to use what? We're going to use this equation to solve it. So we're going to say y, right, is equals to a, open bracket, x minus x1, then x minus x2. This x1 and x2 comes from what? Comes from this two intercepts, right? So we need to reverse this two solution to put in so that we can find x1 and x2. So let's do that. We see the fact that here the coordinate here, right? The coordinate is what? Is -1 and 0. So meaning here x, let me just do it in pink, meaning here x was equals to what? To -1, right? When you solved it. So meaning now we need to reverse it. So it's going to be what? X plus 1 is equals to 0, right? So we found the first bracket. Then the second one, which is this one, right? We see the fact that is what? It's going to be 4 here. So it's 4 is to 0. So meaning the fact that we had what? X is equals to 4. Take the 4 to the other side, meaning it was x minus 4 is equals to 0. So this will be your second bracket. So now rewriting this whole thing by here, putting the two brackets, you're going to say y is equals to a, open bracket, you're going to say x plus 1. Then the other bracket is going to be x minus 4, right? Then after doing that, just distribute, just expand this, right? Then we're going to distribute the a. So you're going to say y is equals to a. Then let's expand this. So it's going to be x squared, right? So when we expand, it's going to be x squared. Then it's going to be what? It's going to be minus 4x. Then it's going to be what? It's going to be 1 multiplied by x, which is going to be just plus x. Then the last one is going to be what? It's going to be 1 multiplied by -4, which is going to give you what? Which is going to give you -4. Then close your bracket. Then we're going to say y is equals to a. Let's clean up this bracket. So it's going to be x squared. Then that's going to give me what? It's going to give me -3x minus 4, right? Then we're going to do what? We're going to distribute the a. So a is going to be equals to what? It's going to be a x squared minus 3a x. Then the last one is going to be -4a, right? So now we already used what? We already used the first intercept. Now we need to use the y-intercept. So the y-intercept is there to solve for what? To solve for our a. So let's substitute this y-intercept here. So we can solve for what? We can solve for a. So we're going to substitute. So it's going to be 2 is equals to a. Then at x, we need to substitute 0. So it's going to be 0 squared minus 3a. Then it's going to be 0. Then it's going to be minus 4a, right? So this one and this one are both going to be 0. So you're going to be left with 2 is equals to negative 4a. Divide both sides by negative 4. So our a is going to be equals to negative a half. So that's our a. So knowing that, what we're going to do is we're going to substitute our a back here, right, where I put a dot. So when we substitute back, there's going to be y is equals to what? To negative 1 over 2 x squared, right, minus 3 open bracket negative 1 over 2, then x, then the last one is going to be minus 4 open bracket negative 1 over 2. Then simplify that. Y is going to be equals to, this is going to be negative x squared divided by 2. Then here is going to be plus what? Plus 3 over 2x. Then the last one is going to be what? It's going to be a positive 2. So this is how you would find the equation. So now let's move to case 2. So you're given the x-intercept plus 1 random point in the graph. As you can see in the diagram, you're also given 2 intercepts, 2 x-intercepts, right? And as I said, 1 random point. So now we're still finding what? We're still finding the equation given the graph, right? So you take the same formula that we used in case 1. So which is y is equals to what? To a open bracket x minus x1. Then it's going to be x minus x2, right? So you're going to take your intercepts to find these 2 components. So let's do that. So you see the fact that here our x component, x coordinate, right, for the intercept is what? Is 1. So it's the same as saying x is equals to 1. So now let's take the 1 to the other side. So it's going to be what? It's going to be x minus 1 is equals to 0. So this is going to be the first bracket. Then the other one, we see the fact that the x coordinate for the second one is 5. So it's going to be the same as saying x is equals to 5, right? Take the 5 to the other side. It's going to be the same as x minus 5 is equals to 0. So now let's rewrite this, putting the 2 brackets, right? So it's going to be y is equals to a open bracket. The first one is going to be x minus 1. And the second one is going to be x minus 5, right? So now we're going to what? We're going to expand this bracket. So it's going to be y is equals to a. Let's expand this. It's going to give me what? X squared, right? Then it's going to give me minus 5x. Then it's going to give me what? Minus x. Then the last one is going to give me positive 5, right? So let me clean up the bracket. So it's going to be y is equals to a. Then you're going to get x squared. Then you're going to get minus 6x. Then it's going to be plus 5. Distribute what? The a. So y is going to be equals to ax squared minus 6ax plus 5a, right? So now what we're going to do is we're going to substitute the yellow point here on this one, right? On this one. So let's do that. So the y is going to be 12 is equals to a. Then the x is going to be negative 1 squared minus 6a open bracket negative 1. Then it's going to be plus 5a, right? So let's simplify this. It's going to be 12, right? It's equals to what? The side's going to be a, because this is going to give me a positive 1, and 1 multiplied by a is a, and this is going to be plus 6a. Then it's going to be plus 5a, right? Then 12 is equals to, add this together, it's going to give you 12a. Therefore a is going to be equals to 1. Then substitute this a back here, right? So let's do that. So y is going to be equals to 1, right? X squared minus 6, then it's going to be 1x plus 5, 1, which is, when we simplify it, is the same as having what? Y is equals to x squared minus 6x plus 5, right? So this is the equation that you're going to get of this function. So now let's move to the last case, which is case 3. You are given what? You are given the turning point. So let me just write that. So you are given the turning point plus one random point. As you can see, you have the turning point here, right? And one random point here. So what we're going to do to find the equation, we're going to use the formula or the formula or the equation that has the turning point, which is this one. Y is equals to a open bracket x minus or x plus p all squared, right? Then it's going to be plus q. So we're going to use that. So we need to find our p and q. Remember to find my p to substitute here. I need to solve this, right? So we see the fact that here my p is -3, right? So this is the p, but we need to solve it. So we're going to have what is the same as saying x is equals to -3. Take it to the other side, so it's going to be x plus 3 is equals to 0. So the one that comes here inside the bracket is going to be this one, right? Then my q here is just this coordinate, which is 1, right? So we know that q is going to be equals to what? To 1. So let's substitute that. So we're going to have y is equals to a open bracket x plus 3, right? All squared plus 1, right? So that's what we have. Then just to go straight to it, we're gonna what? We're gonna now solve for a. So we have our p and q. So the only unknown value here is a. So we're gonna substitute this coordinate to find what? My a. So we know the fact that this coordinate is 1:5. So by y, we're gonna substitute 5. It's gonna be equals to a open bracket. Then our x here is 1, so it's gonna be 1 plus 3. Then it's gonna be all squared plus 1. Then punch this into the calculator, right? This bracket all squared. So you're gonna say 1 open bracket 1 plus 3 close bracket all squared. You're gonna get that to be 16. So it's gonna be 5 is equals to 16a plus 1, right? Take the 1 to the other side. So when you take the 1 to the other side, what you're gonna get 5 minus what? 5 minus 1. So you're going to get 4 is equals to 16a, right? Divide both sides by 16. So it's going to be 4 divided by 16 is equals to a. Therefore, 4 divided by 16 is going to give you what? 1/4. So our a is going to be equals to what? Our a is going to be equals to 1/4. Now, having your a as being 1/4, rewrite this equation having both components. So I'm just gonna write it in pink. It's gonna be y is equals to, our a is 1/4, right? So it's gonna be 1/4 open bracket is gonna be x plus 3 all squared plus 1. And that's how you would find the equation of this function that is sketched here. So now let's move to inverse function of a quadratic. What I wanted to say is that everything that I've talked about inverse, I've already, like the basic note what inverse function is and everything like that is already discussed in the linear section. As I said, the fact that I'm going to do like a chapter that's going to say inverse functions, so that when you want to refer to the note what is inverse functions and how it works and the column, you can just click on that chapter and you can go there and just refresh your mind, right? So now what important thing that you need to know about an inverse function of a quadratic is that this is that f inverse, right, of a quadratic function is not a function. It's not a function because when using the vertical test, the vertical line test, it cuts on 2 points. And I'm just going to sketch it so that you guys can see what I'm talking about. So this is f of x, right? So I'm just going to use an what you call the vertical line test. It's just doing this. It's drawing a line vertical like this. And what do we see? We see the fact that at f of x, it only cuts what? It only cuts 1 point, meaning making f of x of a quadratic what? A function. But if I sketch the what? The inverse, which is the pink one is going to be the inverse, right? And like this. And you see the fact that doing the vertical line test is that what? It cuts 2 points. You see? It cuts at 2 points, which is here and here. Since it cuts 2 points, then this function is not, therefore, f inverse is not a function. Reason for that is because it is not a 1-on-1, right? 1-on-1 function. That's the reason why. So remember the fact that the f of x of a what? Of a quadratic is actually a function because it's cut 1 point. But what you call this? Then the inverse is not. The only time that the inverse can be a function is that what? If we cancel one part of the function. Do you see the fact that if we cancel the bottom part and we only have the top part, then the f inverse with the restriction, the fact that only the top part exists, is going to be a function, and vice versa. If I cancel just the top part, right, and leave the bottom part, right, of the function, then the graph is going to be a function because of what? It only cuts 1 point. So the f inverse of a quadratic is only a function if it's restricted the fact that only the top part or the bottom part exists. I hope I didn't confuse anyone and this makes sense on why not the entire f inverse of a quadratic is not a quadratic function, right? It's not a function, not a quadratic function. It's not a function. So now let's move to how to determine the f inverse, right, of a quadratic. So now the first step is to interchange. So step number 1 is to interchange, right? Is to interchange x and y. So I'm going to do it in pink. So it's going to be wherever I'm going to see x, I'm going to put, whenever I see x, I'm going to put y. And wherever I see y, I'm going to put x. So it's going to be x is equals to what? Is equals to a, open bracket, y plus p, all squared, right? Plus q. So now we need to make what? Step 2, we need to make y subject of the equation right? So let me fix this. So let's do that. So I'm gonna make what? I'm gonna take q to the other side. So you're gonna have x minus q, right, is equals to a, open bracket, y plus p all squared, divide both sides by a. So it's going to be x minus q divided by a is equals to what? To y plus p, right? Y plus p, and this is all inside a bracket, all squared, right? Then square root both sides. So you're going to have plus or minus the square root of what? Of x minus q divided by a is equals to what? To y plus p. Take the p to the other side, therefore making it is going to be plus or minus square root, right, of x minus q divided by a, right? Then this is going to be minus p is equals to y, making f inverse, right, equals to what? To plus or minus the square root of what? Of x minus q divided by a minus p. So this is how you find the inverse of what? Find the inverse of a quadratic function. So now what we're going to do is we're going to move on to past paper questions. So now let's start with the past papers. We're going to start with 2021. It says the graph f of x is equals to, then they give you x plus 4, then another bracket is x minus 6, right? It's drawn below. So we know the fact that the f of x is the what? Is the quadratic, right? It's the quadratic function. Then they say the parabola cuts the x-axis at B and D, right? And the y-axis at G. Then it says C is the turning point. So we know the fact that C is the turning point. Then they say line AE. So it's this line, right? Let me just highlight it. Line AE. So it's going to be this line, right? Has an angle of inclination theta and cuts through the x-axis and y-axis at A, right, which is this point, and E respectively. Then T is a point. Where is T? So T is here, right? They say T is a point of F between B and G, right? It's between B and G, which makes sense. So let me just clean this up, and now let's go to the first question. So 7.1, it says write down the coordinate of B, right? So what do we see? We see the fact that B and D are what? B and D are the x-intercepts. So we know the fact that B and D are the x-intercepts, right? And to find the x-intercept, we need to let what? Y equals to 0, right? And in our case, we need to let f of x or f of x equals to 0. So let's do that using this one, like letting it to be 0. So it's going to be 0 at f of x is going to be 0 is equals to what? Is equals to x plus 4, right? Then the other bracket is going to be what? It's going to be x minus 6, right? So that's what we have. So now we're going to solve for x and y. So it's going to be what? It's going to be the same as x plus 4, right? Is equals to 0. Or, so it's going to be x plus 4 is equals to 0. Or you're going to say x, not or, you're going to say x minus 6 is equals to 0, right? Then we're going to solve for x. So it's going to be x here is equals to what? To negative 4, right? And the side is going to be or x is equals to what? Is equals to positive 6. So knowing which one is going to be A and which one is going to be B, it's going to be D, right? We see the fact that B is where? Is on the negative side. So the B coordinate is going to be this one, right? So for this one, it's going to be B, right? Then the coordinate is going to be negative 4 and 0. Then for your D is going to be this one because it's on the positive side. So it's going to be what? It's going to be D, right? It's going to be 6 and what? And 0. So that's your two coordinates for B and D. So now moving to 7.2, it says calculate the coordinate of C. What's the coordinate of C? It's actually the turning point. So we're looking for the turning point, right? So that's what we're looking for. We're looking for the turning point. So we're given that f of x, right, is equals to this, which is x plus 4 and x minus 6, right? Then close the bracket. So now what we're going to do is we're going to expand those two brackets. So we're going to have f of x, right, is equals to, then it's going to be x squared, right? Then it's going to be, so it's going to be like this, right? Then it's going to be like this, so it's going to be minus 6x. Then it's going to be like this, so it's going to be plus 4x. Then the last one is going to be like this, which is going to give me what? Which is going to give me negative 24x. Negative 24, not x, right? Doing the distribution, then let's simplify this. So it's going to be x squared is equals to x squared, right, minus 2x, right, minus 24. That's what we have. So now we're finding the turning point. So I'm going to use this one with this formula. So we're going to say x is equals to negative b divided by 2a, right? So what do we know? We know the fact that our a here is going to be 1, our b is going to be negative 2, and our c is going to be negative 24. Substitute your a and b. So when you substitute, it's going to be negative, then it's going to be negative 2, close bracket, then it's going to be 2 multiplied by 1, therefore making my x coordinate being 1. Then now we're looking for the y coordinate, so it's going to be f at 1, right? I'm going to take this and substitute this one that I put as stars and substitute 1. So it's going to be equals to 1 squared minus 2, 1 minus 24. Then what you're going to get that as being negative 25, and that's going to give you what? Your y. So therefore, making the turning point be what? Making the turning point being what? Being 1 and negative 25, right? Not 24. So therefore, my c coordinate is what? Because c is the turning point. Therefore, the c coordinate is 1 and negative 25, right? So that's how you would find 7.2. So now moving to 7.3, right? It says write down the range of f of x, meaning write the range of the quadratic. So range, right? Remember, with range we need what? We need a and we need q. So a here is going to be equals to what? Is equals to 1. So our a here is equals to 1, and positive 1 meaning it's greater than what? It's going to be greater than 0, right? Then our q is from the turning point. We already calculated it from the turning point. Is equals to what? Is equals to negative 25. So meaning, therefore, my range is going to be y is what? It's greater than and equals to negative 25. Then you're done with finding your range. So they say 7.4, given that theta is 14,04 and the tangent of f at t is perpendicular to AC, we're only going to do for 7.4, we're only going to do one portion of the question. Then the second question, the second portion, which is 7.4.2, I'm going to do it when I'm doing calculus, because I need to do the notes for calculus so that you can be able to answer such questions, right? So let's do the first one, because if I can tell you, even if it's part of analytic, it's something that you could just hold on to the information till we do analytic. It's not like a big concept where I need to explain a lot of things. So 7.4.1, right? It says calculate the gradient of AC. So they want the gradient of this line, the one that I'm going to highlight, right? And they give you the angle theta. So if they give you the angle and they want the gradient, of that, a formula that you need to remember is that the gradient, right, of this line, which is in our case is AE, right, is equals to what? Is always equals to 10 theta. So they already gave us the angle, so I can say 10, 14, right, comma 0.4 is equals to what? Is equals to the gradient AE, right? So therefore the gradient AE is equals to what? Is equals to 1/4. It's equals to 1/4. So that's how you find the gradient when you're given the angle. So now moving to 7.5, it says a straight line G parallel to AE. So what do we know? We know the fact that parallel lines, and also this concept is from analytic, but I can just say it now, is that if two lines are parallel, then meaning both the gradient of the lines are equals to each other. So the gradient of the line G, that's what I'm saying, MG, is going to be equals to the gradient of what? It's going to be equals to the gradient of AE. So we know the fact that the gradient of MG is going to be equals to the gradient of AE, right? So therefore the gradient of G here is going to be equals to what? To 1/4. So that's the first information that we know. Then they say the line, because if they tell us that they parallel in the, it's like extra information inside like the commas, right? It says cuts F at K. So we know the fact that it cuts F at K and R, right? So what do we know? We know the fact that the graph, right? The graph G cuts F, see, cuts F at K, which is they give us the coordinate of K, and cuts again at R, which they don't give us. Then they say calculate the X coordinate of R. So what do they want us to do? They want us to find this. The X coordinate when this question is basically find the X coordinate when G of X is equals to F of X. That's what we're looking for. But what do we know? We know the fact that we already have G of X, but we don't have what? We have F of X, but we don't have G of X. So what do we need? We need to find G of X. So what's another important information? That we can actually find G of X because of they gave us one set of coordinate and we already know the gradient. So we can say G of X, right, is equals to what? To mx plus c, right? So we already know m, so G of X is equals to 1 over 4x plus c. We have another set of coordinate, which is k, that we can substitute here to find c. So let's do that. So it's going to be negative 9, right, is equals to 1 over 4. Then it's going to be negative 3 plus c, right? Then let's simplify the negative 9. So let's multiply what? 1 over 4 multiplied by negative 3. So it's going to be negative 9, right? It's equals to negative 3 divided by 4 plus c. Take this negative 3 over 4 to the other side. So you're going to have what? You're going to have c being what? Being negative 33, right? Divided by 4. So now let's write G of X with the component c. So let's do that. So G of X now is going to be equals to what? It's going to be equals to 1 over 4, right? X minus 33 divided by 4. So that's your G of X. So as I said, the fact that we're looking for what? For f of X equals to G of X. So I'm just going to do it in orange. So we're looking for G of X equals to f of X. That's what we're looking for, right? Let me just reduce the pen here. So now we know G of X is equals to this one. So let's substitute. So it's going to be 1 over 4, right? X minus 33 divided by 4 is going to be equals to, then f of X, we know it to be equals to what? 2x squared, right? Minus 2x minus 24, right? After expanding f of X, it's equals to what I just wrote. That f of X that I highlighted in yellow, after expanding, is equals to the one that I wrote here, right? So now what we're going to do is we're going to take everything to one side. So it's going to be 0 is equals to x squared minus 2x minus 24 minus 1 over 4x. Then it's going to be plus 33 divided by 4, right? Group like terms. So you're going to have 0 is equals to what? To x squared, right? Minus what? Minus 9 over 4x. Then it's going to be minus 63 divided by 4, right? Then I'm going to use quadratic formula to find my x. So using quadratic, I know it's going to be x is equals to, it's going to be equals to negative b plus or minus square root of b squared minus 4ac, right? Divided by what? By 2a. Then we need to find a, b, and c. So a here is going to be equals to 1. My b is going to be equals to negative 9 over 4. Then my c is going to be equals to negative 63 divided by 4, right? So that's how it's going to be. Then now substituting my a, b, and c. So I'm going to substitute. So I'm going to say x is equals to what? To negative, open bracket, negative 9 over 4. That's going to be plus or minus square root, right? It's going to be what? It's going to be negative 9 over 4 squared minus 4, then it's going to be 1, then it's going to be, then what? It's going to be 1, then our C is going to be negative 63 divided by 4, right? Then everything divided by 2a, which is going to be 2, 1. Then when you punch this into the calculator, putting just the negative, you're going to get your x, right, as being negative 3. Then when you punch this into the calculator, just put in the plus sign, is going to be or x is going to be equals to what? 21 divided by 4. But what do we see? We see the fact that in the question, let's go back to the question before we answer this. They tell us the fact that the 2 points that it cuts is k and r already is negative 3, meaning that the x coordinate for r is going to be what? The remaining, which is going to be 21 divided by what? Divided by 4. So therefore, the xr, right, is going to be equals to what? To this one. It's going to be equals to 21 divided by 4, because of already the k has the x coordinate of 3. I hope that made sense. So now let's go to 2020. It says the graph of f of x, and they give you the function, and g of x, which is they give you the function. We see the fact that f of x is a quadratic and g of x is a linear, right? As sketched below, then they tell you that a is the turning point of f. As you can see it down, a is the turning point, which is a is here, is the turning point, and they say the axis of symmetry of f and intersects with the x-axis at e, right? So we know the fact that it intersects here, the axis of symmetry. So this line that I'm going to do in pink is the axis of symmetry. Intersects x-axis at e, which is makes sense is here, right? And they say the line G at D, right, which is M and N, which is here, right? Then again intersects at D. That's what they mean. Then they say C is the y-intercept of G. So they tell us the fact that C is the y-intercept of G and F, right? So knowing that information, let's start answering the questions. So 4.2.1, it says write down the coordinate of A. So where's A is this. So what are we given? We're given that f of x, we know the fact that A is the turning point first. And we're given that f of x in this form, which is 1 over 2. Then it's going to be x plus 5, right, all squared minus 8. So we see the fact that they give us the function of f of x in terms of turning point. So now we can write the turning point. First, you're going to take this one out. So you're going to say x plus 5 is equals to 0. Then we're solving what? The x coordinate of the turning point. So take 5 to the other side. So x is going to be equals to negative 5. Then the y coordinate here is going to be q, which is going to be what? Negative 8. So the coordinate A is what? It's negative 5 and negative 8, right? So that's the A coordinate for the first one. Then 4.2.2, it says write down the range of f. So we know the fact that we need to write the range of f of x, which is what? The quadratic. So 4.2.2, we need to write the range of the quadratic function. To write the range of the quadratic function, remember the fact that you need a and you need q. What do we have? We know the fact that a is equals to what? To 1 over 4. Positive 1 over 2, which is positive, which is greater than 0. Then what is our q? Our q here is going to be what? Our negative 8. So it's going to be negative 8, or you could have taken it here. This is negative 8. You could have taken it here from the turning point, right? So therefore, our range is going to be y is greater than and equals to what? To negative 8. Then you're done finding the range of this question. Then now let's go to 4.2.3. It says calculate the value of m and n. Where do we see m and n is the coordinates of what? Of D. So this one, the coordinates of D. And what do we know about the x value is that A, E, and D share what? Share the same x value, right? So therefore, we know the fact that the coordinate here is negative 5 and negative 8. So meaning here E is going to be what? The coordinate here at E is going to be what? It's going to be negative 5 and 0. Then here our M is going to be what? Negative 5. So we know the fact that since they share the x coordinate, right? Therefore M, let me write it, it's going to be 4.2.3. So therefore M is equals to what? Is equals to negative 5. I hope I didn't confuse anyone. Because of it's by the axis of symmetry, therefore A, E, and D share what? Share that coordinate, which is x. The x coordinate of A, which is negative 5, and therefore making M equals to negative 5. Then now we need to solve for what? We need to solve for n, right? And what is n? N is the y coordinate, right, of the y coordinate of D, right? So let's substitute it by the g of x because of it cuts through here by g of x. Do you see that? So we can find this y coordinate substituting this negative 5 by g of x. So let's do that. So we need to find g of negative 5. It's going to be equals to n, right, which is going to be equals to 1 over 2. Then it's going to be negative 5 plus 9 divided by 2. Punch this into the calculator. You're going to find that your n is equals to what? You're going to find that your n is equals to 2, right? So that you then, so now you've calculated your m and n. So now let's move to 4.2.4. It says calculate the area of, let me just highlight it, O, which starts here, right? O, C. So we're gonna go like this, OC, right? Then they say D and E. So this whole thing that I'm just highlighting in yellow, they want us to find the area of that. And I've created a bigger sketch here so that we can basically be able to solve it properly, right? So what do we know here? We know the fact that I already said the fact that the coordinate of A, the x coordinate of A is the same as the x coordinate of E, which is the same as the x coordinate of what? Of D. So here, since it cuts through the x-axis, here is going to be what? The coordinate here is going to be negative 5 and 0, right? Because it's by the x-axis. It's exactly by the x-axis. And we found D's coordinate as being what? As being negative 5 and 2, right? Because we calculated it in the previous question. Then here, the coordinate at O is what? You see the fact that this, the yellow one, I've indicated in yellow, is the x and y axis. So here the coordinate is 0, 0, because it's by the origin. So it's going to be 0. So the coordinate here is going to be 0, 0. Then here we need to find the coordinate of C. Remember that they told us that C is what? Is the y. Let me just move it here. C is the y-intercept of f and g. And what do we know about the linear function, right? We know the fact that the C, right? This C, remember the fact that this is C or Q, gives us what? Gives us the y-intercept. So we know the fact that from this we can find the coordinate of C, which is going to be the y-intercept, which is going to be 0, and the last, which is Q or C, which is going to be 9 over 2. So here the coordinate of C is going to be that. It's going to be 0 and 9 over 2. Right? So now, having all the coordinates in the diagram, the easiest way that I find doing this question is to split this diagram, right, into 2. So I'm just going to do a dotted line like this, right? Let me do it in another color. This one, pink, right? So we need to find the area, then I'm gonna call this x, right? So what I'm gonna do is we're gonna find the area of the triangle, then we're gonna find the area of the rectangle, right? So let me put it aside. Before finding the area of the triangle and rectangle, let's do what? Let's label the sides. From the origin coming to E, what is the length there? The length is going to be what? Let me just do it in another color. Well, I'll do it in pink. From here, from the origin to E, it's 5 units, right? See, from here to here, it's 5 units. Then from here, right, going to C. So going from C, from this position, from O going to C, this whole length is going to give you what? Going up, because we start from 0, then we go to 9/2. So the length there is going to be 9/2. Right? So that's what we have. Then from here, do you see, from E to D, the length, the y-axis of this one is what? Is 2. So we know the fact that here the length is going to be 2. We know this and this are equals to each other, so therefore this length here, right, is also 2. So to find this length, this remaining length is going to be what? It's going to be, to find CX is going to be what? The total, which is 9/2, right? The total length, right? 9/2, which is the total length. Let me just do it in the formula in alphabet so that you can see that first. To find CE is going to be the total length, which is going to be CO, minus what? The small length that we have, which is OX, right? So we know the fact that CO is what? Is 9/2. And what we have is what? OX, which is going to be -2. So therefore CX, which is just this portion, is going to be equals to what? It's going to be equals to 5/2. So the small portion here, right, is going to be equals to 5/2. So now we have all components to find my length, to find my area, right? So as I said, the fact that the area, they say they want the area of what? They want the area, so they want the area of OCDE. That's the area that they want, right? So I'm saying I'm going to break it down into 2 components. So it's going to be equals to the area of the triangle. So the area of the triangle, what? Triangle D, right, CX, plus it's going to be equals to the area of the rectangle. So it's going to be equals to the area of the rectangle, which is what? Which is DEOX, right? So now the area of the triangle is going to be half base times height, plus the area of the triangle is going to be length times breadth. So let's substitute here. The area of the triangle is half base. The base is this one. This 5 and this 5 is going to be the same, right? So dx is going to be our base. So it's going to be half dx, which is 5. Then our length there is this one, which is going to be 5/2. Right, then this is going to be plus our length times breadth. Our length is 2, so it's going to be 2 multiplied by 5, right? Then you punch that into the calculator. You're going to get that your area of OCD is equals to 65 divided by 4. So the area of OCD is equals to 65 divided by 4. Then the last question here, which is 4.2.5, it says determine the equation of the inverse of G, right, in a form of y is equals to. So we need to find the inverse of the linear. So we know the fact that we have G. This is 4.2.5, right? So that's what we have. We know the fact that G of x, right, is equals to, so we know that G of x is going to be equals to 1/2, right? Then x, then it's going to be plus 9/2, right? So we're finding what? We're finding the inverse. So I'm going to write this G of x in terms of y. So I'm going to say y is equals to what? To 1/2, right? X then it's going to be plus 9 over 2, right? So what we're going to do now is that we're going to exchange x and y. So let's do that. So it's going to be x is equals to what? Is equals to 1 over 2 y, right? Plus 9 over 2, right? So what do we see? We see the fact that both of them have a denominator of 2. So I can basically write this thing into being one thing. So what I mean is this. If I have maybe 1 over a plus 2 over a, right? What can I do is I can share the denominator. It can be like this. So this can be equals to 1 plus 2 divided by a. So that's what I'm going to do here, because if they share the same denominator, which is being 2, so I'm going to say x, right, is equals to what? 2. Taking this y on top is going to be y, right, plus 9 divided by what? Divided by 2. So getting rid of this denominator, I'm going to multiply it by here by x. So I'm going to have 2x, right, is equals to what? 2y plus 9, right? Take the 9 to the other side. So I'm going to have what? I'm going to have 2x minus 9 is equals to y. Therefore, my G inverse is equals to 2x minus 9. Then I'm done with 2020. So now let's move to 2018. It says in the diagram below, the graph of f of x, and they give you that f of x is equals to ax squared, is drawn in the interval where x is less than 0, right? Less than and equals to 0. Then they tell you the fact that the graph of f inverse is drawn so that the point P, which is negative 6 and negative 12, is a point on f. So, and R is the point of f inverse. Let me just highlight which one is f of x and which one is f inverse. So this one in orange is going to represent f of x, right? Then this one in pink is going to represent the what? The f inverse, right? And what do they do? They give us the fact that f of x is drawn in a restriction on the positive what? On the on the negative x-axis. That's why they say when x is less than and equals to 0. So now let's move to the first question. It says, is f inverse a function? Motivate your answer. So 4.1, right? So using the vertical line test, which is I'm going to use this highlighter, right? We're going to go down and just draw a line. Do you see the fact that it cuts what? It cuts the pink graph once. So yes, the function is a yes, and f inverse is a function. And your reason for that is using the vertical line test. Using the vertical line test, right? Which creates a what? A 1-on-1, 1-to-1 mapping. Which creates a 1-to-1 mapping, right? So that is why the first question, that yes, f inverse is a function because of it cuts once. And the reason why it cuts once is because of this restriction, right? Then let's go to 4.2. It says if R is a reflection of P and the line Y is equals to X, write down what? Write down the coordinate of R. When something is a reflection upon the line y is equals to x, this is what? This is the inverse. Remember? They're talking about inverse. When something is a reflection between this line, right? So if this point is a reflection of this one, right? So therefore, the fact that the coordinate of R is going to be what? It's just going to be this coordinate swapped. So it's going to be negative 12 is to negative 6. So therefore, the coordinate of R is going to be what? It's going to be negative 12 and it's going to be negative 6. Remember that the inverse is what? The inverse is the interchanging of x and y. And here we just interchange the x and y for r. Then now moving to 4.3, right? So 4.3 says calculate the value of a. So they want a. So a is from where? Is from the f of x, right? So we know the fact that we already have a point P, so we can substitute the point P here at f of x to solve for a. So we know that f of x is equals to what? To ax squared. Substitute your P, so it's going to be what? It's going to be negative 12 is equals to what? To a open bracket 6, negative 6. Then this is going to be all squared. So this is going to be negative 12 is equals to what? Is equals to 36. A, divide both sides by 36, so you're going to have negative 12 divided by 36. It's going to give you a. Therefore, a is going to be equals to negative 1 over 3. And we're done calculating the value of a. Then the last question says write down the equation of f inverse in the form of y. So we need to take f of x, so we need to find the equation of f inverse, so 4.4. We know the fact that we have f of x is equals to what? Substitute your a, so it's going to be minus 1 over 3, right? It's going to be x squared. So this, right, the f of x in terms of y, so it's going to be y is equals to negative 1 over 3 x squared, right? So to find the inverse, right, we need to what? Interchange y and x. So it's going to be what? It's going to be x is equals to negative 1 over 3 y squared, right? So what we're going to do is I'm going to make this y squared go up here. So it's going to be like this. So it's going to be x is equals to y squared negative y squared divided by 3. Then I'm going to multiply this 3 by x. So you're going to have 3x is equals to negative y squared, right? Then what you're going to do is you're going to take this negative or divide both sides by negative. So this side is going to be what? It's going to be negative 3x. And this side is going to be a positive y squared, right? So now I'm going to square root both sides. So I'm going to have what? I'm going to have plus or minus the square root of negative 3x is equals to y. So now what we're going to do here, we're going to pick the negative one. So y is going to be equals to minus square root of negative 3x. The reason why we pick the negative is because from our calculation, we know that a is equals to negative 1 over 3. Therefore, the a for the inverse needs to be negative, right? So that's why from here, during our calculation, we picked what? We picked the negative one. So because of the a is negative there. So therefore, making our what? Our f inverse, right? Be equals to what? Be equals to negative square root negative 3x. And that's your final answer of finding f inverse. So now let's go to 2018. It says question 6. In the diagram below, a and b are the x-intercept of f of x. So we see the fact that a here and b are what? Are the x-intercept for f of x, right? Then they say a straight line, which is this one, g. So the straight line is g, right? Through a cuts f at point C. So we see the fact that C and A are the what? Are the intercept between when g of x is equals to f of x and the y-axis at what? At 0 and 1. So we see the fact that this are the y-axis, right? Then they say M is a point on F and N. So what you call this M? Where is M? M is this one. Is a point on F, so we see the fact that it lies on F, and N is a point on G, such that MN is parallel to the y-axis, and MN cuts through the x-axis on T. So what does that mean? It means the fact that MT and N share what? Share the same x coordinate, right? So now let's go to the first question. It says show that g of x is equals to x plus 1. What do we see? We see the fact that the first point, this one, right? Okay, before I do that, let me just write 6.1 so we can discuss it properly. So we're looking for g of x. So g of x, right, is equals to what? To mx. Let me write this properly. is equals to mx, right, plus c. So what do we need to look for? We need to look for m and we need to look for c. So what do we see? We see the fact that for m, we are given two coordinates. We are given this 1 and we also given this c, right? So we can use the formula for gradient to actually find the gradient here. And another thing for c, we are given this 1, this coordinate 1. Do you see this one? And c is equals to the y-intercept. So we can find c, right, because of they already gave us the coordinate for the y-intercept. So we know the fact that we have the y-intercept, right, which is what? Which is 0 and 1. And this 1 is what? Is the c value. So we know the fact that c is equals to what? 2 equals to 1. So let me rewrite this. This is the same as saying g of x, substituting c, is equals to mx plus 1. So what we need to look for? We need to look for what? We need to look for m, right? Let me go up. So to find m, right, the gradient is equals to what? The difference in the difference between the two coordinates. So y2 minus y1 divided by x2 minus x1. So we need two coordinate. What are we given them? We given as being what? As being 0 and 1, which is this is the y-intercept. And also they gave us the c coordinate, which is what? C, which is 4 and 5. Right. So now we're gonna name this one as being 1 and this one as being 2. Right. So now let's substitute this coordinate here. So y2 is what? Is from c. So it's 5. So it's going to be 5 minus what? Minus 1. Right? Divided by x2 is 4 minus 0. Then simplify that. When you punch that into the calculator, you get your gradient as being what? Positive 1. So now, therefore, let me just write it here. We're going to take this one and substitute m as being 1. So it's the same as g of x is equals to what? 2, 1 multiplied by x plus c, which is the same as g of x is equals to x plus not c. C we already know as being 1. So this is plus 1, right? So this is the same as x plus 1, which is the same as the one that they gave us in the question, which is x plus 1. So the second question says, calculate the coordinates of A and B. What is A and B? A and B is the x-intercept. So we need to look for the x-intercept, right, such that y is equals to 0. So f of x is this one, right? So we're looking for the x-intercept for f of x. So wherever we see f of x, we're going to substitute by 0. So it's going to be 0 is equals to x squared minus 2x minus 3, right? Then factorize this. As I said, I have a video where it talks about mastering factorization. I'll link it down in the description. So when you factorize this, what are you going to get? We're going to get x plus 1. Then it's going to be x minus 3, right? So this is the same as x plus 1 is equals to 0, or x minus 3 is equals to 0. So this is going to be x is equals to negative 1, or x is equals to positive 3. So now looking at our what? Looking at our graph, the point A and B, we see the fact that A is on the negative side, meaning the negative 1 is going to be for A. So it's going to be A, then it's going to be negative 1 and 0. And since B is on the positive side, therefore B is going to be this 3. So it's going to be 3 and 0. And you're done finding the coordinate of A and B. So now let's move on to 6.3. So this is going to be 6.3. It says determine the range of f. So we looking for the range of f. So range, right? We know the fact that for range we're looking for A, then after we need Q. So what do we see? We see from our question our A is what? Is the coordinate? Is the coefficient of x squared, which is 1, and it's positive, meaning it's greater than 0, right? Then we need Q. Q is what? Q is our turning point. So let me go down. So I know the fact that Q is our turning point because our turning point has P and q. So we need to look for our q, meaning we need to find the turning point first. So since we're given the equation f of x, let me just write it down here. So we know the fact that I'm going to write it in red, that f of x, right, is equals to what? Is equals to x squared minus 2x minus 3, right? So since we're given our function in terms of a, b, and c, we can find the turning point using what? Using x. So you can say x, right? Then you're going to say negative b divided by 2a. So what is our a here? Our a is 1. Our b is negative 2. Substitute a and b. When you do that, you're going to get negative, open bracket, negative 2 divided by 2, open bracket 1, which is you're going to get your x as being what? Your x as being 1. Then to find q, so this 1, right, is your p, right? Then q, right, which is going to be the same as f of 1, right, is going to be equals to, substitute it back here, so it's going to be 1 to the power 2 minus 2, 1, then minus 3. So we're going to substitute the 1 inside f of x. So when you punch that into the calculator, what you're going to get negative 4, meaning our q is equals to negative 4. So here our q is going to be negative 4. Remember from the notes of what? Of quadratic, finding the range, since a is greater than 0, it's positive. Therefore, your range is going to be y is greater than and equals to. Don't forget the equals to. Then q, which is going to be negative 4. And that's going to be what? Your range for this question. So now let's move to 6.4. It says if mn, which is this one, right? They say if mn, right, if mn is equals to 6, and they say determine the length of OT. So I'm going to do it in a different color. So they want the length of OT, right? If t lies on the negative x-axis, show all working out. So what are we given? We're given the length of mn, which is 6, right? And what do they want? They want the length of OT. So what do we see? We see the fact that this, right, the one I'm putting points, M, T, and N share what? Share the same x coordinate. And what is the coordinate for here? It's xt into 0 because of it's on the x-axis, right? So to find the length of OT, we need to find the what? The x coordinate of what? The x coordinate of t. So knowing that, right, we can use the information that they gave us, which is mn is equals to c. So what do we know? We know the fact that this is 6.4.1. We know the fact that mn, right, that length is basically what? The top graph minus what? Minus the bottom graph. What is the top graph in our case? Where does m lie? Because that's the top graph. M lies on where? On f of x. So this is the same as saying f of x minus the bottom graph. N lies on g, so minus g of x. So substitute, so this is mn. Substitute what? Substitute f of x and g of x and mn, because they told us the fact that mn is equals to 6. So we know the fact that mn is 6. Then g of x is going to be what? It's going to be open bracket, it's going to be x squared, right, minus 2x, right, minus 3, then minus open bracket the g of x, which is x plus 1, right? So it's going to be 6 is equals to, then this is going to be x squared minus 2x minus 3. Distribute the negative, so it's going to be minus x minus 1. Simplify this side, so it's going to be 6 is equals to what? It's going to be equals to x squared, right, minus 3x, right? Then it's going to be minus 3x, right? Then it's going to be this -3 and -3 and -1 is going to give me -4. Then what we're going to do now, we're going to take the 6 to the other side. So it's going to be 0 is equals to what? 2x squared minus 3x, right? Minus 10. As I said, the fact that I have a video of factorization, so really, if factorization is giving you a problem, really check out that video. So 0 is going to be, we're going to factorize this, so it's going to be x minus 5, right? Then x plus 2, right? So when we solve it, it's going to be x minus 5 is equals to 0, or x plus 2 is equals to 0. X is going to be equals to 5, or x is going to be equals to what? To -2. What do we see? We see the fact that t lies on the negative, and they even stated in the question that t lies on the what? See, they say determine the length of OT if t lies on the negative. They state the fact that it's on the negative. Even on the graph, it shows the fact that t is on the negative, right? This t is on the negative. So here we need to pick the -1, which is x is equals to -2. So we know the fact that the coordinate of t is going to be -2 is to 0, right? Because of 0, because of what? It's on the x-axis. So with that said, now we know the fact that this t, right, is going to be -2 and 0. So the length from going here to here is just going to be t units, right? So it's going to be t units. It's going to be 2 units. So therefore, OT, let me just write here, OT is equals to 2 units. So the distance from here till here is going to be 2. So it's going to be 2 units. So your answer is going to be 2 units. So now we're moving to 6.4.2. It says, hence determine the coordinate of n, right? So what do we know? We know the fact that, as I said, since m, t, and n lie on the same line, right? It means the fact that m, t, and n share the same x coordinate. So what I mean is that xm, right, is equals to xt is equals to xn, right, which is going to be equals to -2. So therefore, the reason why is because of they lie on the same line, right? So therefore, we know the fact that our x coordinate for n, right, is going to be equals to -2. So where does n lie, right? N lies on g of x, so we're going to say g of xn. Now we're looking for g of xn, right, which is going to be equals to what? It's going to be xn plus 1. But what do we know? Xn is being what? Is being -2. So it's the same as finding g of -2 is equals to -2 plus 1. Simplify that. We're going to find that our y coordinate is going to be what? Is going to be -1. So therefore, making my coordinate for what? So remember the fact that this is the same as yn, just to not confuse you guys, and this is the same as yn. So with that said, let me just write it. Therefore, yn is equals to -1. So now the coordinate of n is going to be what? It's going to be -2, this one, and -1. This one. So this will be your coordinate for n. Then let me just write it here. So we know the fact that n is going to be -2 and -1. So with 6.5 and 6.6, I'm not going to do it because it falls under calculus. So when I do calculus, I'm going to actually do questions from functions. So this is the end of 2018 for question 6. So the first one, I scratched it out because if it's a topic for calculus, so I'm going to come back to the questions that I've skipped because of, as I said, the fact that you need to understand calculus first before me doing such questions, because I'm going to confuse a lot of people and we're not here for that. I'm here to clear things up, not confuse you guys, right? So we're going to go straight to what? Straight to 4.2. But before we go straight to 4.2, let me write the function substituting a and b because they gave us in this question. So we know the fact that in our case that f of x, right, is equals to a is negative 1 over 2, then x squared, then our b is plus 2x, then plus 6. So this is the function that we have. Then 4.2 says calculate the x-intercepts of what? Of f. So we know the fact that 4.2, to find the what? The x-intercepts, right, we need to let y equals to 0. So wherever I'm going to see y or f of x in our case equals to 0. So wherever I see f of x, I'm going to substitute by 0. So it's going to be 0 is equals to negative 1 over 2. Then it's going to be x squared plus 2x plus 6, right? Then what I'm going to do is I'm going to use quadratic formula. So to use quadratic formula, I need a, b, and c. So my a is going to be negative 1 over 2. Then my b is equals to 2. Then my c is equals to 6. So let's substitute it there. So it's going to be x is equals, let me write the formula first, minus b plus or minus then let's substitute. So you're going to have x is equals to negative, then my b is 2, so it's going to be 2 plus or minus the square root of 2 squared, right, minus 4. My a is negative 1 over 2, then my c is 6, right? Then that whole thing divided by what? By 2, then my a is negative 1 over 2, right? Then what do I have? I know the fact that when I punch this formula inside the calculator and I just put the negative, I'm going to get my x to be what? To be 6. Or when I punch this formula and I put the addition, my x is going to be equals to what? To negative 2. So here my coordinates, my two coordinates, right? My 2 x-intercept is going to be what? It's going to be 6 is to 0, right? And the other one is going to be what? It's going to be negative 2 is to 0. Then we're done finding the x-intercept. Then 4.3 says calculate the coordinates of the turning point. So since our our function is in terms of a, b, and c, I'm going to use the one that says for finding the turning point that said x is equals to what? To negative b divided by 2a. What is our a here? Our a is negative 1 over 2. Then my b is equals to what? To 2. Then my c is equals to 6. So I'm going to substitute my b and a. So x is going to be equals to what? 2 negative open bracket 2, then divided by, then my a is negative 1 over 2. Then we find this when you punch it into the calculator that my x coordinate for my turning point is equals to 2. Then now finding my y coordinate, I'm going to substitute this one into the function, right? So I'm going to find f of 2, right, which is going to be equals to negative 1 over 2. Then it's going to be 2 all squared plus what? Plus 2. Then this is going to be 2. Then it's going to be plus 6. Then when you punch that to the calculator, you're going to get 8. Therefore, making my turning point, which is I'm going to say TP, is equals to what? To 2 is to 8. So that's my turning point. Then now moving to 4.4, it says sketch the graph F, clearly indicate all the what? All the intercepts with the x's and the turning point. So we already have the x-intercept and we have the turning point. The only thing that's left is what? Is my y-intercept. So one, you can use the approach of substituting x everywhere to find your x-intercept, or very important, if the function that you're given is given in terms of like this, where it's in terms of a, b, and c, my c is the what? Is the y-intercept. So the c, right, is the y-intercept. Just remember that if you're given the function in this form, right, very important, only in this form where you have a, b, and c, my c is going to be what? Your y-intercept. So my y-intercept here, so for 4.4, So my y-intercept here, right, my y-intercept, right, is going to be what? It's going to be 0 and c, where my c is 6, so it's the same as 0 and 6. So that's how you find your y-intercept if the graph is given in this form, right? So now let's sketch it. So now we have all our intercepts plus the turning point. So let me just sketch this. Let me just remove this and write it somewhere here. My y-intercept, because I need space, it's going to be 0 and 6, right? So let me sketch it like this. Right, so let's start with my x-intercepts, right? So it's 6 and -2. So let's start with -2. So this is -1 and this is going to be -2. So my point is here first, right? Then my other point is +6. So this is 0. So here it's 0. So we have 1 and we have 2, we have 3, we have 4, then we have 5, then we have 6. So my other point is here by 6. So I'm done with my what? My x-intercepts. Then now let's move to my y-intercept, right? So my y-intercept is +6. So we go up here. So it's going to be 1. It's going to be 2. It's going to be 3. It's going to be 4. It's going to be 5. And it's going to be 6. Right? So 6 is my what? It's going to be my y-intercept, right? So now we need the turning point. So the turning point, let me just extend this, right, till 8, because of the y-intercept of the turning point is 8. So it's going to be 7 here, then here it's going to be 8, right? So the turning point is what? Is 2 is to 8. So let's go from 2. So it's going to be 2 here, then we go up here by 8. So that's the turning point. Then connect all the points. So it's going to be from here. Let me do it in black. So it's going to be like this. Like this. And that's your graph sketch. So we're done with 4.4. So moving straight, so this is 4.4. Let me write it. 4.4. Yeah. So moving straight to 4.5. They say use the graph to determine the x values. Very important. They want us to determine the x values from which f of x is greater than what? Is greater than 6. So they want us to write the answer in terms of what? In terms of x, but they give us the question, they give us whatever they want in terms of y. So f of x is y. So what they mean here, when y is greater than 6, right? So we need to go to the function, right? Then we need to find where y, right? First, y is equals to 6. Where is y equals to 6? It's here. Let me do it in another color. It's here. So this whole portion, I'm just going to draw a line. This line that I'm drawing, it's when y is equals to 6. So what do they mean when y? Now it's basically y is greater than what? Greater than 6. Meaning when y is greater, meaning can be 7, 8, 9, 10. Where is it? When y is greater than 6, meaning 7 or 8. So y is greater than 6 here at the top. Do you see? Here at the top where I'm highlighting. That's when y is greater than 6. Y is less than 6 is everything at the bottom. See, when 5, 4, 3, 2, 1 is less than and greater is at the top. I hope everyone is okay. So they want the x values when y is what? Is greater than 6. So it's between where? We need to find here, right? We need to write down the coordinate. The coordinate here is what? It's 0 and 6. And remember the fact that we need to write our answers in terms of what? X, right? Then here we need another coordinate here. We need the x coordinate of here, right? So what can I say? I know the fact that this is what? I'm going to do it in pink. This is the turning point, right? And here, my coordinate here is going to be what? It's going to be 2 and 8, right? So I know the fact that this creates symmetry. Remember, this is axis of symmetry here at 2. It creates axis of symmetry. So where is my graph, right? Where is my graph when f of x is greater than 6? It's between this point, right? So it's between this x2 points. I have one point which is 0, and I have another point which is here, right? So I need the x coordinate here. So that is why I know the fact that this is the axis of symmetry, meaning the distance between 0, remember the fact that the x coordinate here is 0, from 0 to here, it's 2 units. So this is 2 units, right? Remember that. And from this point to this point, since this is axis of symmetry, this and this are the same. This another 2 units. So here, the coordinate here, right, is going to be what? It's going to be this 2 plus this 2, which is going to be 4. So here, even if you went down after sketching, but it was going to be 4. Do you see? This is 4 and whatever. We don't need the y coordinate because we need to write everything in terms of what? In terms of x. So my graph, is when f of x is greater than 0, is between which points? It's between when x is between what? Is between greater than, and don't put equals to because of the question didn't say equals to. It's between this point. It's between 0 and 4. Or you could have said x is an element between what? Between curly bracket, because of this is not equals to, between 0 and 4. I hope I didn't confuse anyone on how to do this question. This is the answer for 4.5. So now moving to 4.6, it says sketch the graph g of x, and I gave you g of x as being g of x is equals to negative x minus 1 on the same x-axis, and clearly indicate all the intercepts. So let's find the intercepts of g of x, both x and y. So we know the fact that g of x, right? We know that g of x is equals to negative x minus 1, the x-intercept, right? We need to let y equals to 0. Or in our case, g of x equals to 0. So let's substitute 0. So it's going to be 0 is equals to negative x minus 1. Take the 1 to the other side. It's going to be negative 1 is equals to negative x, right? It's going to be positive 1, taking the 1 to the other side. So therefore, x is going to be equals to what? To negative 1, right? When you divide both sides by negative, right? So therefore you're gonna have your x, remember this is a positive, therefore you're gonna have your coordinate as being what? As being negative 1 and 0, right? So now finding what? My y-intercept. Remember the y-intercept, I can take it from here, right? So my y-intercept is just basically what? It's going to be 0 and c. And in my case, my c is negative 1. So it's going to be 0 and negative 1. So having both my x and y in coordinate, I can plot my graph. So I'm going to plot it in a different color. Let me just make it blue. So it's going to be negative 1, right? My x-intercept, and my y-intercept is again negative 1. So it's going to be negative 1 here again. So connect the two just like that. Connect the two. Then it's going to cut somewhere here like this. And you're done basically answering 4.6. So this graph is for both 4.4 and 4.6, right? And now moving to 4.7. So now moving to 4.7, it says write down the value of x for which f of x multiplied by g of x is less than and equals to 0. Let me explain what that means first before we go straight to the graph and find the solution, right? So let me move this. What does it mean when we say f of x multiplied by g of x, it needs to be greater than and equals to 0? What it means is that when you're multiplying the two graph, right, because if it says less than 0, right, meaning when you're multiplying the two graph, you need to get a what? You need to get a negative value. Remember, since it's saying less than 0, less than, right, let me just, less than, right, means negative. Right? So that's what it means. So multiplying the two graph, right, I need to get what? I need to get a negative. So if this graph is positive multiplied by this graph being negative, what am I going to get? I'm going to get a negative. So meaning I satisfy this condition. And if this graph is negative multiplied by this graph being positive, when I multiply them together, I'm going to get what? I'm going to get a negative, meaning I'm satisfying my condition. But I can't multiply a negative and a negative because of it's going to give me what? A positive, and I cannot multiply a positive and a positive because of it's going to give me what? A positive. So only this two applies. Because we want, when we multiply both the graphs, we're going to get what? We're going to get a negative. So this is what the question means. So for instance, because they might ask it in other questions, it's the same as if they ask the fact that when f of x, right, multiplied by g of x is greater than and equals to 0. Greater than and equals to 0 basically means what? Means this one, greater than, right, means positive. So here, what we're looking for when we multiply both graph, we need to get a positive. So in our case, if f of x is positive and g of x is positive, it's going to be equals to a positive. Then if f of x is negative multiplied by another negative, it's going to give me what? A positive. So this is what it means. So now knowing what to do or what this question means, let's go to the graph and find what they're asking us, right? So remember the fact that we're looking for when f of x, we're looking for when one is positive and the other one is negative, so they can give us a negative, right? That's what we're looking for. We're looking for when they are in opposite signs, right? And f of x, we're looking for what? For the y. We're looking at the y-axis. That's what we're looking for, but we're giving our answers in terms of what? In terms of x. So the first thing first, dealing with this type of questions, right, is that we need to mark the x-intercepts. As I said, the first thing first, we need to mark the x-intercept of both graphs. So we know the fact that the black graph is what? Represents the f of x, right? And the blue graph represents what? The g of x. So first thing first, we need to mark what? The x, or what you call the x-intercepts. So let's do that. So I'm going to do that in orange, sorry. So this is the first intercept, right? And this is another one, and this is another one. So just draw dotted lines. You're going to see they're going to help you out like this. Then draw another dotted line here. Then draw another dotted line here by 6. So you're done doing that, right? Then just mark from your Cartesian plane after sketching. I would advise by the x-axis, right, to mark negative infinity and here positive infinity. It's easy when you're writing when you are writing your answer. Remember, for when you multiply in both graph, right, for it to be negative, one needs to be positive and one needs to be what? To be negative. So let's start here. We see the fact that the blue graph is on the what? Is on the positive, right? It's on the positive what? Positive y-axis, and the black graph here before 2, right? Here, before here. before my dotted line is what is on the bottom. So this area, right, satisfies our condition because of g of x is what is positive, right, and f of x is negative. So when you multiply this 2, you're going to get what? You're going to get what? You're going to get a negative. And remember, we're dealing with when we're looking at it from the y-axis point of view. That is why g of x is negative, and here it's what you call g of x is positive and f of x is negative. So this area here satisfies this condition before the negative 2, before the intercept. So this area, right, from negative infinity till negative 2. Then we see the fact that from negative 2 till negative 1, both graphs are up. Do you see? Both graphs are positive here because of the blue one, which is g of x, is positive. And also, do you see the fact that f of x is also positive? So it doesn't follow this condition because of if we multiply the blue graph and the black graph, right, what are we going to get? We're going to get a positive, which we don't want a positive, we want a negative. So we're going to leave that side. But let's move from negative 1 till 6, right? What do we see? From negative 1 till 6, the blue graph, which g of x, it's negative, right? But the black graph, which is f of x, from negative 1 till 6 is what? Is positive. When we multiply the two, what we're going to get? We're going to get what? We're going to get a negative. So this area also satisfies the condition that we given. So this area, from negative 1 till what? Till 6, right? So let's look from 6 till positive infinity. If I had to extend this graph, right, the blue one and the black one, right, is that we see the fact that after 6, both graphs are what? Are negative. You see, both graphs are negative. And if they both negative, if I multiply the two, I'm going to get what? A positive, which does not satisfy this condition, right? So now we know the fact that the areas that satisfy this condition is the one that I highlighted in yellow, right? So for 4.7, to answer this question, it's from what? It's x is from what? From positive infinity, from negative infinity, sorry, right? So I'm going like this from here till where it ends at negative 2, till negative 2, but square bracket because of the answer set greater than and equals 2, right? Then from negative 2 till 1, nothing happens. They both positive. Then you're going to put the union thing. Then you're going to say another one is from negative 1. Do you see? From negative 1 square bracket till what? Till 6 square bracket because of it's greater than and equals 2. Infinity, positive infinity and negative infinity, we don't put the square bracket. It's always a curly bracket. And this is your answer for this question. So now let's move to 2015. It says the graph f of x is equals to negative 2x plus 18 and g of x is equals to ax squared plus bx plus c. And it says as sketched below. So this is what they sketched. So I'm just going to show you which one is f of x and g of x. So f of x is going to be the one in blue, right? So this is going to be our f of x. So that you can see it visually, because they look quite confusing, right? And our g of x is going to be the one in orange. So the one in orange, I'm going to do this. It's going to be a g of x, and our f of x is the one in blue, right? Then they say point P, which is here, and point Q, which is here, is the x-intercept of what? Of f, which makes sense. Then point Q and R. So we see the fact that Q shares the shares the x-intercept for both g of x and x of x, because they say point Q and R is the x-intercept for what? For g. Then they say S is the turning point of G, so we know the fact that S is the turning point of G. Then T is the y-intercept for barring t is the y-intercept for both of them. So this t, they share both what you call the y-intercept, which is t, and they also share a x-intercept, which is q, right? So they say write down the coordinate of t. So t, so 6.1.1. So we know the fact that since it shares the coordinate, right, and we given that f of x is in terms of a, b, and c, so we know the fact that f of x is negative 2x squared plus 18, right? So we know the fact that we given in terms of a, b, and c because of a is equals to y to negative 2, and our b here is 0, but our c is 18. So therefore the y-intercept, right, for this one is what? Is basically 0, and the c coordinate, the c value. Therefore my y-intercept there here is going to be 0 and what? And 18. So that's our coordinate for t. So t is going to be 0 and 18. Then now moving to 6.1.2, it says determine the coordinate of q. What is q? Q is the y, right? Q is the x-intercept of both graphs, both f of x and g of x. So I can find the q value by equating this by finding the x-intercept of f of x. So 6.1.2, I'm finding the x-intercept, right? Then I'm going to say let y equals to 0, or in our case, let f of x equals 0. So it's going to be 0 is equals to what? Is equals to negative 2x squared plus 18. Take the 18 to the other side. It's going to be negative 18 is equals to negative 2x squared. Then it's going to be the same as saying 18 is equals to what? To 2x squared, because I can divide both sides by what? By negative 1, which is going to give me positive 18 and positive 2x squared. Divide both sides by what? By 2. So I'm going to have x squared being equals to what? It's going to be equals to 9. Then square root both sides. So it's going to be x is equals to plus or minus what? Plus or minus 3. Plus or minus, not square root of 3. Plus or minus 3. Right? Then remember the fact that f of x has two x-intercept, meaning p is going to be the one for negative 3. So this is going to be negative 3 and 0. Therefore, making q to be the one with the positive, so it's going to be 3 and 0. Because of p is on the negative axis and q is on the positive axis. So therefore, q is what? Is 3 and 0. So that's the coordinate of what? Of q. So now moving to what? Moving to 6.1.3, it says given that x is 4.5 at S, determine the coordinate of R. So let's do that. Actually, before I do that, I want to zoom in the picture, the graph, so that you can see how I'm going to explain this question, Anna. So this is how the graph looks up close, right? So what do they did? What did they do? They gave us the x coordinate here of what? Of the S, right? Which is going to be 4.5, right? So what do we know? Since S is the turning point, this x coordinate that they gave us is the what? The axis of symmetry. Just remember that, because that's very important when answering this question. So we know that the axis of symmetry here is 4.5, right? And this is the origin, meaning here it's going to be 0, 0. Then here we already calculated the coordinate, which is what? Which is 3 and 0, right? So now what we need to do is you need to find the coordinate of R, which is I'm going to highlight as being orange, right? So what do we know? We know that the distance between this portion from O till what? Till Q is what? Is actually equals to 3. So from here to here, this length here is what? Is 3. So we know the fact that that length here is 3. So I'm going to do it in orange. So we know that the length here is 3, right? Then I'm going to change my highlighter so that you can see again. Then what do we know? We know that the length from here till the axis of symmetry, right, till here 4.5, it's going to give me what? It's going to give me 4.5, right? Then what do we know? We know the fact that this portion, which is I'm going to highlight with another color so that you can see, we know that this portion, what you call this, QS, right, and SR, these portions are equals to each other, right? We know that these two portions are equals to each other. So this side is equals to this side. So if I can find the distance from here to here, then I can find R. I hope I'm making sense. So now we need to find the small green portion. We know the fact that from here to here, the purple one is 4,5, and the small portion, the yellow one, is what? Is 3. So to find this portion, I'm just going to say 4,5, right? 4,5 minus 3, which is I'm going to get as being 1,5. So I'm going to write it in green so that you guys can see it. So this part is equals to what? To 1,5. Meaning this part is also equals to 1,5. So to find the x coordinate here, right? So to find the x coordinate here, it's basically going to be what? It's going to be this 3, right? Then it's going to be this 1,5 plus this 1,5 is going to give me this r coordinate, right? So it's going to be 3 to find the xr, right? See it. It's going to be this because it's the distance, the r coordinate. It's basically the distance. We need the distance, the entire distance here, like this, to find that x coordinate. Does it make sense? So it's going to be made up of this 3 plus this 1,2 plus this 1,5 and plus this 1,5. So xr is basically equals to what? To 3 plus, right, 1,5 plus 1,5, which is going to give me what? Which is going to give me 6. So therefore, here the coordinate is going to be what? The r coordinate is going to be 6 is 20. So meaning r, let me just write it here. The answer for that question, for the last question, is going to be 6 is 20. I hope that made sense. So now moving to 2014, it says, question 6, given g of x is equals to 4x squared minus 6 and f of x is equals to what? It's equals to 2 root x. What do we see? We see the fact that g of x is the normal function, right? It's a normal quadratic, but f of x is actually an inverse because it's the square root of x, right? They say the graph g and f are sketched below. S, right? So is S is here. So they tell you that S, right? S is the x-intercept G, and abutting X is the x-intercept of G, and K is the point between what? And K is the point between O and S. The straight line OKT with Q on the line of Q on the graph of F and T on the graph of G is parallel to the y-axis. So they're saying this one, right, is parallel to the y-axis. That's what they mean. So now let's move straight to the questions. They say determine the x coordinate of S, which is this one, right, to correct 2 decimal places. What do we know? We know the fact that S is the what? Is the x coordinate of what? Of g of x. So we know the fact that this is the x-intercept, not x-coordinate, x-intercept of the graph g of x. That's what we know, right? So you need to let g of x equals 0, right? Because this is let y equals 0. So in this case, I'm going to say let g of x. So if I see g of x, I'm going to substitute by 0. So this is 6.1. It's going to be 0 is equals to what? Is equals to 4x squared, right, minus 6. Take the 6 to the other side. It's going to be positive. So it's going to be 6 is equals to 4x squared. Then divide both sides by what? Divide both sides by 2. So you're going to have what? You're going to have 3 over 2 is equals to what? Is equals to x squared, right? Then now square root both sides. So you're going to have plus or minus what? Plus or minus 1, 2 is equals to x. But where is S? S is on the positive side. So therefore, x here is going to be equals to what? X here is going to be equals to 1,22, positive 1,22. And that's going to be the x coordinate for S. So we're done with that question. So now moving to 6.2, it says write down the coordinate of the turning point G. So what do we see? We see the fact that the turning point for G, right, which is I'm going to do in blue, this one is the same as what? The turning point. And so we see the fact that the turning point, right, turning point and the y-intercept are the same thing. Do you see that? And the y-intercept are the same, right? So if I find the y-intercept, I can so much just find the turning point, right? So what do we see? We see the fact that they're given our function in terms of A, B, and C, right? So we know the fact that the y-intercept, so 6.2. We know what? We know that the y-intercept, we can write it like this. We can write it as being 0 and C, right? So therefore, our C here, our C is equals to what? Is equals to -6. So therefore, my y-intercept is going to be 0 and -6. Therefore, making my turning point, which is I'm going to say TP, being what? Being 0 and 6. And that's how you find the turning point for 6.2 of G of X. Then 6.3.1 says write down the length of QKT in terms of X, where X is the X coordinate of K. So that's what they want us to write. So to do this is the same as what? Finding the length of OT, right? So we're looking for this length, right? And our answer needs to be in what? The length needs to be in terms of what? Needs to be in terms of X, right? So this and this is the same thing. So QKT is the same as OT. It's that length, right? So what do we see? We see the fact that we have one top graph, which is f of x, and at the bottom we have another graph. So every time when they say the fact that find the length between two graphs, what you're going to do, the length, right? Let me just write it down. The length between two graphs, between two graphs is equals to what? To the top graph, right, minus the bottom graph. Let me just put it like this, minus the bottom graph. Bottom graph. Bottom with an M, sorry. Bottom graph, right? So the length now of what you call QKT is equals to what? Is equals to f of x, right, which is the top graph, minus G of x. What do I know? I know the fact that f of x is given as being what? As being 2 root x. So we know the fact that f of x is 2 root x, and G of x is what? Is minus, open bracket, 4x squared minus 6. Therefore, it's the same as what? As being 2 root x minus 4x squared minus 6. Then this is the length of OKT in terms of what? In terms of x, right? Then this question has like another portion to it, which, as I said, I cannot do on this section because of it's part of what? Is part of calculus. So I'm going to do all those questions in calculus. So this is the end of quadratic. So now we're going to move to what? To hyperbola. So now let's start with hyperbola, right? So as you know, the fact that we're going to start with the mother graph. So it's going to be the mother graph. And the mother graph is what? It's y is equals to 1 over x. Then we're going to move to the general form, which is the one that's important because we're going to look at how each component affects the graph, right? So we move to the general form, and that's what? That's y is equals to a divided by x plus p plus q, right? So with that said, now let's move to the effect of a and see what a does to the graph. Effect of a, right? So we're going to move to the effect of a. So we're going to move to the graphing calculator. So when we get to the graphing calculator, what we're going to do is we're going to first sketch the mother graph. So it's going to be y is equals to 1 divided by what? 1 divided by x. And this is how the graph is, right? So in this case, I'm going to make my a, meaning the first one is going to be positive 1. As you see in the fact that I have positive 1 here, right? Then the other one is going to be when what you call this a is what? Is positive, it's negative 1. So if you say y is equals to negative 1 divided by x, and this is how the graph looks, right? So now let's look when a is equals to 1. We see that the graph exists in which coordinate, we see that the graph exists in the first and the third quadrant, right? So we see the fact that it exists in this part, right? That's when a is what? When a is positive. And when I'm talking about a is positive, I'm talking about the red graph, right? And when a is negative, it's going to exist on the second and fourth quadrant, right? So again, is that we know that a gives us what? The shape. So now let's go right notes. We know the fact that in square bracket here, we know the fact that a and gives the shape. So with that said, we know when a, so let me put a star, when a is greater than 0, meaning a is positive, this is how the graph is going to look. It's going to look like this. It's going to be in the first and third quadrant, right? And when a is less than 0, meaning a is negative, right? It's going to be in which? It's going to be in the second and fourth quadrant. So we know the fact that a what? A gives us the shape. And when it's positive, it's in the first and third quadrant. And when it's negative, it's in the what? It's in the second and fourth quadrant. So this is the effect of a. So now let's move to the effect of p, right? So we're going to move to the graphing calculator. So now we're going to have our a as being positive 1, which is the mother graph, as you see from the red one. Then from that, we're going to check when p is positive and when p is negative, what happens to the graph. So now let's take our p as being positive what? Positive 1, right? So we're going to say y is equals to 1 divided by what? Divided by x plus 1, right? So what do we see? The graph that we're looking at that has a positive 1 is the blue one, right? We see that the graph has moved, right? See, from here, from this point, it has moved like to the what? To the left. So we see that the graph has moved to the left, and again is that it has a new asymptote. I'm going to discuss more asymptote when we go to the lines, right? So if I take that, if I equate, let me go this side and basically show you guys. You know the fact that with p we need to solve this, right? And that side I have my p as what? I have this equation. I have y is equals to 1 divided by x plus p, right? Plus 1. That's what I mean. Plus 1, right? So with that, to solve for your p, I need to basically solve the 1 in the denominator. So it's going to be x plus 1 is equals to 0. Then therefore x is equals to negative 1, right? So this x negative 1 is what? It's my vertical asymptote. So I'm going to call it VS, right? So if I take that, if I say x is equals to negative 1, what do I see? I see the fact that the graph does not touch this line. If you see it, the graph never touches this line. Where in the red one, right, my asymptote, my vertical asymptote is actually 0. So if I say x is equals to 0, do you see the fact that the graph, the red graph, right? Look at the red graph. It never ever touches what? The purple line. I hope you can see that. And now with the blue graph, it never touches what? It never touches my green graph. So that's my asymptote. I hope that makes sense. So 1, we know that P is our vertical asymptote, and 2 is that when P is positive, it moves the graph where? It moves the graph to the left. Same applies when we were doing quadratic. P, the sign that you're given, it shifts the graph the opposite side, right? I hope I didn't confuse everyone and you guys are okay. So now let's take what? Let's take our P, right, as being negative. So if I say y is equals to 1 divided by x minus 1, do you see the black graph? It's going to move the graph to the right? And again, is that if we go back and have to solve my P, so if I take that equation, I'm going to do it in green and say y is equals to 1 divided by x minus 1, right? And take this portion and equate it to 0. If I say x minus 1 is equals to 0, therefore x is equals to 1, right? That's going to be my vertical asymptote, right, for the black graph. So if I take that one and I say x is equals to 1, right, do you see the fact that the red vertical line, this line, right, the red one, is going to be what? Your vertical asymptote for the black graph, right? So again, is that P is what? It's my vertical asymptote. Also, it's what? It shifts the graph left or right? So now let's go and write the notes. So let me just erase this, right? So what do we know? We know the fact that P moves the graph, right? Moves the graph left or right? That's what we know. And also another important point is that P is also known, right, as the vertical asymptote. Right? And what is an asymptote? I'm just going to write it in green. Asymptote is what? Is asymptote. This is like not the direct, definition, but I just want you guys to understand it in a general form, right? Asymptote is where the graph does not touch or exist, right? As you see here in the graph, is that the graph never touches the asymptote. It never touches, even if it looks like it's close by it, but it never touches. So that's what it means, right? So now let's talk when P is positive and when P is negative, right? So when P is greater than 0, meaning it's positive, right? And when I mean P, I mean like this. I'm going to just write the equation when y is equals to a divided by x plus P. So when P is positive from here, right, then we know that the graph is going to move to the what? The graph is going to move to the left, right? And also the vertical asymptote, right? So the vertical asymptote here, when we solve it, asymptote is going to be what? It's going to be from here, it's going to be x plus P is equals to 0. Therefore, x is equals to negative P. So that's what we know when P is positive now. So now when P is negative, so I'm going to say when P, let me just write it here. when P is less than 0, meaning it's negative, right? Meaning it's like this. Y is equals to 1 to A divided by what? By X minus P, right? So the graph is going to move to the what? It's going to move to the right, right? And the vertical asymptote is what? It's going to be X minus P is equals to 0. Therefore, X is equals to P. So that's going to be your vertical asymptote. So that's the two important points that you need to understand about the effect of P. So now let's move to the effect of Q, right? So we're going to move to the graphing calculator. So you can have your mother graph first. Then we're going to check when Q is positive and when Q is negative. So now what we're going to start with, we're going to start when Q is positive 1. So if you say Y is equals to 1 divided by X, then you're going to say plus 1. What do you see? You see that your graph is going to go what? It's going to go 1 unit up. Another thing that you need to understand about Q is actually our vertical asymptote. So I'm going to start by the mother graph showing you when the vertical, what you call this, the horizontal, not vertical, sorry guys, the horizontal asymptote, right? So when Q on the mother graph is actually 0, right? Because there isn't any P and there isn't any Q. So here when we say Y is equals to 0, right, that's going to be what? That's going to be our horizontal asymptote. What do you see? Just look at the what? Just look at the red graph. You see the fact that the graph never touches the line at Y is equals to 0, right? So here on the blue one, our horizontal asymptote is actually Y is equals to 1. Our Q value is our horizontal asymptote. So if we say Y is equals to 1, what do you see? Do you see the purple line? This one, the purple line, this one, right? Do you see? You see that the graph never, and we're looking at the blue graph, the blue graph never touches that line at all. It never touches that line. So when what? First thing is that Q is our horizontal asymptote where the graph never touches that line. And two, another thing is that when Q is positive, it moves the graph upwards, right? So now let's make our Q what? Our Q negative. So it's going to be Y is equals to what? To 1 divided by X. Then we're going to say minus 1. That's going to be the black graph. What do you see? You see that the graph shifts from the red one. Remember the fact that we're always looking at the red one in retrospect of the red one. The graph moves down by 1 unit, right? And another thing is that remember the fact that the Q value is our horizontal asymptote. So therefore, we know the fact that here our horizontal asymptote is going to be Y is equals to negative 1. What do you see? Looking at the red straight line, right, is that the graph never touches, the black graph never touches what? Never touches the red line, right? So now let's go and make notes. Right? So what do we know first about Q? That it moves the graph up and down, right? So we know that it moves the graph up or down. That's what we know, right? And another important point is that it is also, right? It's also known as the horizontal asymptote. Asymptote, not asymptotes, right? So that's what we know. So knowing from that, we know the fact that when Q, right, is greater than 0, what happens is that remember when Q is greater than 0, it's positive, Q is positive, the graph, right, the graph moves up. and also the horizontal asymptote, which is, I'm going to call it HA, which is horizontal asymptote, is going to be equals to what? It's going to be y is equals to what? To q, right? And here, when q is less than 0, meaning it's negative, the graph, right, moves down, meaning our horizontal asymptote is going to be y is equals to negative q. So that's the two important effects that you need to know about what? About the effects of q. So now let's talk about asymptotes, and I know I've already talked about it when we were talking about the effects of P and Q, but I just want to have slight notes for it so that you guys know what's asymptote. As I said when we were talking about P, that asymptote is where the graph does not touch. So where the graph doesn't touch at all, that's your asymptote, right? So we have two of them. We have the vertical asymptote and we have the horizontal asymptote. So your vertical asymptote comes from P. So I'm going to write the note. So I'm going to say vertical asymptote. Right? And with that one, together you need to solve for your P here, right? So you're going to say x plus P, right? It's going to be equals to 0. Therefore, x is equals to negative P. That's going to be what? That's going to be your vertical asymptote, right? Then we have another one, which is your horizontal asymptote. Which is your what? Which is your Q. And to solve it, it's basically y is equals to what? To q, right? So that's going to be your what? Your vertical and what? And horizontal asymptote. So now let's do an example. It says f of x, they give us the equation of the hyperbola, right? And it says write down the asymptote, right? So solution. So what do we know? We know the fact that we have two asymptotes. We have the vertical asymptote and we have the horizontal asymptote. So for the vertical asymptote, I'm just going to call it VA, representing vertical asymptote. And remember, with the vertical asymptote, what we need to do, we need to solve for what? We need to solve for the denominator. So it's going to be x minus 1 is equals to 0. Therefore, x is going to be equals to 1. And that's going to be your what? That's going to be your vertical asymptote. Then for your horizontal asymptote, which is, I'm going to name it as HA, right? It's going to be what? It's going to be equals to Q. So you're just going to say y is equals to Q, which is this one. So y is going to be equals to 2. And that's going to be your vertical asymptote. And that's going to be your horizontal asymptote. So now let's move to domain and range, right? With domain and range, we need to take into account what? Our asymptote, right? So with domain, right, we need what? We need our vertical asymptote, right? So if we take like just the general equation, let me just write it down here. If I say y is equals to a divided by x plus p, right, plus q. So we know the fact that from here, our what? Our vertical asymptote is what? It's going to be x, right, plus p is equals to 0. Therefore, x is equals to negative p. So here to write our domain is going to be what? It's going to be, you're going to say x is an element of real numbers, right? Then taking what? Taking your vertical asymptote, you're going to say x is not equals to negative p. Which makes sense because of the graph does not exist by the vertical asymptote. So it's all values, right? When you say x is an element of real numbers, you're basically saying the fact that the graph exists everywhere besides where? Besides at the asymptote. That's why we say x is not equals to what? To the vertical asymptote. So now moving to our range. With range, we're going to take what? Our horizontal asymptote, which here we know it as being q. So it's going to be y is equals to q. right? So you're going to say your range is going to be y is an element of real numbers, but the graph does not exist where it does not exist by q. So you're going to say y is not equals to q. And that's how you would write your vertical and horizontal asymptote. So now let's do an example. It says determine the domain and range, and they give you a function, right? So now let's start with domain. So we know that domain, what we're going to need the vertical asymptote, right? So when we need the vertical asymptote, we're going to take this as being x minus 1 is equals to 0. Therefore, x is equals to positive 1. So your domain here is going to be x is an element of real numbers, but we know the fact that the graph does not exist by the asymptote. So we're going to say x is not equals to 1. That's our domain. And now let's do our range. We're going to take we're going to take our horizontal asymptote, which we know as being y is equals to the q, which is q is 2 here, so it's going to be equals to 2, right? But we know to write our range, we're going to say y is an element of real numbers, but y is not equals to 2. And that's how you would write your domain and range. So now let's talk about the axis of symmetry, right? That's where the graph are symmetrical to each other. So in hyperbola, we have two equations of axis of symmetry. So let me write the heading is equations for axis of symmetry. So we have two equations, right? We have one that's a positive and the other one is a negative. So we have the first one as being what? As being the positive gradient. Right? And when we have the equation is like this, it's going to be y is equals to x plus c. See, the positive gradient comes from the coefficient of x. You see the fact that it's positive 1. And we have another one which is a negative gradient. And that's going to be what? Y is equals to minus x plus c, right? And now to solve for c, to find c basically, to find c, what do we need? We use this coordinate, which is your vertical asymptote and your horizontal asymptote. We use the value of p and q. So that you guys can see it in action and know how to solve it, we're going to do an example now. So now let's talk about determining the equation, determining the axis of symmetry, right? So solution. What do we know? We know the fact that we have two equations. We have the one with the positive gradient and the other one with the negative gradient. So I'm just going to write both of them. So we're going to be the first one, which is the positive gradient. Or let's start with the positive gradient, right? We know the fact that the equation says y is equals to x plus what? Plus c. What do we need? We need the value of p and q to substitute here so we can solve it, right? So finding the coordinate, right? So for p, what do we need? We need this. We need to solve for p here. So we know the fact that we need this. We need p and q, right? The coordinate. So for p, we need to solve it. So it's going to be x plus 1 is equals to 0. Therefore, x is equals to negative 1. So we know that our p here is going to be equals to negative 1. Then our q is from here, which is negative 2, right? So we know the fact that q is equals to negative 2. So therefore, making our coordinate what? Negative 1 and negative 2. I hope that made sense, right? So I'm just going to write the coordinate here in orange so that I can solve it here. So you know the fact that the coordinate is negative 1 and negative 2, right? Let me erase this for space. So now we're going to substitute this coordinate way here, right? So we know the fact that negative 2 is going to be our y, so it's going to be negative 2 is equals to negative 1 plus c. Take the 1 to the other side, is going to be negative 2 plus 1 is equals to c. Therefore, c is going to be equals to what? To negative 1, right? So now rewrite the equation. Is going to be y is equals to x minus 1. So this is the equation, the axis of symmetry when the gradient is positive. So now let's move when it's negative, right? So this is negative gradient. So with negative gradient, we know the fact that y is going to be equals to negative x plus c. Then we're going to substitute our coordinate. So it's going to be negative 2 is equals to negative, open bracket, negative 1 plus c. Then this is going to be basically negative 2 is equals to what? 2 positive 1 plus c. Take the 1 to the other side, is negative 2, negative 1 is equals to c. Therefore, c is equals to negative 3. So the one with the negative gradient is going to be basically, it's going to be basically equals to y is equals to what? To negative x minus 3. And this are your two equations. This one is when it's a positive gradient, and this one is when it's a negative gradient. So now let's move to sketching a hyperbola. So let me write you the 3 things that you need when you're sketching it. So the first thing that you're going to need is going to be the sine of A. And remember that the sine of A gives us what? Gives us the shape, right? The sine of A, because it gives us the shape of the graph, right? And number 2, you're going to need what? You're going to need your asymptotes, right? You're going to need your asymptotes. Then number 3, you're going to need your intercepts. And remember, with intercept, it's the same with linear, and it's also the same with what? It's also the same with parabola. This is for sketching a hyperbola, right? So now we're going to move to past paper questions. So now let's move to the first question. This is from 2021. It says, it gives us a function. It says given f of x is equals to negative 1 divided by x minus 3 plus 2. Then the first question, it says write down the equation of the asymptotes, right? So we need to write both the equation of the asymptotes. So we're going to say 5.1. We need the vertical and horizontal asymptote. So I'm going to call it VA for vertical asymptote. And remember, for the vertical asymptote, we take it from here. So it's going to be what? It's going to be x minus 3 is equals to 0. Therefore, x is going to be equals to what? To positive 3. Then for the horizontal asymptote, it's going to be what? It's going to be this 2. So you're just going to say y is equals to what? To 2. And that's your vertical and horizontal asymptote. Then now we're going to move to what? We're going to move to 5.2. It says write down the domain of f of x. So remember the fact that for domain of a hyperbola, what do we need? We need the vertical asymptote, which is the one with x. So we know that our vertical asymptote is x is equals to 3. Therefore, our domain is going to be what? It's going to be x is an element of real numbers, and x does not exist where? Does not exist at 3. Therefore, x is not equals to 3. And that will be your what? Your domain. So now moving to what? We're going to move to determine the coordinate of the x-intercept. Remember the fact that x-intercept, we're going to let what? We're going to let y equals to 0. So x-intercept, right? And we're going to let y equals to what? Equals to 0. So here in the equation, wherever I see y, I'm going to substitute by 0. Or f of x, wherever I see y or f of x, I'm going to substitute by 0. So it's going to be 0 is equals to what? To negative 1 divided by what? Divided by x minus 3 plus 2. So I'm going to take the 2 to the other side. So you're going to have negative 2 is equals to negative 1 divided by what? By x minus 3. This negative 2 is the same as what? Divided by 1. So I can cross multiply. So when I say negative 2 multiplied by negative 3 by x minus 3, I'm going to get negative 2, open bracket, x minus 3 Then when I say 1 multiplied by -1, I'm going to get -1. I'm going to distribute the 2, so it's going to be -2x plus 6. Then the side is going to be -1. I'm going to take the 6 to the other side, so I'm going to have -2 is equals to what? To -1, -6. Therefore, -2x, right? So -2x is going to be equals to -7. Divide both sides by 2, so it's going to be x is equals to 7 over 2. And that's going to be what? That's going to be your x coordinate of your x-intercept. Write it in coordinate form. It's going to be what? It's going to be 7 divided by 2 is 0. So that would be your x-intercept coordinate. So now moving to 5.4, it says write down the coordinates of the y-intercept, right? So what we're going to do is that, with y-intercept, imagine y-intercepts, we need to let what? We need to let x equals to 0. So y-intercepts, not without an e, so we're just going to say let what? Let x equals 0. So here by the equation, what we're going to do is wherever we see x, we're going to substitute by 0. So it's going to be y. I'm going to change the f of x in being y. So I'm going to say y is equals to -1 divided by 0 minus 3 plus 2. When you punch that into the calculator, you're going to get your y being equals to what? Being equals to 7 divided by 3. Therefore, your coordinate here is going to be what? It's going to be 0 is to what? Is to 7 over 3. And that's your y-intercept coordinate. So now moving to the last question, which is 5.5. It says, draw the graph of f, clearly indicate all the asymptote and intercepts with the x's, right? So what do we know? We know the fact that to sketch a graph, you need what? You need your sine of a, which is we're going to start with that one. So we know the fact that a is going to be equals to what? The one that's on top on the numerator is your a, so it's equals to -1. And -1 is less than 0 because it's negative. Therefore, our shape is going to be where? It's going to be in our second and fourth quadrant, right? Then you need your asymptote. We already calculated them in the first question. Then you need your x and y intercept that we calculated in our third and fourth question, right? So now let's sketch it. So I'm just going to draw the Cartesian plane. So that's this. This is our x and y. This is y. And this is x. So I'm going to start with what? Which is I'm going to do it with orange. I'm going to start with my vertical and horizontal asymptote. So what do we see? We see the fact that my vertical asymptote is +3, sorry. So this is 1, this is 2, and this is 3. So this 3, let me write it down. So +3, right? So by there, I'm going to draw a line going down. This is going to represent what? My vertical asymptote, like this, right? Then I see the fact that my horizontal asymptote is +2. So it's going to be 1, 2. So 2 here, I'm going to put a dot. Then I'm going to draw a line going horizontal like this. So now we have put down our what? Our vertical and horizontal asymptote. So now let's go to the intercepts, right? So with intercept, we know the fact that the first one is what? Is 7/2. Our x-intercept is 7/2 is to 0, which is the same as what? Which is the same as saying, this coordinate is the same as saying 3,5 is to 5, right? So we know the fact that it's positive, so it's 1, 2, 3, 4, right? This is 4. 3,5 is here, so this is what? This is our x-intercept. Then we see the fact that our y-intercept is the same as saying what? 0 is to what? Is to 2, 3, and 3 is recurring, right? So we know the fact that it's +2, so it's going to be 1, 2, 3. Then 2, 3 is somewhere here. So we know the fact that this is going to be what? This is going to be my y-intercept. So now, remember that the shape, it goes from the what? From the second and fourth quadrant. When we look at quadrant, we look at here. See, it's divided by your asymptote. Your quadrant that's divided by your asymptote. This will be the first one, this will be the second one, this will be the third one, and this would be the fourth one. So we know the fact that it's by the second one, so it's gonna go like this, the shape. And here by the fourth quadrant, so it's gonna go like this. Remember, the graph doesn't go through what? Your asymptote. And this is your graph when you're done sketching it. So now we're going to move to 2020, right? Question 4. So the first question, so it says given h of x, then they give you the equation. And we know that the equation is a hyperbola, right? So they say write down the equation of the asymptote. So you know the fact that you have two asymptotes. You have the vertical and horizontal asymptote. So 4.1.1, first with the vertical asymptote, right? You know the fact that you need to take the denominator and equate it by 0. So you're going to say x minus 1 is equals to 0. Therefore, x is going to be equals to positive 1. And that's going to be your horizontal, your vertical asymptote. And now we're going to move to horizontal asymptote. So horizontal asymptote is going to be y is equals to q, which is in our case q is 2. So it's going to be y is equals to 2. So that will be your vertical asymptote and your horizontal asymptote. So now moving to 4.1.2, it says determine the equation of the axis of symmetry of h that has a negative gradient. Remember when we talked about axis of symmetry, I said there's two equations, one with negative and one with positive. So the one with the negative gradient, right? So 4.1.2, the one with the negative gradient is this one, is y is equals to negative x plus c. To find your c value, you need what? You need your p and q. Which is your p and q is what? It's your equation, is actually your equation of asymptote, right? So your x coordinate is going to be this one that you found as being your vertical asymptote, so it's going to be 1. And your y coordinate is going to be what? It's going to be this one, which is your horizontal asymptote, which is going to be 2. So I'm going to substitute this one in 2 to find my c. So it's going to be 2 is equals to what? Is equals to negative 1, right? Plus c, which is, this is the same as negative 1. So it's going to be 2 is equals to negative 1 plus c. Take this one to the other side. It's going to be 2 plus 1 is equals to c. Therefore, c is going to be equals to 3. Then rewrite the equation. Therefore, you have y is equals to negative x plus 3. So this is your equation for the axis of symmetry when it's a negative gradient. So now let's move to the last question, which is 4.1.3. It says sketch the graph h showing the asymptote and the intercept within the axis, right? So what do we have? We have the asymptotes, but we do not have the x and y intercept. So let's solve that. So 4.1.3, we need to solve the x and y intercept. So it's going to be x intercept, right? It's going to be equals to what? We're going to say let y equals to 0, which is in our case let h of x equals to 0. So it's going to be 0 is equals to negative 3 divided by x minus 1 plus 2. Take the 2 to the other side, so it's going to be negative 2 is equals to negative 3 divided by x minus 1. This is the same as negative 1, so we're going to cross multiply. When we cross multiply, we're going to have negative 2. Then it's going to be x minus 1, and it's going to be 1 multiplied by negative 3, which is negative 3. Distribute the negative 2, you're going to have negative 2x plus 2 is equals to negative 3. Take the 2 to the other side, so you're going to have negative 2x is equals to negative 3, right? Negative 2. Therefore, it's going to be negative 2x is equals to negative 5. Divide both sides by negative 2, so you're going to have x as being equals to 5 over 2, making our coordinate here for the x-intercept being 5 over 2 is to what? Is to 0. So now let's solve for what? Let's solve for my y-intercept. So it's going to be y-intercept, right? And we're going to let what? We're going to let x to be equals to 0. So we know that our function is h of x is equals to what? To negative 3 divided by x minus 1 plus 2. So it's going to be y. I'm going to change the h of x to be y. So it's going to be y is equals to negative 3 divided by what? Divided by 0 minus 1 plus 2. Punch this into the calculator. You're going to get your y as being equals to what? As being equals to 5. Making our coordinate here is 2 being 0 is 2, 5. So I'm going to clean this and write my x and y intercept on the top. So now let's sketch the graph. So let's draw the Cartesian plane first. We're going to start with our asymptote. So this is going to be y-axis, and this is going to be my x-axis, right? So you're going to start with what? We're going to start with my asymptote. So I'm going to start with my what? With my vertical asymptote, which is 1. So it's going to be here. So I'm going to put a start. This is 1 here, right? Then we're going to go, and I'm going to draw a dotted line there, going like this, representing what? Representing my vertical asymptote. Then I'm gonna go and write or draw a line for my vertical asymptote, for my horizontal horizontal asymptote. So this is 1 and this is 2. So it's gonna be here. This is what? This is gonna represent my horizontal asymptote. So I'm gonna draw a line there. So we're done sketching the horizontal asymptote. And one more thing, which is I forgot, we need to find the sign of A. We see the fact that A is equals to what? Let me go to the side. Is equals to negative 3, right? So it's equals to negative 3, which is less than 0. Meaning our graph is going to be like the what? It's going to be like this. It's going to be on the second and fourth quadrant, right? So this is reference when we actually draw the graph. Does it look like this? Right? So now we need to what? We need to plot our x and y intercept. So this one is the same as saying what? It's the same as saying 2,5. 2,5 is to what? Is to 0. So now we need a positive 2,5. This is 1 and this is going to be 2. So therefore this is 3. Therefore 2,5 is here. This is what? Our x-intercept. And our y-intercept is 5. So this is 1. This is 2. This is 3. This is 4 and this is 5. So it's going to be here. So our graph is going to go like this. Which matches with this one because it's in the fourth quadrant. And it's going to go like this. It needs to cut at 5 here. So it's going to go like this. Which is correct because of it's in the second quadrant. So this is how the graph is going to look, right? And we're done with 2020. So now let's move to 2019. Let me write it down here. This is 2019, right? So it says below is a graph f of x, which is they give you f as x as being x squared plus bx minus 3 and g of x as being equals to a divided by x plus p. So what do we see from the start, from the question, from the first line that I just read, is that we have two graphs. One is a quadratic function and the other one is the hyperbola. F of x is quadratic and g of x is hyperbola. So they tell you that f has a turning point at C and passes through the x-axis at 1 and 0. So that's what they told us. They told us the fact that C is the turning point and 1 and 0 is the x-intercept, right? One of the x-intercept for f. Then they say D is the y-intercept, right? Which is here. D is the y-intercept for both f and g. Then they say the graph f and g also intersect each other at E. So we know the fact that the graph f of x and g of x intersect each other at E and also at D, right? Then they say the vertical asymptote of G passes through the x-intercept, through the x-intercept of f. So what do we know? We know the fact that 1 and 0 is 1 is the x-intercept for f of x and also is the vertical asymptote for what? For g of x. So that's the two information that we know. So let me just write it down for you guys. So we see that this point is what? Is the x-intercept for f of x, and is also the vertical asymptote for what? For g of x. So that's what I mean, right? So now let's move on to the questions, which is 5.1. So the first question says, write down the value of p. What is p? P is the vertical asymptote, which is this one, which is our road, which is we know as being what? As being this coordinate, which is 1 and 0, right? So we need to write the value of p. To write the value of p, we're going to equate this value by, we're going to equate it to x, right? So we're going to say first x is equals to 1. The reason why we first equated to x is because of we need to reverse it so that we can find the value of p. So take 1 to the other side, so it's going to be x minus 1 is equals to 0. Therefore, this value that I'm just underlining is going to be p. So therefore, my p is going to be equals to -1. Remember, if you are given from the graph, to find your p, you need to equate that value of p into 0, then reverse it so that you can find the actual value of p. So here p is equals to -1. So now moving to 4.1, it says show that a is equals to 3 and b is equals to what? Is equals to c. So for a is equals to b is from what? Is from f of x. Then our a is from g of x. So first let's go to the graph and fill in the information that we need. First of all, for what? For to find what? To find my b here, we can use this coordinate of 1 is to 0, because of we know that coordinate is what? Is equals to 1 is to 0, which is our y-intercept for what? For f of x, right? So I'm going to use that to calculate b, because of if I substitute x and y, the only unknown value that's going to be left there is going to be what? It's going to be my b. So let me write it. So it's going to be f of x is going to be equals to what? Is equals to x squared plus bx plus what? Not plus, minus 3. So it's going to be minus 3, right? So we're going to substitute this 1 is to 0. So let's do that. Let me move my screen. Let me move my page, sorry. So I'm going to substitute. So it's going to be 0 here is equals to, then we're going to substitute 1. So it's going to be 1 squared plus b, then it's going to be 1 minus 3. So this is the same as 0 is equals to 1 plus b minus 3. 1 minus 3 is going to give me minus 2. So it's going to be 0 is equals to b minus 2. Take the 2 to the other side. So therefore b is going to be equals to 2. So we have solved our b as being positive 2. So now let's move to calculating what? Calculating a, right? So we still in 4.2. So for a, we know what? A is g of x. So we know the fact that it's going to be g of x is equals to a divided by what? By x plus p. Remember the fact that we already calculated what is our p. Our p is -1. So I'm going to rewrite it. It's going to be g of x. And remember, it comes from here. Remember the fact that this point that I'm going to do in yellow, in orange, is what? Is our x-intercept for f of x, and is also the vertical asymptote for what? For g of x. So let's substitute my p. So my p is going to be a divided by what? By x minus 1, right? So now we need to calculate a. What do we see? Another point that this share is what? Is d, right? We know the fact that d is what? Is both the x-intercept for f of x and both also for g of x. What do we see? We see the fact that from f of x is written in terms of a, b, and c, and always our c value is what? Is our coordinate for my y-intercept. So this is going to be what? 0 and -3. So I'm going to substitute my d here to find my a. So let me do that. So I'm going to say substitute, right? d, which is the coordinate, is 0 and -3 to get my a. So let's substitute that. So it's going to be -3 is equals to a divided by what? Divided by 0 minus 1. 0 minus 1 is basically going to give me, this is going to be -3 is equals to a divided by -1, which is the same as -3 is equals to -a. Therefore, a is equals to +3, which is what you get exactly here. So we just showed the fact that A is equals to 3 and B is equals to 2. So now let's move to 4.3. It says calculate the coordinate of C. What is C? C is the turning point. So C is the turning point, right? So C is the turning point. Let me write it down. I'm going to move the page, right? So we know the fact that from the turning point, we're going to use f of x is equals to x squared. Then we're going to substitute our b. So it's going to be plus 2x minus 3. Let me move it to the side. So I'm going to use this equation to solve for my turning point. So I'm going to say x is equals to what? To negative b divided by 2a. What is my a here? My a is equals to 1 and my b is going to be equals to positive 2. Substitute my b and a. So x is going to be equals to what? To negative 2 divided by 2 open bracket 1. Therefore making what? Punching this into the calculator, making my a equals to what? My a is going to be equals to negative 1. So now I'm going to substitute my negative 1 into this function. So I'm going to find f of negative 1. It's going to be equals to, it's going to be negative 1 all squared plus 2 negative 1 minus 3. Punch that into the calculator. You're going to get your y coordinate as being negative 4. Therefore, making your c coordinate into being negative 1 and negative 4. Then you're done finding your c coordinate. So 4.4 says write down the range of f, right? So to write down the range of f, we need to check between f of x and g of x. What is f of x? F of x is the quadratic. So when we write down the range of a quadratic, remember you need two things. You need the sign of a and you need your q. So we know that a is equals to what? Is equals to 1, which is greater than 0, meaning it's positive. And here my q is what? Is from the turning point, which is q is negative 4. So therefore, my range here is going to be equals to what? So my range here is going to be y is greater than and equals to negative 4. Then you're done finding your range. So now we're not going to do 4.5 and 4.6 because of 4.5 falls under analytic, but I want to do it together with 4.6 because 4.6 is calculus, right? So I'm going to do 4.5 and 4.6 when we do calculus. So now let's move to 4.7. It says the function h of x is equals to f of x, then open bracket m minus x plus q has only one x-intercept, and they give us as being what? As x is equals to 0, right? Then they tell us determine the values of m and q. So first thing first, what we're going to do here, we're going to find the value of q first. Then we're going to move to what? To the value of m. So to find the value of q, I need to rewrite the equation in terms of the turning point, right? When I say the equation in terms of the turning point, f of x, right, is written in which term? Is written in terms of a, b, and c, which is like this, right? Plus bx, right, minus 3, where my b is 2. So let me just write that. So it's going to be plus 2x minus 3. Writing that in terms of turning point is going to be f of x is equals to what? It's basically equals to a as being 1. So it's going to be open bracket. It's going to be x. Then my turning point here for the x, the peak value is negative 1. When you put it here inside the bracket, it's the opposite sign of this. So it's going to be plus 1 all squared. Then it's going to be what? Minus 4. This is writing the turning points in terms of what? In terms of, this is writing the quadratic function in terms of the turning point. This is what I mean. So what do we have? They tell us the fact that h of x, right, is equals to what? To f, then is m, right, minus x, then plus q, right? We need our q. So from here, from the original, not h of x, our q is negative 4. But now we need to write it when this one affects my graph, right? So I need to write my q when this one affects the graph. So let's do that. So I'm going to take just this portion. I'm just going to highlight. I'm just going to take this portion and rewrite it where x starts first and the number follows. Because you remember the fact that our function is not the number first then the x value. It's always the x value then the p value, right? Where m here, it's like kind of like the p value. So let's do that. So I'm going to take this portion, which is f is equals to m minus x, right? And I'm going to rewrite it where p is on the other side. So when I do that, I'm going to take out the negative sign. So I'm going to be left with what? I'm going to be left with inside is going to be, this one is going to change. The x is going to be changed into being a positive. So it's going to be x. Then the m is going to change into being what? A negative. So it's going to be negative m. And the reason why I could do that because of I took out this negative sign. I took out a negative sign outside. So if I distribute the negative sign inside again, it's going to go back to being this one. I hope I didn't confuse anyone, right? So now I'm going to take this and substitute it here, right? So if I say negative f, right, then it's going to be x minus m, right, and substitute it here. It's going to be the same as open square bracket. This is going to be negative, and this whole thing is going to be inside here. So it's going to be negative x plus 1 all squared minus 4 close bracket. Distributing the 1, you're going to have this as being what? As being negative. This is going to be x plus 1 all squared, and this is going to be plus 4. Therefore, making my q value equals to what? To 4. So now we know the fact that q is equals to 4 here, right? That's that, right? So now, knowing that, we need to substitute, we need to solve for what? We need to solve for m. So we know the fact that when we substitute what you call this coordinate way, this is our y-intercept, which is, if it's our y-intercept, this is 0, 0, right? If we substitute 0, 0, we can find our m. So that's what we're going to do now. So now, since I wrote this like this, right, this is the same as being h of x. So I'm going to write this as being h of x is equals to this part, right? But with the m. Sorry, here I forgot m. So it's going to be, this is going to be minus m. I think when I solved it, I forgot the m. This is minus m. And this is minus m. The reason why I forgot the m, I was focusing more on finding the q, right? So here, h of x is the same as what? It's the same as saying minus, and this is going to be x minus m plus 1 all squared. Then this is going to be plus 4, right? This is what I meant to write. Sorry for the confusion. I'm really sorry for the confusion, but I was just focusing on finding my q. But you needed to put your negative m because of here. Remember the fact that you need to substitute x minus m, which is I did here, right? So now we see the fact that they gave us the x-intercept as being 0, 0, because they tell us is that at the x-intercept is equals to 0, meaning the coordinate is 0, 0. Because of x-intercept, you let y equals to 0. That's why the coordinate there is 0, 0. So I'm going to substitute 0 here. And wherever I see x, I'm going to substitute by 0. So it's going to be minus, open here, it's going to be 0, minus m plus 1 all squared plus 4, right? Then I'm going to take the 4 to the other side. So it's going to be negative 4 is equals to what? To negative. This is going to be minus m plus 1 all squared, right? So the negatives are going to cancel each other. So it's going to be 4 is equals to, I'm just going to write the 1 in front. So it's going to be 1 minus m all squared. Square root both side. I'm going to get it to be what? To be 2 is equals to 1 minus m, right? Then I'm going to take the 1 to the other side. So it's going to be what? It's going to be 1 is equals to negative m. Then take it, dividing both sides by negative 1. I'm going to get my m being positive and my 1 being negative 1. So therefore, m is going to be equals to negative 1, right? So let's just break it down again on how I did it. Is that they tell us that h of x is equals to f of x, then open bracket m minus x plus q. How we going to get our q is that we need to rewrite this in terms of what? In terms of our turning point, which is I did here, right? Then after that is that since our equation, when you see the equation, it never starts with the value first, it always starts with x. So I needed to rewrite this one in terms of what? Where x comes first. And to do that, I took out the negative sign, which is this one, right? Then what I did is I found the negative f of x when x minus m. Basically, I took this one, but I rewrote it where there is m. That is why here I said the fact that they needed to be an m. So let me just rewrite it properly here. so that no one is confused. So it's going to be what? It's going to be open bracket. It's going to be x minus m, right? Plus 1, right? All squared plus 4. Then close bracket. This is a square bracket, right? Then we distributed what? We distributed the x there. So it's going to be what? It's going to be here. It's going to be minus. Then it's going to be x minus m plus 1 all squared. Then this is going to be what? A positive 4. Remember here it's going to be a negative from the original. So it's going to be negative. I hope still I didn't confuse anyone, right? So after doing that is that we know the fact that this one that we just wrote here is the same as h of x. And we already calculated that our q is going to be what? 4. So the reason why we did all the steps is to find our what? Our q value. Because at first our equation was written in terms of a, b, and c. And now we wrote it in terms of q, in terms of the turning point, because of q is the y-intercept of the turning point. I hope I'm making sense. So therefore, our q value here to answer here, q is equals to 4, right? So we find our q. So therefore, this one and h of x is exactly the same thing. So h of x is exactly equals to this, right? So I said, instead of saying negative f of x, x minus m, I said h of x is equals to exactly this one, right? Then after doing that, now we need to find what? Our m value, right? To do that, to find our m value, what are we given? We're given that the y-intercept is equals to 0. Remember, to find the y-intercept, we need to let y equals to 0. And that is why the coordinate here is 0 to 0. We substitute 0 to 0, then we solve for m. So therefore, my q is going to be equals to 4, and my m is going to be equals to negative 1. So that's how you find your q and m. Okay, now we're going to move to 2018. So it says given f of x is equals to negative 1 divided by x minus 1. The first question says write down the domain of f. So 5.1, they want the domain, right? So we're going to say domain. Remember, with domain, what do we need? We need the vertical asymptote. So we're going to take this and find the vertical asymptote. So it's going to be x minus 1 is equals to what? It's equals to 0. Therefore, x is going to be equals to 1. So my domain is going to be x is an element of real numbers, but it's not equals to the asymptote. So you're going to say x is not equals to 1. And that's going to be your domain for the first question. So now moving to 5.2, it says write down the asymptote of f. We have two asymptotes. We have the vertical and the horizontal. So the vertical asymptote, we already solved it when we were doing the domain. So it's what? It's going to be x is equals to 1. And our horizontal asymptote, right, let me just write it properly here. And our horizontal asymptote is going to be what? Here there isn't any q, so that means the fact that it's 0. So it's going to be y is equals to 0. And that's both our horizontal asymptote, not as a VA, not a VS, right? So this is our vertical asymptote and our horizontal asymptote. So now moving to 5.3, it says sketch the graph f, clearly indicate all the intercepts and the x with x's and any asymptote, right? So the first thing that we need to do is that we need to find our intercept, right? We need to find our x and y intercepts. So let's start. So our x intercept, right, this is 5.3, so it's going to be x intercept. So intercept, not intercepts. So it's going to be let y equals to 0. In our case, y is f of x, so it's going to be 0 is equals to what? To negative 1 divided by what? By x minus 1. Right? Since this side is 0 and this one is division, we don't have to, we can't take any number to the other side. And if we divide this by 1 and we cross multiply, what do we see? It's going to be 0. Then it's going to be open bracket x minus 1 is equals to negative 1. The x are going to cancel. That means the fact that there is no x-intercept. So this is undefined. Undefined. so it does not exist. So meaning we don't have any what? Any x-intercept, right? So now for my y-intercept, so it's going to be y-intercept. Remember that we need to let x equals to 0, right? So our function was f of x, right, is equals to what? To -1 divided by x minus 1. So we're going to substitute 0 by what? By x, and we're going to change the f of x into being y. So it's going to be y is equals to -1 divided by 0 minus 1. Punch this into the calculator. You're going to get y as being equals to +1. Therefore, the coordinate of the y-intercept is going to be 0 is to 1, right? So this is my y-intercept. Now, since we have both our x and y-intercept, what we're going to do is going to sketch. But before we sketch, we need to determine the sign so we can find the shape. So we know the fact that a is equals to -1 from here, and 1 is less than 0, meaning the graph is going to be in the second and fourth quadrant. Knowing that, let's sketch it. So I'm just going to draw the Cartesian plane like this. So it's going to be like this. Then this is my y and this is my x, right? So let's start with my asymptote. I'm going to do it in orange so that you can see it. The first one is what? X is equals to 1. So 1 is here, right? So we know the fact that this is 1. So I'm going to draw a dotted line going down. So it's going to be like this. Then now we know the fact that y is equals to 0. So y is equals to 0. The line that's equals to 0 is this one, meaning this is going to be your what? Your horizontal asymptote. The x-axis line is going to be your horizontal asymptote because y is equals to 0, right? So now let's substitute what? My x and y-intercept. We know the fact that we don't have an x-intercept because it's undefined, but my y-intercept is 0 is to 1. So 0 is to 1 is here, right? So this is 1. Then this point here is going to be what? It's going to be my y-intercept. So we know the fact that from the sketch, our graph needs to be in the second and fourth quadrant, meaning it needs to be here and here. So let's sketch that. So it's going to be like this. It cuts through the y-intercept like the way you see it, right? Then it's also here like this. And that's going to be what? Your graph for 5.3. So now moving to 5.4, they say for which values of x will x, right, multiply by f prime of x is going to be greater than and equals to what? To 0. I could do this question in when we're doing calculus, but either way they don't teach you on how to solve this one to find the f prime of a hyperbola. When you're given this type of equation, they don't necessarily teach you on how to do it, even if I know how to show you guys, but I feel like it's just going to be too much information for you guys. So what I'm going to do is I'm going to show you how the graph looks, right, when you have a hyperbola and you're finding the f prime of it, right? So this is calculus work, but I can show you how the function looks, right? So the derivative, this is derivative, f prime is derivative. Don't worry, we're going to get more into it when we do what? When we do calculus. So when we find the derivative of what we given, which is 1 over x minus 2, you're going to get your function as being 1 over x minus 1 all squared, right? And this is how the graph looks, because I just want to show you how the graph looks. So the graph is y is equals, remember, to 1 divided by open bracket x minus 1 all squared, right? This is all squared and it's squared, right? Remember the fact that I took it from here where I'm pressing here. The answer for this one, that's where I took it, right? So do you see how the graph is? The graph is going to look like this. The thing that you need to understand is that you just need to remember visually how the graph looks. The graph, how it looks when you differentiate this is what matters, is how it looks, and it's going to look like this. So now they said x when it's multiplied by f prime, right? So remember the fact that x is the same as saying y is equals to x. This is the function. So we have two functions, is y is equals to x and f prime like the f derivative, right, of the original. Multiplying together is equals to greater than, and it's greater than and less than, and equals to 0. Remember, when we do this, is this thing that we talked about before that. Before I do that, let me sketch the graph. So before I continue, is that I want to show you on how to sketch it, right? Is that when you're finding the f prime of the original of this one, is that the vertical asymptote remains the same from the original graph, 1, and 2 is that your y-intercept also remains the same. So you knew the fact that my x-intercept here was what? Was 1, right? So 1 is going to be here. It's still going to be your vertical asymptote, and this one, which is what? Which is your y-intercept, which is 1 is to 0, is still going to remain the same, but it's just that this one goes up and basically is a reflection of this. Just remember that, right? Is that your vertical and horizontal asymptote remains the same, only the other one shifts to the positive side, right? You'll see it more. There's another question that's similar to this that we're going to sketch it again, right? And I'm going to show you again on how to sketch it. Then they say this is multiplied, this f prime is multiplied by x, which is the same as y is equals to x, which is, I'm going to sketch in orange, which is the same as this graph, right? This is what? The orange one is y is equals to x, and the black one is what? Is f prime, right? Just remember that. So the question says when x multiplied by what? By f prime is greater than and equals to 0. What do they mean? They mean the fact that when we have this two multiplied together, right, it needs to give us what? A positive. So when you multiply those two together, it needs to get a positive. So meaning this side, x needs to be positive, and also y needs to be what? To be positive, right, to get a positive. Because when you multiply this 2 together, you're going to get a positive, or one needs to be negative and the other one needs to be negative. So when you multiply them together, it's going to be what? It's going to be positive. That's what I mean, not 0. It's going to be positive and positive, right? So here, just take it as the same as that question when, if I had to replace y is equals to x, take it as being saying g of x multiplied by f of x, this time is f prime, is greater than and equals to 0, right? And where we take g of x as being that g of x is equals to x. I hope that made sense. This is what I mean, right? So with that, taking this as being g of x, right? With that, knowing the fact that it's either both graphs needs to be on the positive y-axis or both graphs needs to be on the negative x-axis, right? So here, remember when we're doing this type of questions, if you've watched the quadratic section, is that what do we need? After establishing what does this question mean, what do we need? We need to find the x-intercept. What do we see? We see the fact that we only have one x-intercept, which is by what? By y is equals to x. So we have one x-intercept, and I'm just going to draw a line by a highlighter line going down because of that's the only x-intercept, right? Then I'm going to write my negative infinity and my positive infinity because it's going to help me with this, like to write down the answer. So what do we need to look for? We need to look for when both graphs, both the black graph and the orange graph, when they are both in the negative side, meaning, and when I say negative side, we're looking at the y. We're looking at the y-axis, right? Y is positive from here going up, and it's negative from here going down, right? So we're looking for when both graphs are here at the top or when both graphs are here at the bottom. So from 0 to my x-intercept, which is 0 here, right? What do we see? We see the fact that the black graph is on the positive y-axis and the orange graph is on where? It's on the negative y-axis. So this one does not satisfy my condition, right? But what do you see? From 0, right, till positive infinity, we see the fact that both graphs, right, are what? Both graphs are on the positive, what? Positive y-axis. So writing my answers in terms of what? In terms of writing my answers in terms of x is that from 0, this point is 0, 0, right? So from 0 till 1, right? So from 0 till 1, then from 1 till positive infinity. The reason why it's from 0 till 1 and 1 till infinity is because of, remember that f prime does not exist at 0. So your answer is from 0, right? Because it's equals to, so you're going to be a square bracket. So you're going to say x is an element, then square bracket from 0 till 1, which is the asymptote, so 1, then with the curly bracket, because the graph f prime, even though the orange graph exists there, since f prime does not exist, we need to exclude it, right? Then or from curly bracket from 1, right, till positive infinity. And positive infinity is also a curly bracket. So this would be your answer. Or you can write it like that x, right, is what? Is greater than and equals to what? Greater than and equals to 0, right? Meaning it's from 0 till positive infinity, but x is not equals to what? To my asymptote, which is 1. So this, both answers are exactly the same thing. So this is how you would answer this question. So now we're moving to 2016, right? So there isn't any question about hyperbola in 2017, man. I mean, because we did 2018. So there isn't any question, or if there is, it's mixed with exponential, I think. If there is a question there, it's mixed with exponential, and we haven't done exponential, meaning I'm going to do it when we're doing exponential. So let's start. It said, sketched below is a parabola f. So we know the fact that these are quadratic, which is f, with an equation of f of x is equals to negative x squared plus 4x minus 3, and a hyperbola graph G, which is, you see it, and with an equation of x minus p close bracket y plus t is equals to 3, right? Then they tell us that b, which is here, I'm going to highlight it in orange. B is the turning point of f, and it lies in the intersection of the asymptote. So the coordinate here at B gives us the vertical and horizontal asymptote of what? Of graph G. Then they tell us that point A, which is here, right, is what? Is the x-intercept for the G, which is the hyperbola, right? So the first question, which is 5.1, it says, show that the coordinate of B is 2 to 1, right? So we see the fact that B is the turning point, plus also it's what? It's also the intersection between the vertical and horizontal asymptote. So we can find the turning point by using the function of f of x. So we know the fact that f of x, right, is equals to what? To negative x squared plus 4x minus 3, right? So I'm going to use the equation that has negative b divided by 2a to find the coordinate of the turning point. So B is the, what is the turning point? So B is the turning point. So therefore, we're going to say x is equals to what? To negative b divided by 2a, where my a is equals to negative 1 and my b is equals to 4. Substitute that. We're going to have x is equals to negative what? Negative 4, right? Negative, open bracket 4. Then it's going to be 2, open bracket, negative 1. Then when we punch that into the calculator, we're going to get our x value here as being 2. Then to find my y coordinate, it's going to be f of 2, right? So we're going to substitute it back here at f of x. So it's going to be negative, open bracket, 2 squared, right? Plus 4, then it's going to be 2 minus 3. Punch that into the calculator, you're going to get your f at 2 being 1, which is the y coordinate. Therefore, making the b coordinate as being what? As being 2 and 1. So this is the coordinate of what? Of b, which is matches with this one, right? So now moving to 5.2, it says write down the range of f. Remember the fact that f is what? Is the parabola, which is the quadratic. So to do the range, what do you need? you need your A and you need your Q. So we see the fact that A here is equals to what? Is equals to -1. So it's going to be equals to -1. -1 is less than 0, right? And our Q value is from where? Is from B, which is the turning point, which is the Y coordinate. Therefore, Q is equals to 1, right? So this is Q. So therefore, my range is going to be what? Y is less than and equals to what? To Q, which is 1. So this will be your range for your F. So now moving to 5.3, they say write the values of X that will be G of X is greater than and equals to 0. So we need to just highlight G of X. G of X is the hyperbola, so it's going to be this one, like this. So the one I just highlighted in orange, right? And what do they say when G of X is what? Is positive. What they mean is that where G of X lies only on the positive what? Positive Y axis. That's what it means when they say G of X is less than and equals to 0. So now looking at just G of X, very important, looking at just G of X, we need to find what? We need to find the x-intercept for it. So we see the fact that we have only one x-intercept. So I'm going to draw a line going down, right? And this pink line is the x-intercept of G of X. So I need to write my answer in terms of what? In terms of X. So we see the fact that this side is negative infinity and this side is positive infinity. So from going from negative infinity till positive infinity, where does G of X, the orange one, lies? It lies above the x-axis, meaning it's on the positive what? Positive y-axis, right? So from negative infinity, so we know from negative infinity till what? Till 1. Since is what? Greater than and equals to, it's a square bracket, right? And it's also the intercept. The graph exists there. It's positive, right? G of X is positive. Then what do we see? We see from 0, right? Going and going, right? Going till what? The asymptote, right? Till the asymptote, what happens is that the graph is on the negative. Do you see it? It's on the negative y-axis. So from there, it's on the negative. So G of X is not greater than and equals to 0 because we wanted only one is in the positive y-axis. But from the asymptote, right? From the asymptote till what? Till positive infinity, what happens? The graph is on the positive side. So we're going to say what? Union. Then we're going to have a curly bracket because of the asymptote. This way the graph doesn't touch, which is here. Our asymptote, remember, is what? It's 2 and 1, meaning from 2, right? Not including it because of the asymptote for G, till what? Till positive infinity, right? So this will be your answer from negative infinity till 1, union from 2 till positive infinity. So, and when you write your answer for 5.3, don't forget to say X is an element because you're showing the fact that you wrote your answer in terms of X, right? So now let's move on to 5.4. It says determine the equation of the vertical asymptote of the function h if h of X. So let's write it. So this is 5.4. Right? They give us the fact that h of X, right, is equals to what? Is equals to G. Then it's going to be G plus 4. So we see the fact that h of X is equals to G when we add 4. So now let's go and write my G of X. Remember that now we can actually write our G of X in terms of the asymptote because of we know that B is an intersection of what? The vertical and horizontal asymptote. So let me show you. See this line that I'm going to highlight in orange, this one going down, right? Do you see that? That's your vertical asymptote, meaning it's going to be X is equals to what? X is equals to 2. Do you see the one that I'm going to sketch in what? I'm going to sketch in pink. Let me erase this one from the previous question. The one that I'm going to sketch in pink, right? That's your horizontal asymptote, and here's going to be y is equals to what? The y coordinate here, which is 1, right? So knowing that too, I can rewrite the hyperbola, which is G of X, right? In terms of what? In terms of my asymptote. So I know the fact that I don't know A, so I'm just going to say A is equals to and my p, right? My p, remember, is from here, so I'm gonna reverse it. So it's gonna be x is equals to 2. Take it to the other side, it's gonna be x minus 2 is equals to 0. So here in the denominator is gonna come what? X minus 2. So it's gonna be x minus 2, right? Then it's gonna be what? Plus my q, which is my horizontal asymptote, which is y is equals to 1, which is gonna be plus 1. So this is my g of x, right? So knowing from this, I can find my g of x, x plus 4. So I'm going to say g of x plus 4 is going to be equals to what? It's going to be equals to 8 divided by what? By x plus 4, then minus 2, right? So this whole thing is going to replace my x. X plus 4 is going to replace this initial x here, because of that's what we have, right? Then it's going to be plus 1. Remember in the question they said determine the vertical asymptote of h, right? So the vertical asymptote is going to be what? It's basically taking this one, right, and equated it by 0. So you're going to say x plus 4 minus 2 is equals to 0. Then it's the same as saying x, right, plus 2 is equals to 0. Take the 2 to the other side, so it's going to be x is equals to negative 2. So therefore, my horizontal asymptote for h of x is equals to x is equals to negative 2. So that's how you will find the vertical asymptote. So now 5.5, it says determine the values of p and t. So p and t is from here, that's g of x, right? So g of x is written in terms of p and t. So let's take that one. So it's going to be x, right, minus p, right? Then it's going to be y plus t is equals to 3. So I need to rewrite this in terms of my y being the subject of the formula. So first I'm going to divide both sides by what? By x minus p on both sides, right? So it's going to be x minus p. So the x minus p here are going to cancel out. So you're going to be left with y plus t. And this is 5.5. Let me write it down, right? So you're going to be left with y plus t is equals to 3 divided by what? By x minus p, right? Let me just move it here, right? And we need y alone, so I'm going to take t to the other side. So it's going to be y is equals to 3 divided by x minus p, right? Then it's going to be what? It's going to be minus t, right? So now what do we know? We remember the fact that I just talked about the I just talked about the vertical and horizontal asymptote. Being the vertical asymptote is x is equals to 2, and the horizontal asymptote is going to be y is equals to what? So y is equals to 1. So let me write it down here. So we know the fact that my vertical asymptote is going to be x. Let me just write it in another color. So I'm going to write it in pink. So we know the fact that x equals to what? Equals to 2, and y equals to what? Equals to 1. Am my x and y what? Am I asymptote, right? This is my vertical asymptote and this is my horizontal asymptote. That's what we know. So first here for my vertical asymptote, before I equate it to p, right, I need to write it in this form. So it's going to be what? It's us reversing it, so it's going to be x minus 2 is equals to 0. So now I can equate this 2 by p, so it's the same as saying negative 2 is equals to negative p, which is therefore p is equals to positive 2. Then for my t is the what? T is the horizontal asymptote, which is my horizontal asymptote is y is equals to 1. So it's the same as equating this 1 by t. So it's the same as saying negative t is equals to what? Is equals to 1. Therefore, t is equals to what? Is equals to negative 1. So my answer here is going to be what? It's going to be p is equals to 2 and what? And t is equals to negative 1. So now we're going to go to 5.6, but before going to 5.6, it says write down the value of x for which f of x multiplied by g prime, right, the derivative of the hyperbola, right? So I want to show you guys like a simpler way on how to find g prime of the hyperbola, like notes. I know the fact that I did equation, but like I just decided the fact that let me just jot down the notes so that when you guys get in the test, it's easy for you guys to sketch it and becomes easy to answer this type of question, right? So let me just move my space to something clean and we do notes for finding g prime of a hyperbola. So here when we sketch it, let's write the general form of a hyperbola, like meaning g of x without the prime thing on top. So it's going to be g of x is equals to what? It's actually equals to a divided by x plus p, right? Then plus q, right? So here what's important with sketching, g prime, which is I'm going to do it in pink, is that you need two things from here. You need to know what's your a, so you need to know the sign of a, because a is going to affect how the shape is, and you also need your vertical asymptote, meaning you need your p. So you need your x plus p is equals to 0. Solve it, so it's going to be x is equals to negative p. So you need your vertical, meaning this is your vertical asymptote. So you need your a is going to determine the shape of your new graph, right? And you need your p, which is going to be your vertical asymptote. So now let's discuss when what happens when a is positive and what happens when a is negative, right? So now moving here, I'm talking about the pink one and a g prime. So let's say from your question, now you're taking from your question, let's say, and the a and q that I'm talking about is from the question, right? Is that when a is positive from the question, so when a is greater than 0, meaning it's positive, right? What happens is that this is how your shape is going to be, but also you need your p. So let's say p is positive, right? It really doesn't matter where p is positive or negative, you just need your p. So when a is positive, this is how the shape is going to look. So first thing first, you need to put your what? You need to put your vertical asymptote. So let's say p is here. I'm going to do an example where I do it at numbers, and when a is negative, right? When a is positive, your graph is going to look downwards. It's going to go like this. So this will be your graph. It's going to be on the negative y-axis, right? It's going to be on the negative y-axis. So now when a is positive, it's negative, sorry. When a is negative, right? And your p, you just need your p, your graph is going to look like this. So your graph, how it's going to look is that you need your vertical asymptote. So it's going to be here. This is your p, and your graph is going to be way on your positive y-axis. So this is how your graph is going to look. So now let's do an example of when a is positive and when a is negative. So taking into account the first question that we did from the previous example. So now taking an example from the question that we did in 2018, where they wanted us to basically solve this. Remember, they said x multiplied by x prime, right, is greater than and equals to 0. Remember, this is what we needed to solve. But we needed to know how this one looks when we sketch it when it's f prime, right? Remember the fact that I said to sketch this one, we need to know our a and we need to know our vertical asymptote. So now let's find our a in pink. I'll do it in pink. So we know the fact that a here is equals to negative 1, right? And negative 1 is less than what? Less than 0, right? So meaning from our shape, if it's less than 0, our shape is going to be like how? It's going to be less than 0. Our shape is going to be this one, right? A is going to be negative, meaning it's going to be on the y-axis, right? So let me just put reference where you see from the notes and we see when we answer. Now we need our vertical asymptote. So we know that our vertical asymptote comes from here, right? So it's going to be x minus 1 is equals to 0. Therefore, x is going to be equals to positive 1. So now let's do a rough sketch. It's going to be like this, right? then our vertical asymptote is 1, so it's just going to be here, and this is 1, right? And we know the fact that it's going to exist up, but it shouldn't touch my what? It shouldn't touch my x-axis. It shouldn't touch this, right? So the graph is going to go like this, and it's going to cut through here. Then it's going to be like this. This is just a rough sketch. And this is how it would look when my A is negative. So now going back to the question, our g of x, right? Remember the fact that after solving, let me just erase this number because we're on 5.6, right? We see the fact that our g of x, we found it as being what? As being equals to 3 divided by what? 3 divided by. So this is how you would do your g of x, right? So this is how this g of x is a reflection of this one, right? The one that's sketched in orange, right? So now we need to find what? We need to sketch, I'm going to do it in pink. We need to sketch g prime, right? Because what does the question say? The question says when f of x, right, multiplied by g prime of x is greater than and equals to 0. So we need this one to answer this question. So when I sketch it, remember I said A from the original matters, and we need our vertical asymptote. So remember, our A is what? Our A is equals to positive 3. Therefore, our graph is going to lie where? It's going to lie on the negative y-axis, right? So it gives us the shape. So this is greater than 0, so it's going to give us this shape, right? And we need what? We need our P, which is our vertical asymptote, which is we're going to take from there. So it's going to say x minus 2 is equals to 0. Therefore, x is equals to 2. So x is equals to 2 is going to be what? Our vertical asymptote. Let me move it to the side so we can sketch the graph, right? So me sketching the graph, this is how it's going to look. So when we sketch it, what's going to happen is that our x is equals to 2. That's what matters. So I'm going to do it in orange. So this is going to be our vertical asymptote, which is this point 2, right? Then our graph only lies on the negative side. So our graph is going to look like this. It's going to just be like this. And like this. So what I just sketched here is what is g prime, right? That's what you need. And remember the fact that they say when f of x multiplied by g of x, it needs to be positive. So now we need to sketch what? We need to sketch f of x. So from f of x, we know the fact that the turning point is what? It's b is to 2 is to 1, right? So we know the fact that the turning point here, we're just going to do a rough sketch, which is I'm going to do it in pink. This 2, which is here, is to 1, right? So it's going to be like this. Right? So now, remember when we did quadratic, is that this type of question, what does it entail, right? Is that it basically says when we multiply two graphs here, we need to get a positive because it's greater than and it's greater than and equals to 0. So when this graph is positive and this graph is positive, when you multiply them together, we're going to get what? We're going to get a positive, right? And when this one is negative, multiplied by a negative, it's going to be what? It's going to be positive, right? So we need when both graphs are on the positive y-axis or when both graphs are on the negative y-axis. That's what it entails. But we need to write our answers in terms of what? In terms of x. That's why when we come to the graph, we need to highlight what? All the x-intercept. So what do we see? Our x-intercept, I think I want to change the color here so that you can see it. Our x-intercepts here is only what? It's only on the what? On the quadratic function. It's only here. So we see the fact that this is going to be our x-intercept and this is going to be our x-intercept going down, right? So now we need to calculate the x-intercept. So our function for f of x, let me just go down. I just want to rewrite it, then create space. So we know the fact that f of x, this color doesn't show properly. So let me pick another color. So let me pick a dark blue. So we know that f of x is equals to what? To negative x squared plus 4x, right? Minus 3. we finding what the x-intercept, we need to let it by 0. So here it's going to be 0, y by 0. So f of x is going to be equals to 0. So this is going to be negative x squared plus 4x minus 3. Then when you factorize this, you're going to get your f of x as being what? As being x minus 1 and x minus 3, which is x is equals to what? 2, positive 1, or x is equals to positive 3, meaning our coordinate is going to be 1 and 0, and the other one is going to be 3 and 0. That's what we know, right? So there's 2 points where I put the line. Here's going to be 1 and here's going to be 3. Then another thing is that you need to put your negative infinity and your positive infinity. So the reason why you cut them through is that this is the region where you're going to check where one graph are both negative and or where both graphs are both negative and both graph is going to be positive. I hope I'm making sense, right? It's that now this cut through is where you basically, this is the region where you check whether both graphs are positive or both graphs are negative. So from negative infinity till 1 here, right? What do we see? We see the fact that both graphs are on the negative what? Negative y-axis, which is correct because of when you multiply a negative and a negative, which is the other one is black and the other one is pink, right? When you multiply them together, what you're going to get? You're going to get a positive. So from here till 1, this is where our answer lies. So we know the fact that one of our answers is going to be what? X is an element from where? From curly bracket from negative infinity till 1, right? And that's going to be what? A square bracket, because it says greater than and equals to 1. Or now we need another region. What do we see? We see from, let me do it in pink, from here, from 1 till 3, which is another region, right? Both graphs are what? One graph, which is the pink one, is on the positive y-axis. Do you see it? It lies up on the positive y-axis. If I draw this line, right, this line, this blue line that I just drew, it divides the positive y-axis and the negative y-axis. So from 1 till 3, we see the fact that the pink graph is on the positive y-axis and the black graph is on the negative y-axis. So this region doesn't count. But from 3 till positive infinity, so from 3 till positive infinity, what do we see? We see the fact that both graphs are on what? On the negative y-axis. So our another answer is going to be or you can put this or like this, is going to be where? From square bracket from 3 till positive infinity. So this would be your answer. So your answer here is from x is an element of real numbers from this region. Let me highlight this one. From the region that I highlighted from negative infinity till 1 and from 3 till positive infinity, and that will be your answer, right? And this one in the memo, they wrote it, they can write it like this. They can say when x is what? It's less than and equals to 1. Or they can say what? When x is greater than, right, and equals to 3. This is not greater than, this is less than and equals to 1 because of its states the fact that it's in the negative side, right? So from negative, this translates is from negative infinity till 1, and this one translates is from 3 till positive infinity. I hope that made sense. So this is the answer for what? For 5.6. This would be your answer. So now moving to 2014, it says the diagram below shows an hyperbola G by G of x is equals to 2 divided by x plus p plus q with asymptote y is equals to 1 and x is equals to -1. So they're given us the vertical and horizontal asymptote, right? Then let me just write down which is the vertical. So y is equals to 1 is the horizontal asymptote and x is equals to -1 is the vertical asymptote, right? They say the graph G intersects the x-axis at t, so this t is the x-intercept and the y-axis at 0 and 3. So we know the fact that 0 and 3 is the y-intercept of G, right? Then they say the line y is equals to x intersects the hyperbola at the first quadrant at x. So we know the fact that this is an intersection between g of x and y is equals to x. So let's move on to the first question. Let me just move it here like this. It says write down the value of p and q. So 4.1, we need the value of p and q. First of all, for the vertical asymptote, we need to reverse it to find our p. So we know the fact that x is equals to 1, negative 1, right? Take it to the other side. Therefore, x is equals to what? Is equals to, it's going to be x plus 1 is equals to 0. Therefore, making our p equals to this value. So p is equals to positive 1. Then for our q, it's just y. We know the fact that it's y is equals to what? To 1. And that 1 is our q. So therefore, q is equals to 1. Then we done finding the finding our p and q. Then 4.2 says calculate the x coordinate of t. What is t? From our diagram, I'm gonna do it in pink. T is our x-intercept. So we know for 4.2 we're looking for the x-intercept, right? And we're looking for just the x coordinate of it, right? So with x-intercept we need to let what? Let y, right? We need to let y equals to 0. So we know the fact that g of x, right, is equals to what? To 2 divided by x plus p plus q. Substitute your p and q. We already did it. We already calculated the values in 4.1. So g of x here is equals to what? To 2 divided by x plus 1, right? Plus 1. So this is your function. So we're looking for the x-intercept, which is the coordinate of t, just the x coordinate, right? So we're gonna let y equals to 0. So g of x is 0. So it's gonna be 0 is equals to 2 divided by x plus 1, then plus 1. Take the 1 to the other side. It's gonna be minus 1 is equals to 2 divided by x plus 1. This is the same as divided by 1. We're gonna cross multiply. When we cross multiply, it's going to be negative 1, open bracket, what? X plus 1 is equals to 2, right? Then distribute the negative 1, so it's going to be negative x. Then it's going to be minus 1 is equals to 2. Take the 2 to the other side, so it's going to be negative x is equals to 2 plus 1 is going to give you 3. Therefore, my x coordinate, so my xt, is going to be equals to negative 3. So my x coordinate of t is going to be equals to what? To negative 3. Then we're done answering that question. So now moving to 4.3, it says write down the equation of the vertical asymptote of the graph of h if h of x is equals to, so we know that h of x, right, is equals to what? To g of x plus 5. That's what we know. And what do we know? We know that g of x is equals to what? Is equals to 2 divided by y divided by x plus 1. Then it's going to be plus what? Plus 1 again. So now just moving it here, we need to find g of x plus 5 so that we can find h of x, the vertical asymptote. It's the same as saying g of x, right, plus 5. So now we're going to substitute here by x plus 5, so it's going to be equals to 2 divided by x plus 5 plus 1, right, because we need to take the 1 down again, and it's going to be plus 1. What is the vertical asymptote? Is this portion equated to 0. So you're going to say x plus 5 plus 1 is equals to 0. Then it's going to be the same as x plus 6 is equals to 0. Take the 6 to the other side. So it's going to be x is equals to what? Is equals to negative 6. And that would be your what? X equals to negative 6 is going to be your vertical asymptote for h of x. So now moving to 4.4, it says calculate the length of OS. I'm just going to highlight OS. This is OS, right? So what do we need to calculate the length? We already have the coordinate of O, which is 0, is to 0. Then now we need the coordinate of what? Of S. What is S? S is the intersection between g of x and the graph y is equals to x. So g of x and S is the intersection between y. G of x is equals to y. So what's g of x? Let's substitute that. It's 2 divided by what? By x plus 1, right? Plus 1 is equals to what? Is equals to x. This is your y is equals to x. That's why I substituted by y. Then now take the 1 to the other side. You're going to have 2 divided by x plus 1 is equals to x minus 1, right? This is the same as saying divided by 1. So I'm going to cross multiply. When I cross multiply, I'm going to have x plus 1. Then it's going to be x minus 1 is equals to 2 multiplied by 1 is going to be 2, right? So this is a difference of 2 squared. So you're going to have x squared, right? Minus 1 is equals to 2. Take the 1 to the other side. You're going to have x squared is equals to what? Is equals to 3. Square root both sides is going to be x is equals to plus or minus square root of 3. Then where does S lie? It lies on the positive side. So therefore, the x coordinate, so therefore, our x coordinate of S is equals to a positive root 3, right? So now we have the x coordinate, we need the y. So I'm going to take this equation to find my y. So we know the fact that y is equals to x, right? And what's our x? Our x is 3 over, is root 3, sorry. So my y is going to be equals to, substitute root 3, so it's going to be just root 3, because I just substituted this one here. All right, so now my s coordinate, let me just put it here. So now my s coordinate is going to be what? Is going to be root 3 is to root 3. And we know our o coordinate, which is 0, is to 0. So now what we need to do is we need to find the distance. So we're going to say OS is equals to this formula. Square root of what? Of x of O minus x is O squared plus what? YO minus Y is all squared, right? Then substitute, so it's going to be OS is equals to square root, right? It's going to be O minus root 3 all squared plus O minus root 3 all squared, right? So that's going to be OS. Simplify the one that's in the square root. So it's going to be what? It's going to be, here when you punch this into the calculator, you're going to get 3 plus 3. Therefore, OS is equals to root 6. So your answer, the length of OS is going to be equals to root 6. So now what we're going to do is we're going to do exponential graphs. So with exponential graph, as you know the drill, how it starts is we're going to have what? The mother graph. Which is what? Which is y is equals to 2 to the power x, right? Then we're going to have the general form, which is the one that we're going to look at, right? Which is going to be y is equals to what? Is equals to a multiplied by b to the power x. Then here plus p, then plus q, right? So as you know the fact that we're going to look at the effect of a, b, p, and q. So here we're going to look at the effects of 4 things, right? So we're going to first start with the effects of b. So we're going to say the effect of b and we're going to go to the graphing calculator to see how b affects the graph, right? So with b, what you need to know is, when I write the note, you're going to see it more, is that b can be 0 and b needs to be greater than 1, right? Or b can be a fraction, meaning b is between 1 and 0. So the first case, right? So we're going to take the mother graph, which is going to be y is equals to 2 to the power x. So you see the fact that why the general or the mother graph, right, is y is equals to 2 to the power x is because of b cannot be what? Cannot be 1. That's what I wanted to say, not 0. B can never be 1 or 0. And another thing is that b needs to be greater than 1. So it can never be 1, but it can be any number that's greater than 1, right? So now for the first one is that when b is greater than 1, where we can pick b as being what? 2, right? Then we're gonna have y is equals to 2 x to the power x, and that's how the graph is, right? So now let's say our b is what? It's a fraction. Let's say b now is 1 over 2, which is between 0 and 1, and let's see what happens to the graph. So y is equals to 1 over 2, right? Then it's going to be to the power what? Like, put this into a bracket so that it doesn't confuse you guys. So that you can see this whole thing is to the power what? Is to the power x. And you see the blue graph, what's going to happen is that the red one, right? When b is greater than 1, meaning it's 2, 3, 4, 5. Our red graph, the graph is increasing. The tail is on the negative x-axis. Then it goes up from the positive x-axis, right? Then when y is what? When y is equals to 1 over 2 to the power x, right? What's going to happen? The graph is decreasing, meaning it goes up on the what? On the negative x-axis, and the tail is on the positive x-axis. So now with that said, let's go do notes. So now let's write the notes. We know the fact that, let me just put it down. Let's go a little bit down. We know the fact that the effects of b, it gives us what? It gives us the shape. So we know that b gives, right? It gives the shape. So now we're going to start with the first point, which is if, right, b is greater than 1. When I say greater than 1, I mean the fact that 1 is not included. b, I repeat it, b cannot be 1. b cannot be 1. So since b is greater than 1, meaning any number after 1, which is 2, 3, 4, 5, any number that's greater than 1 but not 1 can be b, right? So when b is greater than 1, then our graph looks like this, right? So it's going to be like this. Right? It's increasing, meaning the tail is on the negative x-axis, then it goes up to the positive x-axis. So this we call as being increasing. Then our next point is that if b is between 1 and 0, in simple terms is that b is a fraction, meaning 1 over 2, any number that's a fraction, but it needs to be between 0 and 1, right? So 1 over 2, 1 over 4, 1 over 3, any number that has 0, comma, dot, 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 right, is between 0 and 1, and that's going to be when b is like this, right? So when b is a fraction, what's going to happen is that the graph is like this. It's decreasing, meaning the tail is on the positive side and it goes up in the negative side, right? And this we call as being decreasing, right? Then the last point is that when b, if b is less than, and what you call this is less than and equals to 0, then f of x does not exist. So f of x is not defined, so it does not exist there. So f of x is not defined. Let me explain this point more further. So what they mean is that when b is 0, that's why it's greater than and equals to, when b is 0 and any negative number after 0, negative 1, negative 2, negative 3, it does not exist, then b does not exist. So when b is negative, the graph does not exist. I hope I'm making sense. So this is the effect of b. So now let's move to the effects of a, right? So we're gonna move to the graphing calculator. Then we're gonna see how A affects the graph. And very important with this one with demonstration is that I'm going to take my B as being greater than 1, meaning my B is going to be 2. Then we're going to look on how A affects the graph when B is greater than 1, which is B is equals to 2. But when I do notes, I'm going to show when B is greater than 1 and also when B is between 0 and 1. So that's what I wanted to clarify when we move to the graphing calculator. So the first one is that we're going to have our mother graph, which is y is equals to 2 to the power x, and here's that when b is greater than 1, right? So the first thing is that let's say now our a is negative, right? So let's take negative 1. So I'm just going to type out the negative 1, but in the normal equation the 1 is not going to be there, right? So if you say negative 1, right, then you're going to multiply it by what? You're going to multiply it by 2, which is b to the power x, right? See what happens to our graph when a is negative. Our graph is going to go what? It's going to flip on the y-axis. So it's going to be the same graph, but it's going to flip on the y-axis, on the x-axis, not the y-axis. So it's going to flip on the x-axis, and this is how the graph is going to look, the blue one, right? Then if we take our a as being positive what? Positive 1. So if I say y is equals to what? To 1, right? Then multiply it by what? By 2 to the power x. Do you see the graph? The red and green graph is the same thing, right? So our graph is gonna flip on x-axis, but it's gonna be on the positive y-axis. That's what I meant, right? So now let's go do the notes. And another extra thing is that exponential has an asymptote. So in other notes, when we're gonna do our g, right, our graph actually flips upon the asymptote, right? So it's gonna flip on your what you call this anyway, asymptote to be on the other side, on the positive or y-axis, on the positive y-axis, and vice versa. When it flips, it's going to be on the positive y-axis. I hope I haven't confused anyone, but I'm going to talk more about it when we get to doing Q, alright? I'm going to explain it more. I'm going to explain this concept more. We know the fact that A gives what? It gives the shape. Right? So the first point is that if we are looking at two cases, right? So if we know the fact that B here is going to be greater than 1, right? So under that, let me just put arrows under that. If, here's not even if, it's B is greater than 1, then if A is greater than 0, meaning A is positive, then this is how your graph would look. So it's going to be an increasing graph, but on the positive y-axis, right? Then we know the fact that if A is less than 0, meaning it's negative, it's going to be this thing, but it's going to be flipped to the other side. So it's going to be like this. So now let's look at a case where B is between what? It's between 1 and 0. Right? So if A is greater than 0, meaning it's positive, right? So our graph, you know the fact that when B is between 0 and 1, our graph looks like this. So the graph is going to look exactly like this, right? When A is positive, then when A is negative, if A is less than 0, meaning it's negative, then our graph is just going to flip and it's going to be like this. So that's the thing that you need to know about A. So now we're gonna go to the effects of P, right? So P is here. As always, is that P from straight line, we don't have it. From quadratic, hyperbola, and everything, P moves the graph right to the left and right. So it's the same concept, but it behaves differently from graph to graph. So just keep that in mind, the fact that P and Q affects the graph the same way in terms of movement, but how their characteristics are from one graph to another, it differs. But how it affects in terms of movement is the same throughout each graph, right? So the effect of P, so we're going to take our mother graph and we're going to make P equals to what? To positive 1. So if we say Y, right, is equals to 2 to the power, then I'm going to put a bracket so I can put my P. So if I say X, right, plus 1, which is right like that, you see the fact that the graph, the purple graph has moved to the what? Has moved to the left. If you see here, the graph has moved to the left. You see, from the red one, it moves to the left. So we see the fact that our graph shifts to the left when P is positive, right? Then let's say our P is what? Our P is negative 1. So if I say 1, Y is equals to 2 to the power, then inside the bracket, it's going to be X minus 1, then close bracket. Do you see the black one, right? The black one from the red one, it moved the graph to the right. So we see the fact that the P affects the graph by movement from left to right, right? So let's go write notes now. So what do we know about P? It moves the graph left or right. That's what we know, right? Then we know the fact that I'm gonna just write the basic. We're gonna take it from this basic concept, right? So when P, right, is greater than 0, meaning P is positive, then let me just write it down what it means when it's positive from the equation. What I mean is that when Y is equals to A multiplied by B, then X plus P. So it's from this, not after solving it, right? Then the graph moves, right, to the left. To the left, not right, to the left. Then when P is less than 0, meaning P is negative, and I mean it like this, A multiplied by P, then it's going to be X minus P, right? The graph moves to the right. So that's the effect of P. So now let's move to the effect of Q. So from the other graph, you see the fact that Q, as we said, it moves the graph up and down. So it's going to still have the same effect here, but it's going to also have extra information because we're dealing with specifically an exponential graph, right? So now let's go to the graphing calculator. So now let's take Q as being what? As being positive 1, right? So we're gonna say Y is equals to 2 to the power X, right? Then we're gonna add a positive 1, so we're gonna say plus 1. What do you see? We're looking at the blue graph moving from what? Moving from the red graph. We see the fact that the graph is going to move up, right? It's going to move up. Then now let's make P our negative 1, our Q negative 1. So we're gonna say Y is equals to 2, right, to the power X. Then you're gonna say what? We're gonna say minus 1. What do you see is the green graph looking from the red one, it moves 1 unit down, right? So with that said, what do we know? We know the fact that Q is gonna move what? It's gonna move the graph up and down. So we know the fact that the effect of Q is that it moves the graph up or down, right? Then there's another part about Q. Let me go back to the graph. We see the fact that I'm going to zoom it in so that you guys can see it. The fact that the graph right here has an asymptote. So it has a what? It has a horizontal asymptote, right? Which is that horizontal asymptote is determined by what? Is determined by Q, right? So Q is also known, star is also known as the horizontal
asymptote. Asymptote, right? Then now let's discuss when Q is positive and when Q is negative. So the first point, right? If Q is greater than 0, right, meaning is positive, it's gonna move the graph, moves the graph what? Up. Then when if Q is what? Is negative, it's gonna move the graph, it moves the graph down. So that's what you need to know about what Q does. It moves the graph up and down, and also Q is the horizontal asymptote. So now moving to asymptote, right? We know the fact that Q is the asymptote, and the exponential graph only has one asymptote, which is the horizontal asymptote, and the asymptote is this, is y is equals to Q. So this will be your asymptote. So now let's move to domain and range, right? So we're gonna first discuss the domain, and we're gonna discuss the range. So let's start with domain because it's the easiest one. So domain, this is the case always, is going to be X is an element of real numbers. Then now we move to range. With range, you need two things. You need your A and you also need your Q, right? So this is going to be the case 1, and here I'm going to write for the second case. So when A is greater than 0, right, meaning our A is positive, what's going to happen is that my range is going to be y is greater than Q. Remember here, our difference with our quadratic, right? Quadratic, the range for... Okay, let me do when A is less than 0. Then we're going to discuss what is the similarities between the quadratic and the exponential. Ne? So when A is less than 0, right? And we also need Q, then here our range is going to be what? Y is less than Q. So here what do we see? We see the fact that domain and range for the quadratic and for the exponential is the same method, right? You use the same thing. The difference here is that with quadratic is less than, when you write your answer, it's going to be less than and equals to, or greater than and equals to, where here is just less than without the equals to, right? So remember the fact that with quadratic you need to put the equals to. With exponential, you don't need to put the equals to. If you mix it up, it's going to be incorrect. Remember the fact that quadratic, the equals to, you need to write it, right? Then with the exponential, you don't. And the reason why with exponential you don't is that Q, remember that what is our asymptote. So the graph does not exist at Q, but it starts from there going up or going down. I hope I made sense. So now let's take an example where we discuss domain and range, right? So I'm going to write my answer in pink. So with the first one, it says g of x is equals to 5 multiplied by 3 to the power x plus 1 minus 1, right? And we need to find the domain and range. So here for the first one, right, our domain is going to be what? It's going to be x is an element of real numbers, right? Then our range. So here looking at our range, remember we need A, then we need Q, right? So what's our A? Our A is this one, right? What do we see? That we see the fact that A is equals to positive 5, so meaning it's greater than 0, right? And what is our Q? Our Q is this one, which is negative 1. So therefore making my range is what? It's going to be Y is greater than what? Greater than negative 1. So this would be my range and domain. So now moving to the second one, let's write the domain. The domain is the same. We're going to say what? We're going to say x is an element of real numbers, right? Then my range, remember we need what? We need A and Q. So we need A and we need Q. So what's our A? Our A is this one, so it's negative 3. Then what's our Q? and our q is positive 1. What do we see about a? A is negative 3, meaning is less than 0. Therefore, my range is going to be what? It's going to be y is less than positive 1. And that's how you would find your range and domain. Then we're going to talk about intercept, which is the x and y intercept. It's the same throughout with the straight line, quadratic, and hyperbola. How you find your intercepts is the same. With x-intercept, you're going to let y equals to 0. Then with the y-intercept, you're going to let x equals to 0. There isn't much that we're going to talk about. Probably we'll do it in one of the questions. So there isn't much that I need to talk about. You just need to remember on how to find it. So now let's talk about sketching a exponential graph, right? So first you're going to need the first thing, you're going to need the sign of A and B, and those two gives you what? It gives you the shape of the graph, right? Then 2, you're going to need what? You're going to need, it's the sign of A, right? So the first one is the sign of A, right? Because it gives you the shape. Yes, because it gives you the shape. Then the second one is going to be what? The value of B. It's not the sign, the value of B, because it also gives you the shape, right? Then you're going to need your intercepts. Then the last thing you're going to need what is your asymptote, your horizontal asymptote. So that's the 4 things that you're going to need. You're going to need your sign of A, your value of B, intercept, and asymptote. So now we're going to move to logmatics. The reason why I want to look at logmatics laws is because of, the fact that in grade 12, you're going to do inverse graph. And a very important thing is that an exponential graph, the inverse graph of it is a log graph, right? So you need to be able to move from a log, you need to be able to move from an exponential graph to a log graph and vice versa, right? You're going to see it more when we do questions. So the first thing that I want to show you as a basic idea on how to move from an exponential to a log, which is this. So you want to move from y is equals to y to a to the power y to the power x, right? So moving from this one, which is now we want the inverse, right? So we know the fact that when we want the inverse, what do we need to do? We need to interchange x and y. So if here we interchange x and y, it's going to be x is equals to what? Is equals to a to the power y, right? And now we need to make what? Everything in terms of y. So now you see the fact that we need to move from an exponential to a log, right? We need to, that way our y is going to be the subject of the formula, right? So let's do that. So moving from this one to log, what you need to do, first thing first, right, is that you see this one is going to be on the other side. It's going to be on the either side of the equal sign. So other side of the equal, right? Because it needs to be the subject of the formula. Then the base remains the same as being the base in the log. So this one is the base. Then this one is the one that comes after the log. Comes after the log. So now let's do it, right? So we see the fact that to change it, I'm going to do it in blue, right? So here we're going to start with what? With y is equals to, because it's on the other side, right? Then we're going to say log base comes here in the bottom. So our base is a. Then our x is going to be the one that comes after the log. So this is how it goes when we want to change an exponential into a log. So this is the first thing that you need to know. So now the first law that I want to talk about is like adding two logs, right? So if you have log a, right, a with the base ax, then plus log, right, a and y here. Since it has the same base, what can we do? When we have this, we can do what? We can multiply those values together. So you can say log a, because it shares the same base, then you can say x multiplied by y. So this is what you can do, and you can go from here, and you can go from this direction equals to this, or you can go to this direction if you have them multiplied together and coming to this direction. So they intersect with each other in terms of how it goes, right? So this is the additional log, right? So now let's move to the second log. So the second one says, if we have log, right, a x, but now it's minus, so it's minus what? Minus log base a, then it's y. What can we do? We can divide this expressions. So let's do that. So you can say log, then the same base a, then you can say y divided by what? X. So we can say x divided by y. So this is the two laws that you need to keep in mind every time we're doing questions, right? So the reason why I'm talking about it is because, as I said, an exponential graph, the inverse of it is a logarithmic graph. So now let's start with past papers.
So now let's do 6.2. It says determine the value of x for which f of x is between -1 and 2, right? So what we given this. So this is what we given, right? And they want us to determine the value of x. So what can we see here? We see the fact that we can solve for x by doing this, by saying f of x, right, is equals to -1, and also f of x is equals to 2, right? So what can we do? We know the fact that f of x is equals to what? Is equals to log 4x is equals to -1, and also here log 4x is equals to 2. So what we're going to do in both of them, we're going to make x the subject of the formula. So when we make x the subject of the formula, remember that this is the base, right? And this is going to be what? It's going to be the subject of the formula, meaning it's going to be in the equal sign, and this is the exponential. Same thing, base, other side of the equal side, and this is the power. So this is going to be the same as saying x is equals to 4 to the power -1.
So we're going to start with the 2021 paper, right? It says the graph f of x is equals to log base 4x is drawn below. So what we given the inverse of what? Of the exponential, right? Then they tell us that the point B is k is 2 is the point on f. Then the first question they say what? Calculate the value of k. So 6.1. we need to calculate the value of k. So where do we see k? We see k, the fact that k is the what? Is the x, what? X coordinate of b, right? So we're going to take the function and we're going to substitute b so we can solve for k, right? So we know the fact that f of x is equals to what? Is equals to log 4 then x, then substitute b. So 2 is our f of x, so it's going to be 2 is equals to log base 4. Then what's going to happen? Our k is what? Our k is x, so we're going to substitute k here, right? Then what we're going to do now, we need to solve for k, meaning we need to change this log into what? Into being an exponential. So remember this is that this one is the base, the 4 is the base, right? This one is going to be on the other side of the equal sign, so other side of equal. Then this is the exponential, so this is the exponential or the power. So now let's solve it. So we know that the base is what? The base is 4, so it's going to be 4 to the power what? To the power 2 is equals to what? Is equals to k. Therefore making our k equals to what? To 16. And you're done solving for k for the first question. So now let's move to 6.3. It says write down the equation of f inverse, write the inverse of f in terms of y. So what do we know? We know the fact that we given f of x as being what? F of x as being equals to log, right? log base 4x, right? So now what do we need? We need to rewrite this as being what? As being the inverse. So as I say, the fact that this, right, to write your inverse, right, is that this one is your base. So this one is going to be your base, right? Then the x is going to be the power. So to rewrite this, because of it doesn't really give you marks for calculation, you're going to say f inverse, right, is equals to this 4 then to the power x, right? But on the side, let me show you on how to solve it, right? So I'm going to do it in blue for solving purposes. So we know the fact that to write inverse, we need to change the f of x in terms of y. So you're going to say y is equals to what? To log 4x, right? And what do we need to do to find the inverse? You need to interchange it. So it's going to be x is equals to what? To log 4y. Then now put everything in terms of what? In terms of in terms of y, meaning y needs to be the subject. Remember the fact that this is the base, right? So this is the base, this is the one on the equal sign, and this is the power, right? So now it's going to be y is equals to what? Is equals to 4 to the power what? To the power x, which is exactly like this one. So this is how you would find your inverse. Then therefore you're going to say f of x of the inverse is equals to 4 to the power x, right? So with exponential, right, just remember the fact that the minute you find your base, it's very easy to swap to the other side. You just need to put it to the power x. Then you found the inverse if you're given the graph as being a logarithmic. So now let's move to 6.4. It says for which values of x will x multiplied by f inverse be less than 0, right? So first, so that you can see it properly and it's easy for us to basically solve this question, I'm gonna sketch x and f inverse in the Cartesian plane, right? So let me just sketch f inverse so that you guys can see it. So it's gonna be like this. So we know the fact that f inverse is the inverse of f of x, right? So meaning this b point is going to change from being what? We know the fact that k is what? We solve k as being what? As being equals to 16, right? So k is going to change from what? So we know the fact that the b coordinate is 16. It's 16 into 2. So for the inverse, this b prime, let me put it like that, is going to be 2 is to 16, right? So it's going to be 2, let's say 2 here, then 16 is here. So it's going to be this point like this, right? And what do we know? We know the fact that the graph is what? The graph is increasing. So we know that the graph is going to look like this, cutting out from that point. It's going to look like this. And this is the point here, right? So we know the fact that this is going to be f inverse. Then x, the graph for x, I'm going to do it in blue, is just going to be the same. X is the same as saying y is equals to x, right? So it's going to be this blue graph. It's just a straight line, right? So what do they want? They want when, let me do it in pink, they want when x multiplied by f prime, not f prime, f inverse is less than 0. So what does this mean? Let me move here. It means the fact that when you multiply this two graph, you need to get what? A negative, right? So meaning this one needs to be either negative and the f inverse needs to be positive, so that when you multiply it together you're going to get a negative, or vice versa. This one needs to be a positive and this one needs to be what? A negative, so that when you multiply together you're going to get a negative, right? So what we're going to look at, we're going to first need to, before we do anything, we need to first find the what? The x-intercept. We see the fact that f inverse does not have x-intercept, only the straight line has the x-intercept, which is here, which is this 0.00, right? Then remember to put your negative infinity and positive infinity, because you're going to need it when you write your answers, right? So now what we're going to look at, we look at when the graph, let me positive, this is positive y and this is negative y. So now this thing means the fact that we need to look at what? At the y-axis, right? So we need to look at when the pink graph, not the pink graph, the blue graph is on the negative y-axis, right? And the black graph is on the positive is on the positive y-axis, or vice versa. When the black graph is on the positive y-axis, when the black graph is on the negative y-axis and the blue graph is on the what? On the positive y-axis. So what do we see? We see from negative infinity till 0, which is the intercept, right? What do we see? We see the fact that the black graph is on what? Is on the positive y-axis and the blue graph is on the negative y-axis, right? So what do we see? We see from here our graph, if we multiply these two graphs together, we're going to get a negative. So from here till 0, our restriction is satisfied. But what do we see? We see from from 0 till positive infinity, both graphs are on what? On the positive y-axis. So this condition is not satisfied. So your answer here for 6.4 is that our x, right, is an element from where? From negative infinity, right, till what? Till 0. Right, but it's a closed bracket. The reason why it's a closed bracket because of is what? It's a round bracket is because of our answer. Our question wasn't greater than and equals to. It wasn't less than and equals to. It was just less than. So that is why our answer is a curly bracket. What you call this? It's a round bracket. So this would be your final answer for this question. So now let's move to 2020. It says the graph f of x is equals to 3 to the power negative x, right? Is sketched below. A is the y-intercept of f, and b is the point of intersection of f of x and the line what? Y is equal, and the line y is equals to x. So let me move it. So this line, let me just write it in blue, this line. So B is the intersection of the blue line and f of x, right? So the first question, which is 5.1, it says write down the coordinate of A. What is A? A is the y-intercept. So we're looking for the y-intercept, right? So when we're looking for the y-intercept, we need to let x equals to what? To 0. So we have f of x, so it's going to be f of x is equals to what? Is equals to 3 to the power negative x. So we need to let x equals to 0. So it's going to be y is equals to, I changed the f of x into y. So it's going to be y is equals to 3 to the power negative 0, which is the same as 0. So it's going to be y is equals to what? When you punch this into the calculator, you're going to get that our y is equals to 1. So therefore making A into being what? Into being 0 and 1. So that's going to be your y-intercept, which is the coordinate of A. Then now moving to 5.2, it says determine the coordinate of B. So what do we know? We know the fact that B, right, it is the intersection between what? Between f of x and also the line y is equals to 9, right? Meaning that the B coordinate, the y coordinate for that is going to be 9. So it's going to be xb and what? And 9. So what can we do? We can substitute this coordinate of B inside here to find our xb. Then we're going to find the B coordinate. So let's do that. So we know the fact that 5.2, that f of x, right, is equals to 3 to the power negative x, right? So what do we know? We're going to substitute the coordinate B. So it's going to be f of x is going to be what? It's going to be 9 is equals to what? To 3 to the power what? 3 to the power xb, right? So what do we see? We see the fact that we can rewrite what? 9 in terms of 3, right? So we know the fact that 9 is what? Is 3 to the power what? 3 to the power 2. And that's going to be equals to 3 to the power negative xb. Right, so we see the fact that it's the same base. So what we can do, we can drop the base. So it's going to be 2 is equals to negative xb, right? So divide both sides by negative 1. So this one is going to be negative 2 is equals to xb. So our xb, our x coordinate for B is going to be negative 2. Therefore making the coordinate of B being what? Being negative 2 and 9. And this is the coordinate for B. So now we're going to move to what? To 5.3. It says write down the domain of F inverse. Remember the fact that with domain and range, when we were starting with the video, right, when we did linear, I explained inverse on how it works, that the domain of f of x is going to be the range of what? Of F inverse, and the domain of F inverse is the range of f of x, right? So we know the fact that we're looking for the domain of F inverse, and we given what? We given f of x. So therefore we need to find the range of f of x. Because of this, we know the fact that the range, right, of f of x is actually what? Is actually the domain of F inverse. Right, and what do we know? We know the fact that the domain, I'm recapping notes, I already done them in linear, of f of x, right, is what? Is the range of F inverse. Right, and what do they want? They want what? They want the domain, so they want this one. They want this one. So to find this one, we need to find the range of f of x. Then we're going to write the domain of F inverse. So let's do that. Let me erase this. So let's find the range of f of x. So the range, right, of f of x, what do we need? We need a and we need q. So what is our a here? We see that our a here, right, so we have f of x, let me write it down, is equals to 3 to the power negative x, meaning here our a is actually positive 1. It's an imaginary 1, right? So it's going to be equals to 1, and 1 is what? Is greater than 0, meaning why? 1 is positive, right? Then we see the fact that we don't have a p. Our p is actually equals to 0, and also our q is equals to 0, right? It's not written here in the equation, so therefore we assume that it's equals to 0, right? So therefore my q is what here? My q is 0, so my q is going to be 0, right? So since my a is positive, my range is going to be y is what? Is greater than 0, right? So now this is the range for f of x, right? So this one is for f of x. So now to write the domain of F inverse, right, it's the same thing, but we just changed the what? The y into being an x. So the answer here is going to be x is greater than 0. And that will be your final answer for 5.3. So now let's move to 5.4. It says describe the translation from f of x to h of x. So they say the fact that describe on how the graph behaves from f to h, right? So what do we need to do? We're going to take h of x. Let me write it down. This is 5.4. H of x is equals to what? To 27. Then divided by what? By 3 to the power x, right? So here we need to simplify it in terms of exponential. So here you need to know your exponential rules, right? So let's change this. Let's change the 27 into being a factor of 27. It needs to have a factor of 3, right? So that's going to be what? 27 is going to be, is the same as 3 to the power what? 3 to the power 3, right? Then it's going to be 3 to the power x. Then we're going to use our exponential rules, which is the fact that since it's a division and it's the same base, we can subtract the exponential. So it's going to be 3 to the power what? It's going to be 3 minus x, right? So with that, I want my x to be in front, so I'm going to take it in front. So it's the same as saying 3 to the power negative x plus 3. So now we're going to take what? We're going to put everything into the bracket, right? So it's going to be what? We're going to take the negative sign outside. So we're going to say x, then it's going to be open, it's going to be negative, then open bracket, then the negative becomes a positive, and the positive becomes a negative. Since this negative x, it was negative, now it's going to be positive, so it's going to be x, and this 3 is going to become what? A negative, so it's going to be negative 3, then close the bracket, right? So now I'm going to compare it with f of x. So we know the fact that f of x is equals to what? To 3 to the power negative x. So what is the difference here? We see the fact that here it didn't have a p-value, right? And here there's a p-value of negative 3. So we see the fact that my p-value is what? Is equals to negative 3. So I'm going to say since, and remember what p does. P moves the graph are left or right. So since, right, P is equals to -3, right, therefore h of x, right, moves the graph moves 3 units. It's going to move 3 units to the right. Remember, it's because of P is what is less than 0. That is why it's going to move to the left, right, to the right. But if P was positive, right, then it was going to move to the left. So remember, when we started doing the effect of how P affects the graph, this is where I got my answer. Since P is negative, right, the graph is going to move to the right. So that is why I say since P is equals to -3, h of x moves 3 units to the right. And that's your answer for 5.4. Now let's move to 5.5. It says determine the value of x where h of x is less than 1. So we know the fact that h of x, right, is less than 1. So what we're going to do is we're going to substitute h of x. Remember from the previous question, we solved h of x to being what? To being equals to 3 to the power negative open bracket x minus 3, right? So we're going to substitute it here. So we're going to say 3, right, to the power negative, then it's going to be x minus 3 is less than 1, right? So now what we're going to do is we're going to solve for what? We're going to solve for my x. So what do we know about 3? We know the fact that anything to the power of 0 is going to give you 1, right? So what we know about 1, not 3, is that anything to the power 0 is going to give you 1, right? So I can change this one into being what? 3 to the power 0. So I'm going to say 3, then it's going to be x minus 3, then it's going to be less than 3 to the power 0. So since we have the same base here, I can drop them and take the exponent and equate it to each other. So now we're going to have negative open bracket x minus 3, right, is less than 0. That's what we have. So I'm going to distribute the negative. So it's going to be negative x, then it's going to be plus 3 is less than 0. Take the 3 to the other side, so it's going to be negative x, right, is less than what? Less than negative 3. Since it's negative and I want them to be positive, I want my x specifically to be positive, I'm going to divide everything by -1. So here we're going to have x. Since I'm dividing by a negative number, my inequality changes, so it's going to be greater than positive 3. So your answer is that x is greater than positive 3, and that will be your final answer. So now let's move to 2019, right? It says sketched below is the graph f of x is equals to k to the power x. Then they tell you the fact that k is greater than 0, meaning k is positive. Then they say the point 416 lies on f of x, right? So 5.1, it says determine the value of k. So what do we know? We know the fact that f of x, right, is equals to what? To k to the power x. And what are we given? We're given an extra point. So we can substitute this point to solve for my k. So let's substitute it. So f of x is going to be 16. Then my k, then to the power 4, right? So we can put the root of 4 on both sides to solve for k. So let's do that. So it's going to be 4 root 16, right, is equals to 4 then k to the power 4, right? So this one is going to give you what? Plus or minus 2 is equals to k. The reason why it's plus or minus because of the exponential, the root that we're using here, right, is an even number. That's why it's what? That's why it's plus or minus. So, but since they told us the fact that k needs to be greater than 0, meaning k needs to be positive, therefore making my k equals to 2. So your k here is equals to, so your k here is equals to 2. So now moving to 5.2, it says graph G is obtained by reflecting the graph f about the line y is equals to x. The minute they talk about the reflecting the line about y is equals to x, we're looking for the inverse. So we're looking for inverse here. right? Then they say determine the equation of g in terms of y. So what we're looking for the inverse of f of x. So we know the fact that f of x is equals to what? Is equals to k, and our k is 2. So it's the same as 2 to the power x, right? So we're looking for the inverse. So let me rewrite it in terms of y. So it's going to be y is equals to 2 to the power x. So we're finding the inverse. So now we need to make y the subject of the formula. So remember that y is going to be on the other side of the equal sign. The 2 is the base. Then this one is next to the log, right? So it's going to be y is equals to what? Is equals to log. Then base is here, which is our base here is 2. Then it's going to be x. So therefore making my g of x equals to what? To log base. Then the base is 2. Then it's going to be x. So that's going to be my g of x. So now let's look at 5.3. It says sketch the graph G, indicate the graph's coordinate of the 2 points, right? So the 2 point is this 2 point. Remember the fact that G is what is the inverse of f, right? So whatever this 2 coordinate, we're just going to interchange what? We're going to interchange its x and y. So the one for G, I'm going to write the coordinate here. So since here is 4 to 16, then for G is going to be 16 to 4, right? And since this one is 1, it's what? It's 0 and 1, right? So this one is 0 and 1. When we change it, it's going to be what? It's going to be 1 and 0, right? So we know our 2 coordinates. So let's sketch it now. So the first one is what? It's 1 and 0. So it's going to be somewhere here. So this is going to be the first. This is negative. Positive is going to be here. Let me just connect it here. So it's going to be 1 and 0. So it's going to be here. So let me just do it in pink. It's going to be here. Then the other one is 4 and 16. So 1, 2, 3. It's going to be 1, 2, 3, 4. Let's say 4 is here because we're sketching, and 16 is over here. So the g of x is going to be something like this, right? So this is the sketch. So we know the fact that here is 1, and here this point is going to be what? It's going to be 16 and 4. So this is how g of x is. So this is g of x, right? So now moving to what? To 5.4.1, it says use the graph to determine the values of x for which f of x multiplied by g of x is greater than 0. So what does that mean? It means the fact that, let me just go up. They said what? F of x multiplied by g of x, right, is greater than 0. Meaning when we take both graphs, when we multiply them together, we need to get a positive. So when can that happen? Is when f of x is positive, right? And also g of x is positive, which is when we multiply them together, we're going to get what? We're going to get a positive. Or when f of x is negative, then also g of x is negative. When we multiply them together, we're going to get what? A positive. So now I'm going to sketch what? I'm going to sketch what you call as f of x here, because we're going to need it when we answer the question. So it goes through one like this. So we know the fact that the black one is f of x, right? So what does it mean? We mean the fact that we need where both graphs are on the positive y-axis, or when both graphs are on the negative y-axis. But before we do that, we need what? We need our x-intercept. So we know the fact that we only have one x-intercept, which is this one. So I'm going to put a line going through it like this. Then we need to write what? We need to write our negative infinity and positive infinity, because it's going to help us with writing the answer, right? So what do we see? We see from negative infinity till the x-intercept, which is 1. What do we see? We see the fact that f of x, the black graph, is on the positive y-axis, right? And the pink graph, which g of x, is on the what? Is on the negative y-axis. So when we multiply them together, a positive and a negative is going to give us what? It's going to give us a negative. So this one does not contain our answer that we want. It doesn't fulfill the restriction, right? But what do we see? We see from 1 till positive infinity, right? That both the black and pink graph are on the what? On the positive y-axis. So what do we know? We know from here, from 1 till positive infinity, both our graphs are what? Are on the positive y-axis. So our answer here is going to be what? It's going to be x. For 4.2, let me just write it here. It's going to be that x is an element, right? From where? From 1. The reason why it's a curly bracket, because of it didn't say equals to, it just said less than, it said greater than, right? Then it's from 1 till what? Till positive infinity. So this will be your answer when x is between 1 till positive infinity, or you can write it the effect that and say x is what? Is greater than 1. So both of the answers are acceptable and both of them are correct. Then now we're going to move to 5.4.2. It says when g of x is less than and equals to 1, right? So let's solve that. So it's going to be g of x, right? So it's going to be g of x is less than and equals to 1. So we're going to substitute g of x that we solved. We know the fact that g of x is equals to what? G of x is equals to log, right? Log 2x is less than and equals to 1. Right, so what we're going to do, we're going to solve for what? We're going to solve for x. So to do that, the first thing that we need to do is what? We need to make x the subject of the formula. So let's do that. So we know the fact that this one is our base, right? And this one is going to be on the other side, the equal sign. And this one is going to be the exponential, right? So we're going to say what? We're going to say 2 to the power 1 is going to be what? It's going to be, then it's going to face what? It's going to face the exponential. So it's going to be less than, it's going to be greater than, and equals to x, right? So let me rewrite it again so that you guys can see how the inequality looks, right? Remember in the question, the inequality faced where? It faced on the number, right? So when you change it into an exponential, it still needs to face the number. It still needs to eat the number. That's why it's facing the 2. So this to the power what? This is negative 1, guys. I'm sorry, this is negative 1. So this is going to be to the power negative 1. See by the equation is g of x is less than and equals to negative 1. So it's going to be to the power negative 1. So therefore 1 over 2 is greater than and equals to x. Right, are we okay? Then with that said, what do we see? We see the fact that our graph is less than and equals to 1 when x is less than and equals to a half. But where does it start? We see the fact that we have an asymptote here at 0. Do you see this line? Right? It's the asymptote. The graph never touches this line, meaning the graph never goes beyond this. So if we leave this answer like this, what do we mean? We mean the fact that the graph exists where? From the negative x-axis, and the graph does not exist there. So our answer here is from where? Is from 0, right? Is less than. The reason why 0 is not equals to is because of 0 is the asymptote, right? Then we're going to say x, then it's going to be less than and equals to 1 over 2. So this is how your answer is, because of what? Because of the asymptote. So now moving to the last question, it says if h of x is equals to f, then open bracket negative x, close bracket, then calculate the value of x for which h of x minus h of x is equals to 15 divided by 4. So we know the fact that h of x, right, is equals to what? To f negative x. What do we know? We know the fact that f of x, we have that f of x is going to be equals to 2 to the power x. That's what we know, right? So we know the fact that h of x is the negative of f of x. So therefore, if I find h of negative x is the same as finding it 2 to the power negative x. And that's going to be equals to h of x. So therefore, h of x is equals to what? Is equals to 2 to the power negative x. Right, so that's what we know. So we're looking for what? We're looking for h, not h. We're looking for f of x, right, minus h of x is equals to 15 divided by 4. That's what we're looking for, right? We're solving for x. So let's substitute h of x and f of x, right? So we know the fact that f of x is going to be 2 to the power x, then minus what? Minus 2 to the power negative x is equals to 15 divided by 4. So this one, let's change it into a positive exponent. So it's going to be 2 to the power x minus 1 over 2 to the power x is equals to what? Is equals to 15 divided by 4. The minute you see something like this, right, is that remember the fact that if you see the fact that these two are the same, let me circle them. You see the fact that these two are the same, right? And we need to solve for x and it looks like this. Remember the fact that you need to let k. So when you see a situation like this, remember to let k. So let's do that. So I'm going to say let k equals to what? 2 to the power x, right? So I'm going to say k minus 1 over k, right, is equals to 15 divided by 4. So now I want to get rid of the k in the denominator, right? So I'm going to basically get rid of this k. So I'm going to multiply this k here. So it's going to be k multiplied by k minus here is going to be minus 1 is equals to what? To 15, right? Divided by 4 multiplied by what? By k. Simplify this, you're going to have k squared minus 1 is equals to what? To 15 divided by 4 k, right? So now let's get rid of the 4. So it's going to be what? Multiply this 4 here and here. So you're going to have, we need to multiply it. So it's going to be 4k squared minus 4, right? It's going to be equals to what? To 15k. Take the 15 to the other side. So you're going to have 4k squared, right? Then it's going to be minus 15k. Then it's going to be minus 4 is equals to 0. What do you see? We see the fact that this is what? This is factorization, right? It's a quadratic formula. So now what I'm going to do is I'm going to solve for x here. So I'm going to solve for x. What you can do is I'll link the video where I do a video of mastering factorization. So I'll link it up. It's a very good video. Go check it out if you can factorize. So what you're going to get when you're done factorizing is going to be 4k, right, plus 1. Then it's going to be k minus 4 is equals to 0, right? So what we're going to have, 4k plus 1 is equals to 0, or we're going to have k minus 4 is equals to 0. So for k, so it's going to be 4k here is equals to negative 1. Therefore, k is equals to negative 1 over 4. Or we're going to have what? K is equals to positive 4. That's what we have, right? So we know the fact that k can never be a negative value. There isn't any value that's negative. So before me talking about that, emphasizing the fact that k can never be negative, let's substitute. So we know the fact that 2 to the power k, remember the fact that k was what? Let me go up. K was 2 to the power x. We're still solving for x. So you're going to say 2 to the power x is equals to negative 1 over 4. Remember the fact that k, what you call this, your exponential, this y value can never be negative number. So this is unapplicable. So you can't solve this. My y value can never be negative. It does not exist on the negative y-axis. So now let me solve this one. It's going to be 2 to the power x is equals to 4 because that's k, right? So I can change this 4 into having the same base as 2. So you're going to say 2 to the power x is equals to, finding the factors of 4 is going to be 2 to the power 2. Drop the base because they are the same. So x is going to be equals to positive 2. So for this question, right, is that for this question, last question, is that now my x here is going to be equals to what? It's going to be equals to 2. And that will be your final answer. So now let's move to 2017, question 5. It says the diagram below shows a graph g of x is equals to 2,
divided by x plus p plus q, and it says f of x is equals to the log 3. What do we see? We have two graphs. One is a hyperbola and one is an exponential. More information, they tell you the fact that y is equals to -1, which is the horizontal asymptote for what? For g of x. And they tell you the fact that b, which is 1 is to 0, is the x-intercept for f. They also tell you the fact that a, which is t is to 1, is the point of intersection between g of x and g. And they tell you that the vertical asymptote of g intersects with the x-axis at E, right? And the horizontal asymptote at D. Then they tell you the fact that OB is equals to BE. So now, moving to the first question, it says, write down the range of G. So 5.1, it says it wants the range of G. So what does it want? It wants the range of what? Of the hyperbola, right? So finding the range of the hyperbola, you need what? You need your horizontal asymptote. So our horizontal asymptote is y is equals to -1. So our range is what? Is y is an element of real numbers, but y is not equals to -1. It's not equals to the asymptote. So it says the fact that the graph exists everywhere besides at the asymptote, which is y is equals to what? To -1. So now moving to 5.2, it says determine the equation of G. What do we see from G? We are missing P and Q. What do we see? We already have Q, right? Our Q is what? Our Q is our horizontal asymptote, which is -1, right? So what do we need to find? We need to find our P. What do we know about our P? They told us the fact that what you call this E, right, is the x-intercept. It cuts through, it says the line, which is this line. Let me just highlight it so that you guys can see it. Do you see this line? It cuts through by E, right? And meaning the fact that if it cuts through by E, meaning E and D share what? Share the same what? Share the same x-coordinate. This D line is a point where the horizontal and vertical asymptote share. So this coordinate is P is to Q. We already know what's Q. It's already -1. We need to look for P, meaning we'll be looking for the x-coordinate of D. I hope I'm making sense. So that's what we're looking for, right? So with that said, what do we see? We see the fact that they gave us extra information. This one, they told us the fact that OB is equals to what? To BE. So let me change this color so that we can fill in that information. So we know the fact that this one and this side, so this whole thing, right? Let me change the pen, it's too thick. And this whole portion are equal. So this and this are equal. So we know the fact that the length from OB is what? Is 1, right? So meaning also the length from BE is going to be 1, making our e-coordinate what? 1 plus 1, which is 2. So it's going to be 2 is to 0, right? So the coordinate for E is 2 is to 0, meaning the fact that the coordinate of D here is going to be 2. Right? So knowing the fact that here the P is 2, what do we know? We know the fact that to write it in this form, we need to equate this 2 into 0. We need to equate this 2 into x, right? So we know the fact that it's going to be x is equals to 2, right? Then we need to reverse it, so it's going to be x minus 2 is equals to 0. So this one is the one that goes here, where I put a star. So now writing g of x is going to be g of x is equals to what? Is equals to 2 divided by x minus 2 minus 1. And that's the equation for what? For g of x. So now looking at 5.3, it says calculate the value of t. So t lies at a, right? What do we see about a? A is the intersection between g of x and f of x. So to solve for a, I can take either g of x or I can take f of x. So I'm going to take f of x. So for 5.3, so I'm going to take f of x is equals to log 3x, right? So I'm going to substitute my a. So it's going to be 1 is equals to log, right, 3 than t. Then we're going to solve for t. Remember, this is the base, this is the exponent, and this is the one that's going to be on the other side of the equals to. So it's going to be t is equals to 3 to the power 1. Therefore, implying that t is equals to just 3. So our value for t here is 3. So now we're going to move to 5.4. It says write down the equation of f inverse, right? Then they say in a form of y. So we know the fact that f of x, right? So we know the fact that this is 5.4. We know the fact that f of x is equals to what? To log 3x, right? So to find f inverse, you just take the base, so it's going to be 3 to the power x, or you can do it as I've been doing it previous question, interchange them. Start by changing f of x into y, then interchange them, then solve for our y. But this is the simplest way. Just look at the base, then you're just going to put a power of x, then that's going to give you your f inverse. So now moving to 5.5, it says for which values of x will f inverse be less than 3. So we're looking for f inverse, right, is going to be what? Less than 3. Let's substitute our f inverse as we've calculated in the previous question, which is 3 to the power x is less than 3, right? So now since the bases are the same and this is the same as to the power 1, drop the base and equate what? Equate the exponent. So it's going to be x is less than 3. And this is the final answer, but in the memo they wrote it like this, which is exactly this, honestly, is that x is from where? Is from negative infinity till 1. And it's a curved bracket. X is an element, from negative infinity till 1. This is the same thing as what I just wrote here. So either if you write this one, you're correct, and if you write this one, you're correct. So this is 5.5. So now moving to 5.6, it says determine the point of intersection of the graph G. So we're looking for the point of intersection of the graph G. So this is 5.5 of the graph f of x, not G. F of x is equals to the axis of symmetry. So we're looking for the axis of symmetry, the -1, right? So we're looking for a point where these two are intersecting, the negative, then the of G that has a negative gradient. So that's why I'm writing negative in bracket. So the negative gradient, right? So what do we need to do? We need to find first what? We need to find the negative gradient of the graph G, of the axis of symmetry. So let me say axis of symmetry, the negative gradient. So we know the fact that it's y is equals to negative x plus c. This is the equation for the negative gradient. Then to solve it, what do we need? We need the point, right? The point, so that we can solve for c. That point is what? Is actually the point D, right? Which is this coordinate of P to Q. Right, we saw the fact that when we're calculating, we saw the fact that our P, we take it from here, which is we know the fact that from here, which is we know it's x minus 2 is equals to 0. Then it's going to be what? It's going to be x is equals to 2, and this 2 is going to be your P. So here it's going to be 2 is 2. Then your Q, you take it exactly, which is -1. So you're going to take this coordinate, so we're going to substitute, right, this coordinate of 2 and -1 into the negative gradient. When we substitute that, it's going to be -1 is equals to negative, then it's going to be 2 plus c. Take the 2 to the other side, it's going to be -1 plus 2 is equals to c. Therefore, it's going to be 1 is equals to c. So rewriting this equation, it's going to be what? It's going to be y is equals to what? Is equals to negative x plus 1. So we see the fact that our gradient is -1, right? So now what we can do is that before solving, we can actually like roughly sketch this point, right? So to roughly sketch this point, we know the fact that the y-intercept, right, is going to be what? It's going to be the c. So it's going to be 0 and c. What is our c? Our c is 1. So it's going to be the same as what? As 0 and 1. So know the fact that the graph, the y-intercept is going to be what? It's going to be 0 and 1. So now the x-intercept, right? We need to let what? We need to let y equals to what? Equals to 0. So it's going to be the same as 0 is equals to, let me go a little bit up. It's going to be 0 is equals to negative x plus 1. Take the 1 to the other side. So it's going to be negative 1 is equals to negative x, which is the same as x is equals to positive 1. So our what? Our x coordinate here is going to be, our x-intercept, sorry, is going to be 1 is to 0, right? So if I had to sketch it roughly here, let me just... So if you had to sketch it now, you know the fact that it's 1 and 0. That's going to be here, right? Let me just do it on purpose. It's going to be here for x-intercept. And our y-intercept is going to be here. So the graph, which is the purple one, is going to go like this. And that's going to be the axis of symmetry, right? And it makes sense the fact that it cuts through D2. So what is a point where f of x, remember f of x is equals to the axis of symmetry, we see the fact that it's this point B, right? So the point B is actually what? Our point of intersection. So what we're going to say is that point B, let me just write it down, point B, right, is the point B, sorry, is the intersection, right, between f of x, right, and a negative gradient, or you can just write it f of x, and let me just write the equation of the negative gradient, and y is equals to what? To negative x plus 1. And that point, or you can also write the fact that the point of intersection is B, right? Then you can just write it's 1 is to 0. Then you are done with this question. So now let's start with 2016. It says sketch below is the graph h of x that is equals to a to the power x. Then they tell us that a is greater than 0, meaning our a needs to be positive. Then they say point R is the y-intercept of what? Of h. Then they say the point P, open bracket, 2 is to 9, and Q, B is to 1 over 81 lies on the graph h of x, right? So they say write down the equation of the asymptote for h, right? So what do we see? We see the fact that h does not have a p and it doesn't have a q, right? And the exponential graph has only one asymptote, which is the horizontal asymptote, right? So we know that the horizontal asymptote, so 4.1, we know that the horizontal asymptote is going to be what? Is y is equals to q. And what is our q here? Our q is what? Is equals to 0 from the equation. So we see the fact that there isn't a p and there isn't a q. So our q here is equals to 0. So therefore implying that y is equals to 0. So this will be your horizontal asymptote. Then now we're moving to 4.2. It says determine the coordinate of r. What is r? R is the y-intercept of the exponential, right? So something that I need to tell you, and I think I did point it out in one of the questions, is that if you have a graph, right, if you have an equation like this and it's standard, it does not have a p or it doesn't have a q, right? The graph is not affected at all. So there isn't any movement. It's just that it's h. It's what you call, it's just a to the power something, right? Meaning it can be 2 to the power x or any number. If it does not have a p, right, and it doesn't have a q, the y-intercept always is what? It's going to be 0:1. So here our r is going to be what? 0:1. Let me repeat that again, right? If you have an equation, right, of an exponential, and it does not have a p, meaning it doesn't have any vertical shift, right? Or it doesn't have a q, meaning it doesn't have any horizontal shift, your y-intercept always is going to be what? It's going to be 0:1. So therefore making r being 0:1. So now moving to 4.3, it says determine the value of a. So we have the fact that h of x, right, is equals to what? To a to the power x. What do we see? They gave us the coordinate p. So we're going to substitute the coordinate p to solve for what? For a. So that's what we're going to do. We're going to substitute this coordinate p. So let me just say sub p, meaning I'm substituting p. So which is going to be 2:9. Right? So when we substitute it, it's going to be 9 is equals to what? 9 is equals to a to the power 2. Right? So now we're going to square both sides. So it's going to be √9 is equals to what? 2 root a squared. So your answer is going to be plus or minus 3 is equals to what? Is equals to a. So what we're going to pick, they tell us in the question the fact that a needs to be positive. So therefore my a is equals to 3. And that will be your answer for 4.3. So now let's move on to 4.4. It says D is a point such that, right, PQ is parallel to the y-axis. So let me just write the line. So we know the fact that DQ is parallel to the y-axis, meaning this and this are parallel to each other. And they say DP is parallel to the x-axis, meaning this. That's what they mean. This line are parallel to each other. So that's what it means. Then they tell us the fact that what? Calculate the length of DP. So that's what we're going to do. So first, we see the fact that they want which length. I'm going to highlight it in orange. They want this length, right? And to calculate that length, what you need two coordinates, right? You need the P and you also need D. So what do we see? We see the fact that D is unknown, right? So now we need to find the coordinate of D. So there is relationships amongst this parallel line situation that's going to give us the coordinate of D. So the first one that we're going to discuss is the x coordinate for D, right? So what do we see? We see the fact that the x coordinate for D and the x coordinate for Q is the same, right? So D and Q share what? Share the x coordinate, meaning here the coordinate for D, the x coordinate is going to be B, right? And what do we see? We see the fact that B is unknown. So what can we do? We can first solve for B, then that's going to be the coordinate for the x coordinate for what? For D. Then what do we know? What is the another information that we see? We see the fact that the y coordinate of D and the y coordinate of what? Of P is the same, right? So meaning they share the y coordinate. And what do we see? We see the fact that P, the y coordinate is 9, therefore making the y coordinate of D what? Making the y coordinate for D what? 9 2. So now we need to solve for what? For P, for B, so that we can have the entire coordinate of what? Of D. So let's do that. So let me just write down everything that I just said, right? So I just said the x coordinate and the x coordinate of Q is the same. So if they are the same, meaning the fact that xd is equals to xq, right? Which is equals to what? To b, right? So now we need to solve for what? For b. So solving for b, we know the fact that we're going to have h of x, and we're going to substitute the 3, so it's going to be 3 to the power x. Then we're going to substitute the coordinate q, right? So when we substitute the coordinate q, remember it's going to be what? Q was what? Was b is 2 1/81, right? So substitute that. Let me just say substitute that. So it's going to be 1/81, right?
is equals to what? To 3 to the power what? 3 to the power b. So now I'm going to do what? I'm going to find the factors of 81. So it's going to be the same as 1 divided by 3 to the power 4 is equals to 3 to the power b. Take this into being a exponential, right? Change this into being like an exponential, but without being a fraction. That's what I mean. So it's going to be what? It's going to be 3 to the power negative 4. Then it's going to be equals to 3 to the power b. So since the bases are the same, we can drop the bases and equate the exponential. So it's going to be negative 4 is equals to b. So now we know the fact that x d is equals to negative 4. With that said, we know the fact that what? Let me just go back to the picture so that you guys can see it. So going back to the pictures, we know the fact that d is what? Let me just write it down here so that when I move, we see the fact that d is what? B is to 9, right? So therefore, making my d here, my d coordinate what? Is going to be b is to 4, right? So they say they want the length of what? They want the length of dp, right? In the equation. So we know the fact that the p coordinate there is what? The p coordinate is 2 is to 9, right? So now we have both the coordinate, which is now d. When we substitute the value of x, it's going to be what? It's going to be d is to what? Is to negative 4 is to 9, right? So now let's find the length of what? Of dp. So we know the fact that dp is going to be equals to us the square root, right, of x of d, right, minus x of p all squared plus y of d minus y of p all squared, right? So substitute my x and y. So it's going to be the square root, right? Then it's going to give you negative 4 minus 2 all squared plus it's going to be 9 minus 9 all squared, right? So now when we punch this into the calculator, we're going to see the fact that dp is equals to 6. So your answer is going to be 6 units. And that's your answer for what? For 4.4. So now let's move on to 4.5, right? It says determine the value of k for which the equation of h of x, right, plus then open bracket x plus 2 plus k is equals to 0. Then they say we'll have a root that is less than 6. So we see the fact that here we want the root when it's less than 6, right? And also we're looking for the values of k. So now let me just write it down. So 4.5, it says h of x, right, plus 2, right, then plus what? Plus k is equals to 0. So we're looking for what? We're looking for this value k when what? When the roots are less than 6. So what do we need to know first? We need to determine what is k. K from this equation, right, is going to be what? It's going to be your q, meaning k is what? Is your asymptote. Also, it's your what? It's your horizontal, right? It's your horizontal asymptote, meaning that it moves the graph up and down, right? So before starting with anything is that we need to take k to the other side. So it's going to be h of x, right, plus 2 is equals to negative k, right? So with that said, another important thing that we need to figure out is that they do tell us when the root is what? When the root is negative 6, right? So now we need to solve when the root is negative 6, meaning we need to substitute negative 6 into h of x. But first we need to find what is h of x. So h of x plus 2. So we know the fact that h of x plus 2 is equals to what? Is equals to 3 to the power y to the power x, right, plus 2. So this is h of x plus 2 inside the bracket. So now I'm going to substitute what? I'm going to substitute this h of x plus 2 here. So it's going to be 3 to the power what? X plus 2 is equals to what? To negative k, right? So now, very important, Ane, very important, is that we need to find when the root is less than what? Less than 6. The root what? See this root. This root means x. Root means the x coordinate, right? So now I'm going to substitute when h, right, is negative 6 plus 2. So that's what I'm going to substitute. So let's do that. It's going to be 3. I'm doing it separately, and you're going to see why. So it's going to be negative 6 here plus 2. Punch that into the calculator. You're going to get it's going to be 1 over 81, right? So when it's 1 over 81, we know the fact that h, right, h of x plus 2, right, is equals to this value. And we know the fact that that happens when k, so we know we have calculated when h is negative 6, less than negative 6, meaning now our k needs to be what? Less than 1 over 81, right? Because of that's what they told us. And another thing is that since k is the what? Is the asymptote, right? The graph never goes below 0. So it needs to be what? This is negative k from here. So it needs to be between what? It needs to be between negative k, solving it, taking it, right? It needs to be between less than 1 over 81, the first thing. Then again, it needs to be between 0 because of the asymptote, right? Because of our k, as I said, can never be below because of there's an asymptote, and that asymptote is 0. Right, so now our k, since it's negative, and the reason why it's negative is because of I took it from here, right? Since our k is negative, right, I need it to be a positive, so I'm going to divide everything by negative 1. So it's going to be negative 1, negative 1, and negative 1. When you divide by negative 1, the inequality changes. So this one's going to be 0, but the inequality is going to change facing that side. Then this is going to be a positive. Then the inequality is gonna face the other side. Then this is gonna be negative 1 over 81, right? So now I need to rewrite the inequality properly. So it's just saying negative 1 over 81, right? Then putting the k in between, then 0. And this will be your answer. That k is between negative 1 over 81 and 0. So now let's move to 2015. It says given f of x is equals to 2 to the power x plus 1 minus 8. Then the first question, which is 4.1, it says write down the equation of the asymptote. Remember the fact that with exponential, there is only one asymptote, which is the horizontal one. And that one says y is equals to q. So what is our q? Our q here is negative 8. So therefore, my y is going to be equals to negative 8, right? So the first one. Then the second question says sketch the graph if clearly indicate all the intercepts, right, with the x's as well as the asymptote, right? So what do we need to do? We need to find what my x and y intercept. Then we need to determine my a, right, and the value of b so that we can know the shape. So let's start with the intercepts, right? So my x-intercept is, and we know the fact that to find my x-intercept, we need to let y equals to 0, right? So now wherever we see f of x, in our case, we're going to substitute by 0. So it's going to be 0 is equals to 2 to the power x plus 1, right, minus 8. Take the 8 to the other side. It's going to be 8 is equals to what? 2 to the power x plus 1. Change 8 into being a factor. So it's going to be 2 to the power 3 is equals to 2 to the power x plus 1. Drop the bases because they're same and equate the exponents. So it's going to be 3 is equals to x plus 1. Take the 1 to the other side. So it's going to be what? It's going to be 2 is equals to x. So therefore, making the x-intercept coordinate being what? Being 2 is to 0, right? So now, let's solve for what? Let's solve for the y-intercept. So y-intercept right? We know that we need to let x be equals to 0. So it's going to be what? Wherever here I see what? Wherever I see x, I'm going to substitute it by 0. Then I'm going to change the f of x being y. So it's going to be y is equals to 2 to the power y, 2 to the power 0, plus 1 minus 8. Punch this into the calculator. You're going to get your y as being what? As being negative 6. So here the coordinate is going to be what? It's going to be 0 and negative 6, right? So now since we're done finding the x and y intercept, right, which is I wrote it here, right, is that now we're going to determine the value of a, right, and also the value of b to give us the shape. So what do we see? We see the fact that a is equals to what? Is equals to 1. Remember, after here, this is multiplied by a. Remember the fact that it's a. The general form is y is equals to a multiplied by b to the power x plus p plus q. So here our a, because of there isn't any number multiplying by 2 here, right, is that our a is going to be 1. Since our a is positive 1, what do we see? We see the fact that anything that's positive 1, our shape is going to look like this. Before writing the shape of a, let me do b first, because b is the one that's going to determine the shape of a, right? So the value of b here is what? Our value of b here is positive 2, right? So it's going to be equals to 2. Remember the fact that with b, right, it's either it needs to be greater than 1, or b needs to be between 0 and 1, or b needs to be a fraction. Since our b is greater than 1, then our shape is like this. So our shape is increasing, right? So since our shape is increasing, if you're watching this video and you went straight to the question, I would advise you to go back and actually look at the notes first, then come and do the question, because it becomes easy when I'm explaining everything, because I've already explained this, right? Since it's like this, and now we know the fact that our a is greater than 0, meaning it's positive, so the shape is going to remain like this too. So this is the shape that we're looking for, right? So now let's sketch it, right? So when we're sketching it, it's going to look like this. So it's going to be the Cartesian plane. Then I'm just going to make it a little bit up here. I'm going to make the y-axis a little bit up because the graph is fairly down. So now we see the fact that we have what? Sorry. We have the horizontal asymptote, right? So we need to fill in first the horizontal asymptote. So let's go up. We saw the fact that our horizontal asymptote is y is equals to 8. So let me just finish the Cartesian plane, right? So we're looking for negative 8, right? So it's 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Let me go a little bit down. Negative 7 and negative 8. So this is negative 8. So this would be your what? I'm going to do it in pink. This would be your asymptote. So this is where the graph does not touch. So it does not touch by this point. Alright? Then what do we know? We know the fact that let's start with the y-intercept, right? Which is this one. It's 0 and negative 6. So it's going to be what? It's going to be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So it's going to be negative 6. Then I'm going to put a point here. Then now what we're looking for? We're looking for the x-intercept, which is 2 0. So it's going to be 1. It's going to be 2. So it's going to be here. So the graph cuts here. Then our shape is going to look like this. It's going to be a tail on the negative side. Then it's going to cut through here. And this will be your graph. Do you see the fact that this graph and this graph are the same? And this is how you would sketch the graph. So this is the sketch of the graph. So now moving to the last question, which is 4.3. It says the graph G is obtained by reflecting the graph F in the y-axis, right? Then they say write down the equation of G. When something is reflected on the y-axis, right, it's going to affect what? It's going to affect the, the sign of the x, right, is going to change. So what do I mean is that reflection, right? So reflecting, let me just write notes for both of them. So reflecting, reflecting on y-axis, comma, sine of x changes. Then remember the fact that reflecting on x-axis, right? Then sine of y changes. Then I'm going to do this one, but I'm going to write it in pink, right? So let's answer the question because it says reflecting on y. It says reflecting on what? On the y-axis. So we see the fact that g of x, right, is going to be equals to, from the original equation, we know the fact that f of x is equals to what? Is equals to x plus 1 minus 8. So it's x, the x is positive now, on the f of x is positive, so meaning the g of x, it's going to change the sign, meaning since it was positive, it's going to become negative. So it's going to be what? It's going to be 2 to the power negative x plus 1 minus 8, right? Then for the second one, because I said I'm going to do it in pink, I said when it's reflecting on the x-axis, it's going to affect the what? You need to change the y, what you call the sign of y. So if we say g of x, right, is equals to what? Is equals to 2, then it's going to be minus, it's going to be positive, sorry, from the original, right? It's going to be positive. Let me write it. Remember the fact that I'm answering for the second part that I just gave you no note. So it's going to be x plus 1 minus 8, right? So it's going to affect what? If it's reflecting on the x-axis, it's going to affect y. Y is what? Y is our g of x, so this is going to be negative. But then remember the fact that g of x can be negative, so I need to take the negative to the other side, right? So I'm going to have to divide both sides by negative. So when we do that, dividing both sides by negative, this is the same as g of x, right, is equals to minus, open bracket, is going to be 2x plus 1 minus 8. Therefore, making our graph what? It's going to be negative 2x plus 1, then plus 8. So this is the reflection. The pink one is the reflection upon what? Upon the x-axis. And this is how you would answer this type of questions. But the answer for 4.3 is what? Is g of x is equals to 2 to the power negative x plus 1 minus 8. Then we are done with this question.